is a UPSC 2-year batch, a comprehensive batch completely in English. To know more about it, please check the description link. So will you be able to explain these concepts based on two lines that is present? Possibly no. Any scientist gone to the interior of the earth? We're not talking about Jules Verne books and those comedy lectures, no. Now let us see these inferences and then we will build on these concepts, how these continents have originated, how they're possibly moving. The important thing is, what are the types of rocks that we're going to study here? Let us see. We might want to talk about geomorphic processes. This is something very commonly used and a chapter in your NCERT. A landform that is created is an outcome of these processes that are going on. Some processes might be eroding them, some processes might be creating them. Soon we'll be coming with part 2 also, which is going to have the climatology. Hello aspirants, welcome to PW OnlyIAS. I'm here Harpreet Singh with a one-shot video of the part 1 of the physical geography of the world. This video is a complete knowledge which you require from the geomorphology part of the physical geography. That is part 1. Soon we'll be coming with part 2 also, which is going to have the climatology, oceanography and the biogeography part, which is very important for the physical geography, for the prelims as well as the mains. So let us start with the one-shot video for the physical geography. Before we start, please remember, we have the Pinnacle 2027 batch. This is a UPSC 2-year batch, a comprehensive batch completely in English, which prepares you well for the prelims, mains as well as the interview. To know more about it, please check the description link. So let's begin with the one-shot video, part 1 of the physical geography of the world. You all were eagerly waiting for the physical geography series on this particular channel. So here we are, based on your demand, we have come up with a physical geography of the world. Now please remember, though this is a complete NCERT series, this is not limited to NCERT. Why? Please understand this very, very carefully. There are various instances when students ask me that, sir, just tell us one thing, that when we read the NCERT, is this completely okay or is it enough for even the mains examination? I always tell them, yes, the NCERT is from the foundation, but merely NCERT will not help you to qualify this examination also. So there is a small gap between the NCERT and the mains and as well as the prelim examination. So how can you basically fill that gap? So while we are doing NCERT, we are going to fill that gap also. Now understand how. I'll be giving you an example in order to comprehend this concept, what I'm saying. So in order to download the notes which we completely write on the board and the description that we give, so for that you will have to enroll in this free batch, and please for that click on the description link given below, by which you can enroll in the batch and get access to all the notes what we write on the board. See here. Whenever we read the NCERTs, let us take the example of chapter number 2, which talks about the origin and evolution of the earth. It mentions certain things like, it mentions about Immanuel Kant, it mentions about Laplace and a brief description, it talks about Otto Schmidt and so on and so forth. Now when you're reading the NCERT, this is the foundation. But in the examination, if they ask you, give certain theoretical concepts for the origination of the earth, other than the Big Bang Theory, or even Big Bang Theory can also come. So will you be able to explain these concepts based on two lines that is present? Possibly no. But this is the foundation, because when UPSC picks up the question, they pick it up from these NCERTs itself with respect to the static questions. But when you do not know the details, that is the point where you are stuck and not able to answer in your mains examination. So what I'm going to do in this series, every single word that is mentioned, which requires explanation, which is expected from you when you're reading the NCERTs, to have it in detail in your mind. So I have done this, like Gaseous hypothesis by Immanuel Kant, Nebular hypothesis by Laplace, and every single concept that is mentioned in the theoretical form but not explained, I have done that also. So your gap between the NCERT and what is required is being filled by this particular series. So it is covering NCERT, but in every possible manner, that when you are watching the series, you will be in a state after the series that you can appear in the prelims as well as the mains examination with full confidence. Secondly, as a trademark, every single thing has been written on the board or drawn on the board by hand. Now, when you read these theories and all, the possible thing comes is, sir, geography requires certain diagrammatic representations. From where will we get these representations? Because when you read these theories, you hardly get these representations and how you can make by hand. Because most of the cases we see Google images, and those images cannot be simply drawn on your in your examination sheets. So I have drawn diagrams for every single theory that you are going to possibly imagine, so that by merely listening to the lecture and seeing these diagrams, you will be able to understand what the theory is. Similarly, over here, similarly, all these things, similarly, these concepts, see over here, all these theories with every possible diagram is mentioned here. Even the life cycle of a star, I have explained and done all the diagrammatic representation over here. Now, please understand this very, very carefully, that when you read about the solar system, we have all the representations here. Even when you read about the moon, there's a single statement written, big splat, for the creation of moon. But remember that, is there any diagram that you can possibly draw present in the NCERT? No. So what I have done, I have drawn this diagram also, so that in the examination, if it comes, you can draw by hand. Now you will say, sir, to what level of artistic things? You don't have to be artistic. But at least for you to remember, for you to draw, these handmade diagrams are useful, because if I am drawing by hand, possibly you can draw at a faster pace in the examinations also. Mark my word very categorically, particularly the examinations, particularly the subject like geography, if you are making use of diagrams, maps, you will be scoring really very well. And the gap which we told you that we are going to fill between what is NCERT, the reading, and what is required, because NCERT forms the base, you have to read, but the gap will be filled by this particular series. One more thing before I begin with my lecture. If you are following this series religiously, properly, making the notes out of it, not merely asking for the PDF, that give the PDF and we can simply just note it down. Please remember, there are a lot of things which I'm going to tell in the class, possibly not mentioned in the PDF. So watch the lecture very categorically, and you will be in a state where you will be able to attempt every single question in the prelims as well as the mains examination asked from these static portions particularly. If they are asked from the current affairs also, these static portions form your foundation. So keeping this in mind, keeping all the dimensions in mind, which I wanted to tell you before we begin with the series, this is the first lecture of your series, which is Origin and Evolution of Earth. I'll be beginning with the first chapter which talks about what geography is, and then we'll begin with this chapter. This is the QR code where you can basically find out or get the PDF which I am basically using on the board, which I've drawn. Along with it, related information related to anthropology optional, which I teach, along with society and social justice, and general things based for your civil services preparation. Let us begin with the concept of geography first of all. Whenever we talk about geography, the question comes, what is actually geography? Because you are reading geography related to landscape study, description of Earth, then you're also dealing with population and demography. Then the question comes, and what is geography? Let us understand first of all, concept, what is geography? Now see, the term geography was first used by Eratosthenes. He is the father of geography. Now he basically, when he used this word, it is basically derived from two Greek words. Geography. Word first is geo. This is geo means earth. Graphy basically means derived from the word graphos, again another Greek word, which means description. So according to him, geography is basically a description of the earth. When I say description of the earth, please remember, from this perspective, majorly initial phases, geography was basically being considered from the perspective of description of the physical landscapes. That means physical geography was being focused more. But with time, we realize that a discipline itself evolves. Over here, it is merely description of the earth, but we also say that there are human beings residing on the earth. There are other animals and plants also. Now, they are shaping the landscapes also. So that is why many people emphasize geography should also deal with these studies related to human beings. So that is why there were more definitions that came up, and with it resulted in various branches of geography basically arising or coming up. So that is why another definition is Earth is an abode of humans. Abode, Just a representation, like this is the Earth, I put a figure over here. That means representing that the Earth basically has a lot of human beings, obviously plants and animals. So from that perspective, how can I define geography? Geography is also defined as the description of Earth as an abode of human beings. Abode, that means human beings where they reside. Now, when I'm talking from this perspective, abode of human beings, this is focusing more on the human geography part. When you study population dynamics, when you study settlements and all, over there the focus is human-centric. That is why it is covered under the branch of human geography. So that means when we study geography, from one perspective it can be the description of Earth, from the other perspective human geography, it can be described geography as a study which deals with human beings, focusing on human beings with respect to Earth. So can I say geography deals with the study of the physical landscape description of Earth and also the humans who are residing on the Earth, right? Yes or no, as an abode of human beings? So that is why it is covering the physical geography aspect also. It is covering the human geography aspect also. Now, keeping this in mind, with that, within these physical and human geography branch, there were various branches that were created. That is why we need to study the branches of geography also. Now, branches of geography, there are a lot of branches. I will just represent a flow chart, which is more than enough for you to understand what are the various branches of geography from the perspective of general studies. Let us see. If these are the branches, see, broad division is physical geography and human geography. Along with it, there are a lot of other dimensions which have been given, like the techniques that are used. Based on that also, like for example, I'm using mathematics. In human geography part also, there are a lot of topics. Let us say there's a topic of quantitative revolution where you use mathematics or mathematical skills in order to compute certain things. So you are basically taking up that portion from statistics. So that is why we have put under the techniques. So now these broad things have a lot of further subdisciplines. Let us analyze each one of them. Human geography, if we say, there is a part known as historical geography. Now that takes its inspiration from the subject of history. Political geography, dealing with boundaries, frontiers and all, that has basically been inspired from the topic of political science. You have economic geography, right? That is inspired from the subject of economics. We have social geography, again, the topics have been taken up from sociology. You have cultural geography that takes its topics from anthropology subject. Population geography from the subject of geography, from the subject of demography. Geographical thought, that means which forms a core aspect of the thinkers, that is taken up from philosophy. Similarly, when we talk about physical geography, the topic which we are doing right now, like origin of the Earth, interior of the Earth, continental drift theories, and all these concepts, landforms and all, we broadly study under the topic of geomorphology. So this geomorphology is inspired or taken its content from what? Geology. After our geomorphology part will be complete, we'll be moving on to the climate part. That is known as climatology. Now, it has taken or inspired from what subject? Meteorology. Now, biogeography. Now, this basically is inspired from biology. Similarly, soil geography from pedology. Similarly, oceanography, which will be, when we will study them, we'll be studying the tides, currents, all the dimensions, the deposits in the interior. This has basically been taken up from hydrology. Similarly, if I go to the geographical techniques, now, this is a concept of remote sensing. That is why you realize that in General Studies Paper 1, there have been questions repeatedly on the basis of remote sensing, satellites, and all these questions have been asked. And many people say or assume, how come we are studying or why the questions of remote sensing are being asked in GS Paper 1, which deals with geography? It should be asked in GS Paper number 3, which deals with science and technology. No, the reason is that these systems or these aspects are a core ingredient of the subject of geography. That is why repeatedly with respect to remote sensing, all these things are asked by UPSC in GS Paper 1 because it is a core aspect of geography with respect to the geographical techniques. That is why when we talk about remote sensing, it has been inspired from engineering, cartography from geodesy, geographical information system, it was asked even this year, from computer science, quantitative techniques like for example, if I am dealing with a lot of things like the population calculation or statistical part, there's a paradigm which talks about quantitative revolution, where there was a phase where a lot of mathematics or statistical techniques were incorporated into geography. So that is why these quantitative techniques get inspired from statistics. So these are all the branches of geography. You can just have a look over here. I would request you to pause the video, note them down. It is a very simple part that is present in your NCERT also. Why I have drawn, I could have easily copied that or simply pasted a photograph over here from Google. But remember, I have told you, we very categorically in my particular lectures, whether I'm teaching geography, anthropology, society, social justice, I draw and write everything on the board by hand. So that is why I'm telling you, draw them, you will remember it, you will never forget it. Tomorrow, when you're reading a newspaper possibly, you will, whenever you come across the topic of remote sensing, geographical information system and related aspects, you will realize that, oh, this has got to do with geography, possibly that is important. This can be asked in GS paper 1. That is why, remember, this particular year also, geographical information system and remote sensing was asked in your general studies paper 1, because it is part of geography. Clear? Now, having done with what geography is, the branches are, so or at least foundation with respect to this subject is relatively clear. Now, we should come to the topic of the day, which deals with the aspect of the origin and evolution of Earth, right? This is a very important topic, as I've told you. Questions have repeatedly been asked in various forms, and you should be very well aware. Now, please remember one thing. When I'm talking about these theories, see, when you will be opening your NCERT, everything is mentioned over here in Immanuel Kant, Laplace and all, but they're not explained well, as I had told you in the start of the lecture also. When I'm explaining you all these theories, I will request you one thing very categorically. As previously, this channel in which I'm doing this geography series is completely free of cost for you. This is more than sufficient for your prelims and the mains examination. I'm again guaranteeing you, we are doing in a lot of detail. Obviously, you have to add the current portion. There is no doubt about it. Any current affair happenings take place, we will add that also in the other topics also. But that is something that you should update from your own. Over here, please remember, take your A4 sheet, blank sheets, whatever I'm writing on the board, whatever it is written on the board, whatever I'm explaining, note that down. That will be your consolidated notes for this particular subject. When you read them again and again, you will be a pro in this particular subject. Why I'm repeating this in the start multiple times? Because this is a lengthy series. Many lectures are going to come related to geomorphology, climatology, oceanography, biogeography, complete subject. So you should keep that in a consolidated manner. When the series is over, you will see that you have actually completed the geography subject and you are really good at it. Clear? Let's begin. So, my dear students, when you open the NCERT, you see certain theories, early theories where all these concepts are mentioned, and later on you realize Big Bang theories is mentioned. So what I've done is, I have put all of them in order in a proper manner and then Big Bang theory. So this is again the theory related to the origin of Earth, even solar system, universe also. So let us understand each one of them. Let me be very clear. The theories which you read, let us say the initial ones, even the Big Bang theory, when you read the initial theories, you will say, is it the reality, sir, Earth was formed in this way or the solar system was formed in this way? But please remember, no theory is perfect. Right now, when these theories, hypotheses basically come, these are based on the observations by certain scientists, certain thinkers, and they have presented the concepts. There are a lot of loopholes in each and every concept. So do not assume that any theory or hypothesis is present that is completely perfect. Even the Big Bang theory is full of problems. There are a lot of contradictory views also. So please remember, take it as a view, whether even it is sounding stupid over here, that how come this can be mentioned by a particular thinker, just assume that what the thinker is right now mentioning, because in the examinations also that thing is asked. Now let us begin with the first gaseous hypothesis of Immanuel Kant, then we'll move on to the other theories. Okay, first, please remember, first the concepts or the hypothesis which we read is the gaseous hypothesis of Immanuel Kant. That is 1755. If you remember the date, good. If you do not remember, doesn't matter. At least the name and the thinker who have presented this should be known by you. Now, when he gives his theory, he assumes certain things and then he gives certain statements. So So he has assumed. That means when I use the word assumption, it means I have assumed that this is correct. Whether he is giving evidence for that or not, least bothered. That is what assumption means. Whenever you do anything, you are assuming that this is the fact. So certain assumptions are made in this theory. What are these assumptions? Please note them down along with me properly. He says that there is a supernaturally created. Supernaturally, that means something that cannot be explained. Possibly saying that it existed, there is no reason, could not explain it. That is why he says supernaturally created primordial matter or cloud scattered in the universe. Now he said that primordial, something very antiquated, old, thousands and thousands, billions of years old. There was a primordial matter or a cloud that existed, that was scattered in the universe. Now, if I want to represent it, see, this is assumingly this is the cloud that was present, somewhat like this, right? A cloud was scattered. Now, please remember, this cloud is basically known as a nebula, right? We will be dealing with this concept when we will be studying the star also. But this primordial, let us say the cloud made up of dust particles and all, this cloud is known as nebula. Now this cloud is called nebula, is slowly rotating cloud of gas and matter. Over here, see, it has a lot of gases here. It has tiny particles also present over here. So what do we see? This cloud, according to the assumption that is made by Immanuel Kant, this cloud called nebula is slowly rotating cloud of gas and matter. Very slowly it is rotating, and this cloud is made up of gas and matter. And there is a particular characteristic that Immanuel Kant mentions for the nature. The matter over here, or this cloud, is basically cold, solid and motionless particles. These particles are solid in nature. It is cold in nature and motionless particles. Because it is cold, that is why motionless. Now motionless with respect to each other, though the cloud is moving, but the particles are motionless with respect to each other. That is what he is trying to tell. So don't get confused that when I am mentioning rotating but I am saying motionless, it means with relation to each other. Initially, it is motionless with respect to each other, but the cloud is slowly moving. Second assumption, there are a lot of things that have not been explained by Immanuel Kant. That is why we will not go into those concepts. Otherwise, if you write them, it will be wrong. Third is, particles start colliding against each other under gravitational attraction. Even the smallest of the particle has some gravitational pull. Obviously, the mass is more, the gravitational force is going to be more. Over here, the particles are tiny, but with time we realize there is certain gravitational pull. So one particle, let us say later stages, after this later stages, might have collided with each other. Now, these are the three assumptions that have been presented to you over here. Now, you will say, sir, this does not sound very appropriate. But beta, these assumptions are taken. That is why there are a lot of criticisms also related to them, right? So, these are the three assumptions. First is a primordial matter or a cloud was scattered in the universe. This cloud is basically known as a nebula, which comprises the gases and particles of matter that is present. Now, the matter over here is cold, it is solid, and obviously motionless particles are present here. Now, with the time we realize, because every single entity has a gravitational pull, due to certain instances, you see that they might have collided later stages. And that might have led to what? That might have led to collision. Now see, the thing that comes is, he puts the statement now. This is something assumed. People will say this is wrong with respect to assumption. Leave it, because Immanuel Kant has assumed that this is assumption. Now, after the assumption, keeping that in mind, what does he say? He says that mutual attraction and collision between the particles generated random motion. Now see, supposingly these are all particles, because initially they were motionless and all, but later on, due to the gravitational pull, supposingly there was certain collision that took place. Now, because of the attraction and collision, you realize that there is random motion being generated now. Because after collision, obviously there is repercussions out of it. There might be heat generation also. A lot of things happen. So we realize that due to the attraction, the gravitational attraction and the collision that is taking place, random motion, here movement is generated within this particular nebula. The collision and attraction generated heat. Now you by default know that if there is certain collision taking place, that collision will generate heat. This is basic physics. leading to increase in temperature of the primordial matter. Initially what it was, the assumption was it was cold, motionless. Later on you see there is gravitational pull and collision. Collision generates heat. Now heat will basically lead to increase in the temperature of this, what? This nebula. Now see, random motion of the particles also generate rotatory motion, though it is a criticism. He's not able to explain the reason. He says that this heat generation, this random motion after some time will lead to some rotatory motion. And this rotatory motion will lead to movement in this manner. See, this movement will start. There will be certain part of the nebula which will be over here. Other, due to the random motion, a little bit, you will see a rotatory motion in a specific manner starts over here. He does not explain the reason behind it. Please remember this. He does not explain the reason. That is why it is a criticism also. So random motion, heat generation leads to some rotatory motion like this. While certain matter is over here, which is again the heat was generated over here. And later on we see this will form the sun also. So a rotatory motion starts. Now what happens? See here. With time, due to increase in heat, because see, the collisions do not stop here. The collisions are still taking place. The heat generation is still continuing. So, with time, due to increase in heat, the size of the nebula increased along with the rotatory speed. Now, if there is more heat, obviously it will lead to expansion. And along with the rotatory speed is also increasing over here. So, what happens? When this process continues, what happens? The matter that was remaining inside later on forms a sun. That means a residuary nebula forms a sun. These particular orbits in which the matter was going on, because of collision, they would have possibly formed. How does collision help in formation of the planets? Let us say the collision is taking place slowly by the process of accretion. Accretion means all the matter is getting collected. So we realize that there will be again what? Various orbits where planet will start moving. So these are the residuary nebula forms a sun, and the matter that was due to collision and all getting together, it will form various orbits and these planets will be moving. See, that is why you see these are the orbits, these are the planets. And the residuary nebula is the sun that is present over there. This is a concept that is given by Immanuel Kant. Quickly, supernaturally primordial matter was present. Cloud called nebula slowly rotating, which the matter, along with the gas and matter, the matter being cold, motionless particles are present in solid in nature. They collide under the gravitational force. So what happens with time? Due to attraction and the collision, the heat is generated, right? And that, along with the heat, you realize that there is a random motion generated. With time, with the increase in heat, we realize that there is a rotatory motion that will be generated, according to Immanuel Kant. Slowly, what happens with a further increase in speed, further increase in heat, we see the size of the nebula will increase. So there is a rotatory speed over here, and we realize that a somewhat similar, this type of a structure is formed. The residuary nebula, which was left in the middle, forms the sun. So residuary nebula leads to the formation of sun, whereas the other matter which was again accreting leads to the formation of the planets in the various orbits. This is the concept of gaseous hypothesis by Immanuel Kant. Clear, everybody? Quickly note it down in your papers while I was explaining you A4 sheet so that this concept will be clear. Now imagine if you are asked over here, Immanuel Kant is written in one line, nothing has been explained here. Now, on the other hand, I've explained you complete things. So when you are reading the NCERT, you see the word. This is how UPSC picks up the questions or makes a question. They know it is mentioned in the NCERT, but it is not explained in detail. So what happens is, though they will pick it up from NCERT, but you will be blank if you haven't read this, what I'm teaching you right now. Clear? Let's move on to the next. You do not have to do R&D over here. What is being taught is sufficient for you with respect to these origin theories. Remember that very categorically. Now, the second is Nebular Hypothesis by Laplace, 1796. The first thing he does is, see, he criticizes the concept given by Immanuel Kant. Then he himself assumes something, certain statements, and then he gives his theory or the statements. So, three things are there. Now, let's see. I'll be presenting you the diagram also of this, so you will be remembering. Clear? Now, what is the criticism? He says that large amount of heat cannot be generated due to the collision of primordial matter. The basic premise that was presented by Immanuel Kant is that collision is taking place and that is leading to the generation of heat and then random motion and then rotatory motion. So he said it is not possible that so much heat is going to be generated by merely collision. He criticizes that. So that means he says that the concept presented by Immanuel Kant is wrong. Second statement, he says that random motion cannot generate rotatory motion. He said if some particles are colliding with each other, how is it possible that it is leading to a rotatory motion? It is not necessary. So these two things basically criticize the gaseous hypothesis of Immanuel Kant. Now what does he assume? Now he himself does a very similar thing. What does he say? He assumes certain things. He assumed that there was a huge and hot gaseous nebula in the space. So he does a very smart thing. Rather than giving the reason why the heat is being generated and all, he says initially only, primordially only, there was a huge hot gas nebula present beforehand. He does not explain how it has come. He does not explain why it has come. He simply assumes it. He does a very similar kind of a trick what Immanuel Kant has done, but he's done it in a different way. He assumes that a huge hot and a huge nebula is already present in the space. What Immanuel Kant had done is he had basically presented how the heat was generated and explained the reasons through collision. He does not say that. He said there was a hot nebula of a huge size already present there. Second assumption is from the beginning huge and hot nebula was rotating. So that means he himself says there's a huge and hot nebula present and it is rotating. This is even more weird from the perspective that at least Immanuel Kant had tried to give the reason. He does not even give the reason. He assumes that particular thing. So his assumption is that huge and hot gas nebula is present in the space, and from the beginning huge and hot nebula was rotating on its axis. So this is an assumption. So in order to remove all the things that Immanuel Kant has done, he has basically assumed these two statements. This is correct. Assumption. Now what does he say? Another thing. Another assumption, in fact, nebula was continuously cooling due to the loss of heat and continuously contracting. The third assumption, he said the nebula which was initially hot and huge was continuously losing heat and it was cooling. And because of cooling, the nebula was contracting. Now understand, Immanuel Kant's hypothesis basically talks about heat being generated by the random motion and the collision taking place, and it was expanding. While the focus over here is that due to the cooling, there's a contraction that is taking place. Clear? Now see, what are the statements that are presented over here? There was a gradual loss from the outer surface of the nebula due to circular motion. As I've already told you, nebula is basically a huge cloud of dust and gases, right? You know that initially only I've taught you. So he said that because of this nebula which was hot and huge that was present, the outer part was basically losing its heat. Now let's see. Supposingly, this is the assumption that was made by Laplace. He said that there was already a hot and huge nebula existing and it was basically rotating also. So this was the first stage that he assumed itself, right? Now he says that there is a contraction taking place. See, this is larger in size. This is contracting. Why it is contracting? Because the outer surface of the nebula is losing heat. That is what is presented here. There is a gradual loss from the outer surface of the nebula due to circular motion because it is rotating. So the outer surface in a way was losing heat. Now if it is losing heat, there is certain level of contraction that is taking place. So the gradual cooling leads to contraction in the size of the nebula, thus in turn increases the rotating speed. So he said, what he says is the size is decreasing, but the rotating speed is even increasing. So what is going on here? See, the size is basically decreasing. Sorry, this is the initial stage. The size is basically decreasing, but the size is decreasing because the outer surface is cooling, but the rotating speed is increasing. Now what happens is something very interesting. Out of this, because the rotating speed is increasing, so automatically the outward force is also going to be presented. In generally, when you read about in physics and all, you read about centrifugal force, centripetal forces. I'm not using those words right now. I'm simply using because something is rotating at a very fast pace. So there will be outward force even present there. So what is going to happen is, see here, due to the high rotating speed, a single ring of material came out. I will compare it with the concept of Immanuel Kant also. See this very carefully. It is rotating at a fast speed. A single ring comes out. A single ring comes out. While in case of Immanuel Kant, he does not mention a single ring. Multiple things, things come out, and that is why we realize the creation of planets take place. Immanuel Kant does not mention a single ring, but over here Laplace mentions a single ring came out. Now the single rings divides into multiple rings. Now this single rings further divides into multiple rings, and what happens? The matter that is moving on in the orbits collects together, and it leads to the formation of planets. Because see, there's a lot of dust particles, gases that are present. Now they are also colliding with each other. So with that collision and all, small matter acting as a nuclei will become bigger, and possibly make a planet out of it. So that is why single ring, lot of particles are let us say colliding with each other also, and slowly further divisions of rings take place, and small planets are created. So the primordial nebula over here leads to the formation of sun, and various planets with time are created. Now there are a lot of problems with these concepts also, but what we have to do is you need to understand what these thinkers are saying. Why it is important? See, I have written these statements because this is what is required in your answers also. But by making this diagram, you can remember the complete concept. See, let us assume a hot and rotating nebula is already present there. Clear? So this is hot nebula which is rotating. Now you realize with time, outer surface get cooled and there is contraction. So there is contraction in the nebula which leads to, because the contraction is taking place, so the speed of rotation is increasing over here. So that means cooling of the outer surface and a very fast speed rotation. Because of this, when you're rotating at a fast speed, there is outward force of the particles is basically increasing. That is why a single ring comes out. This ring later on, according to many millions and millions of years later on, these rings further divide into various orbits, and because of collision of the particles within those orbits, it leads to the creation of planets as we are seeing over here. So this is a complete theory. Just merely on the basis of the diagram, you can answer it. That is why I have made these diagrams. These are not present anywhere. This is why I tell you creativity is very important. When you say, oh, the diagram is not mentioned, leave it. Who will make the effort? Let us leave it. Remember, creativity is always awarded in UPSC. When it is not drawn anywhere in any book, when you are drawing these statements based on what you study, UPSC examiners will appreciate that this child has done something really good. Now, just tell me, merely reading this content is easier, or using this diagram and just labeling it and writing few lines is easier? Obviously, this is easier. By merely looking at the diagram, you can completely recall the complete theory. That is why in the examination also, whatever diagrams I'm making, whatever maps I'm going to make, whatever concepts I'm giving, make the best use of it. It will be very, very useful for you in the examination. Let's move ahead. Third theory is the Planetisimal Hypothesis by Chamberlain and Moulton, 1905. Now, this theory is again important also because even today when we talk about the formation of planets and all, this theory is also used even today. But again, a lot of concepts particularly with the concept of planetesimals, though there are multiple concepts that are present, but this concept of planetesimal itself is important to understand. You will be asking, sir, just tell us one thing. When we write planetesimal, we know what is planet, but what is planetesimal? We will be understanding over here. Don't worry, right? So this concept, please remember, you can be asked to differentiate between certain concepts also in your examination. Even in the preliminary examination, because see, all these statements are present in your NCERT. Though they have not been explained in detail, that is a different scenario. That is why I'm filling that gap. It can be very well asked as statements in your preliminary exam. Nobody is stopping the UPSC from doing it. That is why when you say, no, sir, NCERT is enough, not enough, this series makes it clear that reading the NCERT and doing this is already covering every part of NCERT. If you're doing this, you're already prepared for the examination to almost a great extent. Again, remembering, depends upon how many times you revise and how you note down the content that I have written on the board. Clear? Okay. So, again, the statement. Statement means what are the views that are presented by these people. See, just imagine I have written all these things, all the content is mentioned. Okay, fine. 6 points are mentioned that basically tells about this theory. But now let me show you simply 3 diagrams. Simply 3 diagrams. I have not explained you a single statement on this theory. Not a single statement. Just tell me one thing. What do these 3 diagrams tell you? There is a proto-sun, that means not a modern day sun, old sun that was present. Then there is a companion star that is coming. That is very large, huge size. That means another star is coming close to the proto-sun. What is our sun right now? Before this stage, it is known as, in the process of formation, it is known as proto-sun. So, proto-sun, you realize a companion star comes, another huge star crosses by, comes near our sun, which is in the process of itself making. And you realize this, that a lot of material is extracted out of it because of the gravitational force of this huge companion star. And that leads to the formation. This material later on creates various orbits, and the accretion, that means collision of the particles and getting together and becoming huger. That is the process of accretion, addition of material. And that leads to the formation of new planets. Now, did you understand by these 3 small square diagrams, I have completed the whole theory. Now, if I explain you this, you can even write it in your own words. You can write it in your own words now. That is why I say there is a difference between studying very hard. Yes, you have to study hard, but along with it, this smartness is also required. Nothing will replace hard work, but smartness in a long term helps you once you have done your hard work. Now see, what you have studied over here, let us understand the theory. This hypothesis envisaged that the origin of the solar system and the Earth along with it, with the help of 2 heavenly bodies. What are the 2 heavenly bodies? One is the proto-sun, right? One is the proto-sun. Now, please understand this proto-sun. This sun is not this type of exactly the sun in what it is stage it is present right now. Proto-sun means in the process of making of the sun, which is today, those old stages of it. That is why it is known as proto, previously. Now, there is a proto-sun and there is another body, or let us say a companion star, or you can say as an intruding. Why intruding? That star coincidentally crosses near the proto-sun. So this theory basically talks about 2 bodies, one the proto-sun, another the companion star or the intruding star, which will cross nearby or come close to the proto-sun. Now you will say, sir, how do we get these evidence? These are again based on the assumptions, based on the thinking that what the thinker has thought, and that is why he has presented this hypothesis. It is not a theory. That is why it is a hypothesis, right? It is not a theory. It is a hypothesis. So what does he say about the proto-sun and the companion star? Let us see. He says the proto-sun was made up of very small particles which are cold and solid. Now see, he is simply saying that it is basically this proto-sun initially is cold and made up of solid particles. Okay, it is his description. Now then he says a companion star came very close to the proto-sun. There is another star that came and it came very close to the proto-sun we are talking about, thereby detaching infinite number of small particles. That is why when the companion star came close to the proto-sun, it detached, because of the strong gravitational force, detached a lot of particles from this proto-sun. Clear? So these detached small particles are called planetesimals. Now please understand, these detached particles that basically came out from the proto-sun because of the gravitational force of the companion star. So these small particles are known as planetesimals. Why? Because they form the basic nuclei through which lot of accretion or collection of, let us say, addition of these gases and particles will lead to formation of planet. That is why, see, made up of dust particles and it forms a nuclei for the formation of possible planet. So planetesimal is not a planet. These are particles, small particles, which will in the future form a possible planet. That is why these are small particles which act as a nuclei. Why it is called a nuclei? Because when you see a nucleus, it is at the center of a particular atom where a lot of other things, electrons are roaming around. So that is why similarly planetesimals are small particles which will continuously collide, add on. That's the process of accretion and form a planet. That is why it is not a planet, but
in the process of formation of a planet through the process of addition or accretion of the particles or the gases. So the accretion led them to become planets. Later on, a lot of particles collided, added, and it led to the formation of planets. With the passage of time, proto-sun changed to present-day sun. He does not explain the process, how it changed. Over here, we will not give our views over here, right? He said the proto-sun later on, due to the various processes taking place, changed to the present-day sun. So what we see over here, companion star, proto-sun. Companion star pulls a lot of particles. Proto-sun changes to modern-day sun, and these formation of planets through the process of accretion takes place. And this is how the Earth and other planets are formed. This is how the solar system is formed. This is the Planetisimal Hypothesis. Clear? Done? Again, I'm telling you do not have to go into R&D. These questions related to these topics have been asked previously, long years ago, previously in the previous year questions of UPSC also. There is a quite possibility they can again change that trend. You know very well, in UPSC, if you want to qualify, particularly the prelims, you should understand one trend, that there is no trend. If you want to qualify the prelims, please do not make assumptions that, oh, only this part comes, oh, only the static comes, no, only the current affairs come, this subject is not important, that is not important. You yourself are preparing for this examination, and if you do this mistake of considering yourself bigger than UPSC and UPSC examiners, that is the first step towards your failure. That is why if somebody assumes that why or how will these question comes, it is not possible. It is in your syllabus. It is present in the NCERT, but the content is very limited. We have expanded it so that you understand the concept. This can very well be asked in your prelims paper also as statements. It can very well be asked as 15 marker, 10 marker in your mains examination also. And then what happens is, you would have seen, if one or two questions like that come, if you're not able to answer, these are low hanging fruits where you can score really very well. And when you miss on these, that is why it leads to you possibly not getting your desired rank or desired cadre, or possibly out of the list also. So please make sure that you do everything that I'm teaching over here very, very categorically. We are putting a lot of effort. I'm telling you, to record this lecture of, let us say, 1.5 hours to 2 hours, it takes close to 10 hours to 11 hours to make this particular things on my iPad. I'm telling you a reality. Why I'm sharing this with you? Because you are my students, whoever across country or even across the world who are reading these, seeing this lecture. To create this lecture of 1.5 or 2 hours, the effort I put in making these diagrams is close to 10 hours to even 12 hours. And then the content is prepared and I come in front of you to present this. That is why I'm putting an effort so that you gain out of it. You benefit out of it. So please make use of it. Do you realize making these diagrams is not easy? Every single thing has been made by hand. So you understand it and you do well in your exam. So please do this, make the best use of it. During our time, we used to study on our own. We had nothing. We had to study on our own. There was no such book also. Today, when we interpret, we have that analytical power. So we are making these diagrams also. Okay? Chalo. Next is tidal hypothesis. Now the tidal hypothesis, again, James Jeans and Harold Jeffreys again mentioned in your NCERT. Right? These both the names are presented in your NCERT, but they do not explain it in detail over there. That is why you can be asked this question over a prelims and mains. So tidal hypothesis by James Jeans and Harold Jeffreys. Now let us, again the same thing. Let us leave what is written over here. Leave it. Let us see the diagram. Let us see the diagram. This concept is very similar to the concept that we have studied over here also, right? There are certain differences also. Again, there is a proto-sun, there is a intruding sun or the companion sun. Now see over here. Supposingly, this is moving in this direction. Let us assume. The companion star, intruding star is this time moving in this direction. This is a proto-sun. Do you realize a filament is being formed or something is coming out? When it comes closer in this direction, this filament is completely formed or detached. And this filament can be seen like the form of planets, Mercury, Venus, Earth, Mars, Jupiter, and so on and so forth. Just looking at the diagram, can you imagine what it basically means? It is similar to the previous theory, but it is different from certain aspects also. See, the force that is being exerted is known as a tidal force over here, right? Tidal force. The word is new, though it is, see, it is gravitational force only. But this theory uses the word tidal force first. Second, unlike the previous case where we said that matter is basically being pulled out, there is no specific shape which is mentioned there, right? In the planetesimal, over here they mentioned a cigar-shaped material is pulled out. And that is why when you see the planets also from a distance, you realize that it is somewhat like a cigar, because Jupiter in the middle, huge planet, then other smaller planets are present. So that is why, based on this view, he assumed that possibly this could be the reason. So what is the difference? Let us understand. The solar system was formed from the primitive sun and an intruding star. Very similar, like we have the proto-sun and the companion star in the previous. Similar statement is presented here also. Primitive sun was stationary and rotating on its own axis. Now this is again a problematic situation, because today we know that the whole solar system is moving, the whole galaxies are moving, but still this, what does he say? He said the primitive sun is stationary in its position, but it is rotating on its own axis. Clear? Now, when an intruding star came near the primitive star, now see, what happens now? An intruding star came close to the proto-sun or the primitive sun, whatever you say. It exerted a force. Rather than using the gravitational force directly, they mention the word tidal force. It is their own word that is created. So you have to use this word. That is where the word tidal hypothesis comes. So they are basically exerting a force which is gravitational but used as tidal force. Now because of this, material is again pulled out, but it is pulled out in a form of a cigar-shaped structure. This cigar-shaped structure is known as a filament being formed. So as it moves closer to this particular proto-sun, this cigar-shaped structure, which is known as a filament, is taken out or pulled out from this particular proto-sun. So that is why you see, when the intruding star comes near the primitive sun, it exerted a tidal force that is known as a gravitational force in today's time, as we say, on the primitive sun, right? So as it is coming closer, a filament is being pulled, because over here the distance is more. So possibly the filament is not properly extracted. When you come in this position, the distance is near. So the filament is completely extracted. As a result, giant cigar-shaped tide known as filament is ejected from the primitive sun. And this filament, which basically has lot of material, dust particles and all, later on forms the various planets, and which will orbit around the particular sun. This is known as Tidal hypothesis. Clear? See, every theory is going to have its problems and all. You do not have to go into R&D. Just understand the concept very well. Note it down. If you have any queries also, we are still open. When you write in your comment sections, tell us. No, you will be seeing in all my lectures, which are on YouTube, whenever the students are asking any queries, when they are commenting whether they like the videos and all, I always like to respond to them also, and I almost respond to every single comment that is presented. So please remember, when you like the videos, please comment there also. Tell us how you like the video. Did you understand the concepts and all? So do let us know also. So you can copy this down. I'm giving you a minute. Stop the video or pause the video and note it down. Secondly, here again, stop the video or pause the video, note it down. Along with the diagrams, please remember, making of these diagrams is a very boring, very effort-taking process. But if you do it once, you will be ready for your future with respect to your prelims and mains examination. Okay. Next is binary star hypothesis of Russell, 1937. Now this concept again is similar to the previous, but with another angle that comes over here. See here, let me show you the diagram first. Do you realize there is a proto-sun, there is a companion star. See here, the primitive sun and a companion star. Can I write it over here? See, this is a proto-sun. This is a companion star. Generally, this combination was being used was used in the previous two hypotheses that were presented. But in this particular concept of the binary star hypothesis, there is another third dimension, a third aspect that is added is one giant star. This is known as the approaching star. So over here, three bodies are being used, not two, three. So please remember, this is the difference. Based on the diagrams, you're able to understand. You can, if you write the explanation in your own words also, based on these diagrams, more than sufficient for your general studies, more than sufficient for your general studies. That is why I'm showing you the diagram first and then explaining it to you. What can you assume? There is a protosun, there is a companion star that is moving around. There is an approaching star. One more thing is that the approaching star and the companion star are moving in the opposite direction, right? Opposite direction. Now what happens is the approaching star basically pulls all the material from the companion star, and that leads to the formation of various orbits and the planets over there. The protosun leads to the formation of the present day sun, and this companion star basically, because of the large gravitational force that is exerted by the approaching star, various planets or various orbits are formed, and various planets which are revolving around the sun. This is the concept of that is given by Russell. Now, if I want to understand, there was a primitive sun and a companion star revolving around it. So there is a primitive or a protosun and a companion star which is revolving around the protosun or the primitive sun. A companion star was the companion star of giant size and later became, please come back here. There was a primitive sun and a companion star. Later on, one giant approaching star came near the companion star, but in the direction of revolution opposite that of the companion star. What did I say? So, companion star revolving around the protosun, a approaching star came. If this is moving in this direction, it came from the opposite direction. This led to large amount of matter being ejected out. So, large amount of matter was ejected out of it because this was giant, very large size, and a lot of gravitational force was exerted over here. So, this led to matter being ejected and various orbits being formed, where matter was basically revolving around the protosun. That matter again, due to the process of accretion, formed various planets that started revolving around the protosun. That protosun later formed the present day sun. So this is basically the binary hypothesis of Russell. Later on, the planets formed from the ejected material. Clear? I'm giving you a minute. Pause the video and note this complete stuff. Again, very important. And this is again, pause the video, draw this diagram and complete it. Next, supernova hypothesis of Hoyle, right? Now, please remember, supernova concept I will be explaining you in the life cycle of star after 10-15 minutes. Simply, if you want to understand what is supernova, it is basically when an explosion of a star takes place in the end of the life cycle of a star. That is known as supernova. Clear? When life cycle of the star almost on the end of stage, so explosion of the star taking place, that is known as a supernova. Right now, understand this concept, that is more than sufficient. See, what are the statements? Now see, let us see the diagram. Let us assume there is a sun. What does this theory say? I have again created diagrams so that if you do not read these statements also, then also you can write them. So there is a star, there is a companion star. Now this companion star, again it is a star. If I say the explosion, because of the later stages of the star, when it has finished with its life cycle, it explodes. Now, supernova, let us say the explosion has taken place over here. Now, because of this explosion, all the material will be scattered. This material, because of the gravitational force of the protosun, starts revolving around the sun, right? Then slowly, you realize because various particles are present, they might collide with each other, and slowly accretion and increase in the size of the particle will take place, and possibly planet formation will start. Slowly what happens further, because it is revolving, you will be seeing that outward force will also increase, so there will be more orbits that will be created. and slowly you realize this sun will have various orbits and planets that are revolving around it. This is known as a supernova hypothesis. Merely based on the diagram, which I presented over here, you can very easily, very easily draw them. See here. Initially, there were two stars in the universe, the primitive star, primitive sun or the primitive star, and the companion star, as seen over here. The companion star was of giant size, very giant size, and later on became a supernova due to the nuclear reaction. Supernova, and that means violent explosion will take place. Violent explosion of the companion star, which is now supernova because of explosion has taken place, resulted in enormous dust particles around the primitive sun. Now, dust particles will later accrete and lead to the formation of various planets, and the proto-sun will form later on the present-day sun. So this is known as the supernova hypothesis. I'm giving you a minute. Pause the video, note this down. Done. Pause this video, draw the diagram, and you will be done with this theory completely. Next comes the interstellar dust hypothesis. Right? Interstellar dust hypothesis. It is given by Otto Schmidt, right, as we had seen. Now, what are the statements? Before the statement, let us see here. Okay. They assume there was a sun or a primitive sun that existed, and around it was a cloud of dust and gases. With time, that started revolving around the primitive sun or the sun. Later on, what happened, this dust cloud, again, particles accreted or joined together, and small planets started moving. These were not complete planets, let us say planetesimals only in a way, because planet formation is the last process. Earlier on, when the particles are colliding and the small dust particles are present, those are known as planetesimals. Later on, they collide, become big, and at the last stage, they can become a planet. So over here, I'm not using the planetesimal. You can use, there is no problem. But when we see these small particles are slowly growing because of the collision of the dust particles or the gases that are combining over here, and you will see a little bit stage of orbit formation. Now, there will be various directions through which the planets will be moving, because there are a lot of gravitational anomalies that will be taking place, gravitational changes, accretion taking place. So there will be difference in the forces of gravity also, because when the particle size increases, the gravitational pull also changes. And slowly you will be realizing there will be stabilization with respect to the orbits. And at last, a sun and various planets revolving around it are formed. Now, this is the concept of interstellar dust hypothesis. In simple words, a large cloud of gas and dust was revolving around the sun. With time, under the process of accretion, planets were formed. Very simple. And this concept is presented through the diagram. Clear, everybody? Done? Okay. Now comes the last theory. This is the Big Bang theory. Now, please remember one thing. Though we have studied 7 theories before them, again, a lot of problems are there, a lot of issues are there with every theory. Then came the Big Bang theory. Now, Big Bang theories generally we discuss or talk about this is a valid theory, this has lesser criticism, but it does not mean that this theory is perfect. I'm telling you again, whichever theory you study, whichever theory concept you understand, every concept has its own flaws. Understand one mantra with respect to geography, or for that matter, any subject. Whatever we explain you, whatever is presented in the books are based on the observations, based on the limited observations that have been made, right? Possibly after few decades, we have more technology or better technology that is presented, and we realize that no, this Big Bang theory is wrong. There was some other phenomena that took place. Right now, what we have, on the basis of that, we are basically studying these. That is why, from the perspective of you being a process of becoming a civil servant, you should be very clear of this point, on this point, that no theory of any subject is perfect. These are views that are presented based on these certain observations. And these observations in a long term might be right or even wrong, whatever be the case. So, but this theory is today considered relatively better when we study the creation of universe, for the formation of Earth or solar system. So this theory is considered better because a lot of evidences are being presented in favor of it also, but again, not perfect. So let's understand what Big Bang theory is actually. See, in simple words, if you realize, there was a tiny ball or tiny atom that was present. Nothing was there in the universe. The explosion of this took place, and based on that, universe started expanding slowly. You realize that galaxies started forming, and galaxies, and then under that planet, solar system started forming. This thing, when the nothing was there, this single atom was present, is known as singularity. That is why Big Bang theory, which whenever we talk about, is talking about some explosion, bang taking place. Now, evidences are there, so that means it is also talking about the universe being expanding. Right from a single atom or singularity, there is expansion taking place. And this is what this theory is all about. So see, Big Bang theory is prevailing model to explain the universe birth. To explain the universe birth, this is theory is being, in today's time, relevant in the market in a way. It is also called the expanding universe hypothesis. Expanding universe because it says, as a tiny atom was present, a tiny ball and atom was present, it exploded, and slowly universe started expanding or increasing in size. That is why it believes in the concept of universe continuously expanding, and it says it is even expanding today. Many people say that, see, the distance between galaxies are increasing. That means possibly the universe is expanding. Similarly, various observations are made that they assume that possibly are the reasons or evidences for the Big Bang theory. Now, it was formulated by Georges Lemaitre in 1927. Later on, concepts were added, but he basically formulated this theory initially. It states that close to 13.7 billion years ago, 13.7 billion years ago, all the space was contained in a tiny ball. Nothing was present, only a tiny ball was presented. This is this tiny ball, yellow color. Now, this was assumed to be of infinite density, very dense, infinite temperature, very high temperature, and unimaginably small volume, called the primeval or primitive or concept of singularity being represented here. So this tiny ball that was present, that means there was no universe as such, there was a tiny ball or an atom that was present in a way, which had indefinite density or infinite density, infinite temperature, and an infinitely small or unimaginably small volume. And it exploded. This atom exploded violently, leading to the expansion of universe, which even continues today. So that means, what is singularity? Singularity represents this condition or a stage when the complete universe was confined to that particular small atom or a tiny ball. And from there, you realize the expansion is taking place. Remember, that is why there was a question asked in your geography paper regarding singularity. This is taught. That is why I tell you, read the NCERT. Somebody who has just read, like, there was in the NCERT, there's a diagram that is presented. In that diagram, the word singularity is present. There is nowhere singularity is explained in the NCERT, but it is mentioned, singularity is mentioned in your NCERT. Over here, if you had just seen the diagram and singularity is mentioned, if you have not analyzed it, possibly you will not be able to answer in the exam. That is why what is mentioned in the NCERT, I'm expanding them and explaining you in detail over here, so that your complete actual knowledge of NCERT, what is required for the paper, is done, along with all other dimensions. So this is explosion taking place, and then universe basically expanding. This is being represented over here. As the universe grew, some energy was converted to matter. Now see, because explosion took place, so a lot of energy is released. And we know very well that energy is related to matter also. E is equal to mc square. You already know that. I'm not going into the concepts of physics, chemistry and all. But energy, E is equal to mc square. So that means there is a conversion of energy and matter takes place. Now, so such large amount of energy is being generated. Over there, we realize that energy was converted into matter. Now, with time, we realize within the first 3 minutes of the Big Bang theory, first atom, that means again a matter, a basic element of matter, first atom began to be formed. Now, you'll say, from where has this atom come? Because better, this initial atom exploded. Now again, because of the energy being generated, we slowly see small atoms being created. Within 300,000 years of Big Bang, the temperature dropped to 4,500 Kelvin and gave rise to further atomic material. And slowly you realize we see the formation of galaxies taking place, then slowly within the galaxies, solar systems will be forming, solar system having planets formation will be taking place, and later on we realize with them life also coming, right? So this is how the Big Bang theory basically explains or talks about. You do not have to go into a lot of detail right now. What is presented over here is more than sufficient if you analyze it well. This is more than sufficient for your preparation, right? Okay. Now coming to another concept. This is different concept. We have done with the theories. Now obviously life cycle of star. There is a particular paragraph that is presented with respect to star, where it mentions about this white dwarf, black dwarf, red giant and all. A word nebula is also mentioned. And you would have realized this, that in spite of reading those paragraphs multiple times, you have never been able to understand what these things are basically, or what they basically try to convey, because you try to rote learn that. And in that particular process, rote learning is not able to solve the problem. One more thing, there have been instances where in the past 5 years, twice or thrice question with respect to this particular diagram has been asked in your preliminary examination. White dwarf, red giant, all these questions have been repeatedly asked. Just or merely understanding this diagram, you will be able to answer questions in your prelims as well as the mains. This is completely hand-drawn. Please remember this. I have completely hand-drawn these. These are not from Google. You can see, if you will, when you will have the PDF, you will see I have done the sketching also over here. That is why it takes time. So that you should be inspired with the fact that the teacher can put an effort to draw these diagrams. Why can a student not do that? That is why when you say, when you want to qualify the examination, I always tell you one thing. At least put an effort equivalent to that of your faculty or a teacher, at least. And you will realize that your life will change. To create this lecture of 1.5 hours, 1 hour 45 minutes, it took me 11.5 hours to 12 hours to do it. Right? So at least when you do this, when you make your notes, properly read it, properly revise it, so that you are done with the chapter. And then when you revise it again, it will be very easy for you. Okay. When I talk about the life cycle of a star, there are stages. This stage is known as a birth, then the main sequence, then the old stage of the sun, and then is the death or remnants. Now please understand, initially you have a nebula or a gas cloud. Then you have, out from the nebula or the gas cloud, you have the protostar. And from the protostar, you have a T-Taurus phase. Let me explain you this first, and then we will move on to these things, right? We have the nebula or the gas cloud. You know that very well. What is nebula and gas cloud? Then you have the protostar, then the T-Taurus phase. Let us understand them. Nebula. What is nebula? Nebula basically refers to the giant interstellar cloud. That means a cloud that is made up of dust and gases, right? So please see here. What is this cloud? Of dust and gases. Clear? Very well clear to you? This nebula, dust and gases. Next stage after this is a protostar. Proto itself means not in a state, the star which we talk about, but in the process of formation of star. So see here, heat energy produced from a nebula, which results in a warm lump of molecules. Now, you know, within a nebula, there are a lot of particles which might be colliding with each other. There will be a lot of heat energy that is generated. Now, along with it, you will be realizing when the collision takes place, the size of those particles attaching to each other slowly will increase. So, lump is presented there, which has, let us say, the size of the lump is increasing, but along with it, the temperature is also high. Because of the collision, the energy is generated. So, now this is not completely a star, but a protostar, because it is in the process of becoming a star. That is why this is known as protostar. Heat energy produced from the nebula, which results in a warm lump. That means accretion process is going on, and a lump of molecule is created. So this was the protostar. Clear? Multiple such processes are taking place. Then comes the T-Taurus phase. These are three in the birth phase. This phase begins when materials stop falling into the protostar and further released tremendous energy. Now what happens is, because itself the size is little bit increased, now further material is not falling into it. But now tremendous amount of energy is being released from the star itself. Now see, further release of tremendous energy. Now this is a stage where you will see chemical reactions are taking place. Now it is further mature stage from the protostar. So next stage will be formation of a proper star, which we see in the form of like sun and all. So nebula forms protostar, within the protostar you will have the T-Taurus phase where chemical reactions in a little bit in the initial phase will start, energy is being released, and further falling or collision within the star is not taking place now. So that is known as the T-Taurus phase. Now see here, this is the birth stage. Now from T-Taurus stage there are two possibilities. See here, there are two possibilities, 1 and 2. If the star is low to medium mass star, that means it is, okay, low to medium also, just imagine our sun is so huge, but it is a very low to medium mass star, not a very huge star when you compare it with the other stars. Clear? So there are two scenarios now. If the star that is formed now is of a low or a medium star, then we are putting in one category. Example of low and medium star is our sun of the solar system, right? Another can be, the star can be of very huge size or massive mass. Example, Sirius star. When you read about in current affairs, you come across this name also. So now from the T-Taurus phase, two possibilities are there. A star can be formed which is of low or medium mass like our star, or somewhat very much, I think 100,000 lakhs times larger than possibly than our particular star, our star. So that can be a high mass or a massive star like the Sirius. So I presented these two scenarios from this T-Taurus phase. Why I presented in two categories? Because the outcome will be different as you move ahead. Clear? Low to medium stars and other high mass or massive stars. Now let us understand this. Over here, what we are right now, our sun is in a stage of the main sequence stage. You very well know, billions of years from today, our star will also in a way enter its death stage. By that time you would have all died. So be chill, don't have to worry. Whether your children will be there also, you do not know. So you will have completed your life cycle and you would have done with your civil services goal also. So you don't have to worry about billions of years what will happen after this. So chill, right? Till that time, don't worry, things are fine. So right now our sun is in this main sequence state. So what is happening in the main sequence? In this phase, the core temperature reaches a point where fusion will commence. Now fusion, that means the conversion from hydrogen to helium will take place. So that means nuclear reaction have now started. That means energy is being generated. Exothermic reactions are taking place, right? At a very rapid pace. So that means heat energy being generated at a very large scale. Now that is why you can say as a prime youth stage. That is why our sun is in a youth stage. It is not in an old stage. Similarly, Sirius star, which I had mentioned over here, is also in its youth stage, but it is very massive, many times larger, many times larger than our sun. Now what happens is, during this time, after the main sequence, the stars will move to an old stage. Now there are two words which are used here. If, like for example, our sun will become a red giant, but a Sirius, when it enters the star example I've taken, Sirius, will enter the red supergiant because it is much larger. That is red giant and red supergiant. That is why I divided over here. Now, this is the old stage. Now see, we know that this chemical reaction process is taking place, conversion from hydrogen to helium is going on. Now, this will continue till the time hydrogen gas is there. There will a stage will come where this reaction will tremendously fall or come to stagnancy. Red giant is a stage where this nuclear reactions are almost on its end. Certain books say stagnancy, but certain books say yes, they are taking place, but very minimalistically. Then it converts to a red giant, or when a medium or low mass star is on the verge of its, let us say, the old stage, when the chemical reaction processes are not taking place as it was taking place in this stage, you will see it is known as red giant. And a very large scale red giant will be known as a red supergiant, because its previous phase over here, the high mass or massive stage star will form a red supergiant. Our star, which is low and medium, will form a red giant in its old stage. Now see here, old stage. formed during the later stages of the evolution as it run out of hydrogen fuel. It is not very appropriate to say completely runs out. It is more appropriate, though I've written here, but certain books mention it, but more appropriate is because there is hydrogen, but lesser amount, and the chemical reaction and the rate at which the energy was being released is not as it was in the youth stage. You can understand, as a person enters the old stage, he's still living, everything is fine, but not with that same energy as one was doing during the youth stage. That is why you realize this word, when you say runs out, better is or lesser amount would be better, right? Or pace. Clear? So that means it is in the old stage. It is still emitting energy because the process of hydrogen to helium is still going on, but a very low pace because the hydrogen is at a very lesser amount now. Now, red supergiant, an enormous red giant, is often known as a red supergiant. So red supergiant is a very large scale red giant because the high mass and high massive star will form a larger giant, which is that is the red supergiant. So this is the old stage. Now comes the stage where you see the death of the star or the remnants. That is why let us see the red supergiant. Red supergiants form a supernova. Now the supernova might result in two other possibilities after that. Either it can form a black hole or a neutron star. See, a red supergiant, like for example Ceres over here, in its old stage will form a red supergiant, in its death stage will form a supernova, and after that two things can be formed. So whenever you see a black hole, you can assume that there's a possibility that a large or a massive sun existed and it is a remnant, that black hole is a remnant of that, right? So let us see this old stage. After that we have a death or remnant. Now supernova, what does it mean? Supernova means there is explosion or the death of the star, right? There is an explosion or the death of the star that takes place. What is neutron star and black hole? You saw after the explosion there are two possibilities. Either a neutron star will be created or a black hole. Neutron star is a highly dense, compact celestial object that forms after the core of the massive star undergoes a supernova explosion. So it is also dense, it also has a physical presence, and after the explosion what is remnant is known as a neutron star. Now the thing is, if you realize, if you see this diagram over here, from supernova, neutron star or black hole can be created. So what after the explosion has taken place? A highly dense and compact celestial object is formed, which core or the center is basically very dense, and it has formed because the supernova explosion took place. So it is a remnant of the supernova, right? Now other is black hole. Now black hole, unlike the neutron star, is a little bit different. Also formed from the collapse of the massive star or the supernova, having no physical surface. Unlike the neutron star, which has a physical surface, a black hole does not have a physical surface. It has massive gravity that even when light enters it, it is basically absorbed inside it. That is why it has no physical surface. Unlike the stars, previous stars or the neutron star you have studied, it has no physical surface. It is a core of a very strong gravitational center that anything that goes inside it is gone. That is why even today black holes are in the process of being studied. Nothing has been completely deciphered regarding them. That is why it is very problematic also. What is the possible reason? Clear? So these are black holes. Now comes the aspect, red giant might again lead to, let us say, a planetary nebula being formed, and later on finding white dwarf and black dwarf. Certain books do not mention this phase because this is not, in certain books, this is basically leading into the formation of this stage. A nebula or a gaseous like structure being formed. That is why some books mention it, others do not. In a way, that is why this is not something that you should worry about, because the thing is, after the red giant, when it basically gets over with the cycle of exothermic reactions of conversion of hydrogen to helium, that means it has ended now. It will lead to the formation of a white dwarf. Planetary nebula basically means, again, because a lot of other particles will be surrounding it. it is on the verge of death. That is why this statement is mentioned in the books, but correct would be from red giant to white dwarf. This is presented just for the reason that possibly there might be instances where supernova type thing does not happen, but a lesser degree thing happens, which leads to a lot of dust particles being surrounded, and somewhat like planetary nebula is formed. So that is why please understand, even if you miss this part, doesn't matter, you can straight away mention white dwarf and black dwarf. Clear? Now see what these two things are. White dwarf, extremely dense remnant of low to intermediate mass stars that has exhausted the nuclear fuel and expelled the outer layer. So white dwarf, it is white in color. Why it is there? Now the intermediate or the low or the middle mass star which has finished its fuel, hydrogen is not there. Now what will happen? You will realize that all the outer surface is expelled now. Now it shines because of the residual heat that is present. Residual means in the large processes, billions of years, what heat was generated, it will still be there for some millions of years. So for that part, it shines because of the residual heat that is existing, which is seen in the process of white dwarf. Now that residual heat when finishes, you will not be able to see the white surface also, white dwarf also. So that is why later on it is known as black dwarf, last stage of white dwarf, because residual heat will also finish and then nothing will be there. That is why black dwarf is presented. So this is the complete explanation of the life cycle of a star in front of you. You can please note down the diagram or pause the video, make this diagram, again very, very important. This is the birth stage, this is the main sequence, old stage, death at the remnant. Clear? Now comes the solar system. See here. We very well know the solar system comprises our sun, the various planets, asteroids, various comets and all moving around. But this is a major diagram. Now please understand one thing very clearly. There is an asteroid belt. Let us say these are complex stone particles that are basically separating the inner planets from the outer planets. Now, these four planets, Mercury, Venus, Earth and Mars, are known as inner planets or the terrestrial planets, because these have again the reason because they are not gaseous planets like the Jovian planets. These are mostly rocky in nature. That is why these are known as terrestrial planets. When you move beyond the asteroid belt, the other planets, Jupiter, Saturn, Uranus and Neptune, these are basically gaseous planets in nature, right? Larger in size also, gaseous also. One thing you should remember as a trivia question, when a question is asked which planets or which all planets have a ring around them, right? Very, very, very simple question. You can see this, right? The answer is going to be Saturn, right? But this is a wrong answer. The problem is that you see the Saturn ring, which is very prominent, and that is why it is visible also. But the answer is all these four planets have rings. So this is a question that can be asked in your preliminary exam, in PCS exams also, very repeatedly it has been asked. So all these four planets have rings, which can be observed through powerful telescopes and all, but it is prominent over here. That is why you can see it. These also have the rings. So that is why all these four planets, Jupiter, Saturn, Uranus, Neptune, all have rings. Clear? Now let us differentiate between them. Terrestrial planets, these are formed in the close vicinity of the parent star. These have been formed at quite a distance from the parent star. These are relatively smaller in size. These are larger in size. These have very high density because they are rocky terrestrial in nature, as you've said. These are low in density. Remember, the least dense planet is Saturn. It is so dense that if you put, hypothetically, if you put, let us say, Saturn in a pond of water, hypothetically, please understand, it will not sink because the density of Saturn is so low, right? So low. So please remember the least dense planet is Saturn. A trivia question that you should remember. These are mostly rocky. These are mostly gaseous. Ring is absent over here. Ring in all the planets is present. Saturn, it is more prominent, but others also have. So you should be well aware of these differentiation between terrestrial and rocky planets. Now see, Moon. This is present in a big paragraph in your NCERT. Now please remember, there are a lot of theories with respect to origination of how from where the moon has come up. One theory says possibly during the formation of the Earth, when a lot of planets or planetary accretion was taking place, possibly a moon-like body also accreted and it started moving around the Earth. One reason. Another people say that if you see the surface of the Earth and if you remove water, there is a region in the Pacific which has a huge basin. Possibly the moon has basically come out of it. Then there is another reason or another concept that is presented, which is known as a big splat. This is generally the latest one and more acceptable also. That is why I'm telling you, a lot of views are there, but what are the important ones which are mentioned in the NCERT that we are doing, right? Now, moon, when I talk about, this is the only natural satellite of Earth. Now, before I explain you the concept of big splat, how the moon was created, let us see a diagram. Let us say a huge body came and collided with the initial Earth process, okay, when the formation was taking place. So, collided, and you can see the amount of energy and being coming out of it. This led to a lot of material which splashed out of the Earth. This splashing of that Earth basically led to certain material again revolving around it. Then further accretion, that means getting together, or accretion, that means material combined with this body. And today, after cooling processes and all that took place, you have an Earth and a moon that is along with it. Clear? This is known as a big splat. This whole concept which I've explained in front of you is known as big splat. Now, let me explain you again here. It is generally believed that formation of the moon is an outcome of a giant impact called big splat, right? A body of the size 1 or 3 times that of Mars collided with Earth and blasted a large portion of the Earth. As you have seen here, blasting taking place. Blasted portion continued to orbit the Earth and form the present moon close to 4.4 billion years ago. Our Earth is believed to form close to 4.6 billion years ago. The moon formed 4.4 billion years ago. Clear? So, after some time only after the formation of the Earth, this took place. The Big Bang theory happened 13.8 billion years ago. This is again based on the observations by the various geographers and scientists. So, this is, you can pause the video and write this particular content, and this is a diagram that you can draw, which on the basis of which I have basically explained this content, right? Now comes the evolution of Earth. There are certain things you need to understand. First is the evolution of lithosphere, and second is the atmosphere. Please remember, a lot of details with respect to crust formation and other dimensions we'll be doing in the future chapters or other lectures that are going to come. What is mentioned in the NCERT we'll be doing over here. How did the lithosphere, or the upper layer of the Earth, which includes the crust also, right, was basically formed? So what happened is, it says, the NCERT is mentioned, it says, Earth was in a volatile stage during the earlier stage, because you realize a lot of accretion was taking place, temperature was high, so it was basically in a volatile stage. Now with this volatile stage, or let us say even magmatic material was present, so you realize with a gradual increase in the density, the temperature also increased because the accretion processes were taking place. Now slowly you happens, there are a lot of material that is present. The material or the metals that are dense in nature will move down, and along with it, the lighter ones will move up. That is why even today, if you see iron, nickel and all present in the core are very heavy metals. They are inside. We have even the lighter metals on the upper portions. So slowly, after the differentiation, they were solidified and basically condensed. The outermost layer of the Earth basically formed the crust. Now, you realize this process is taking place from the time of 4.6 billion years to 4.4 billion years. Now, immediately after that, close to 4.4 billion years, you have the big splat, where the object close to 2 to 3 times the size of Mars basically, let us say, blasts the Earth or collides. Then again, the whole process will start, where a lot of material that was present in that particular object that came also basically blasted, and the minerals will also come to the Earth also, because which might not have been present earlier. So complete, again, all magmatic processes will start taking place, because the energy to such a great extent was increased. Nothing would have prevailed over there. Complete magma and energy of such a great extent was released. So now big splat completely raised the temperature. Now slowly after that, based on the density of the substances, things would have differentiated into various layers, which would have led to formation of the crust on the top, then the mantle and the core. Core has outer and inner part. Why the inner core is again solid? That has got to do not only with temperature but the pressure. So we will be doing this in the topic of crust when I will be explaining you. That is done in the next chapter, right, in the interior of the earth. So this is the formation of the lithosphere or the evolution of lithosphere. Next part comes the evolution of atmosphere. Now please understand, initially when you realize, because there was initial phase when if we say when the earth is just formed, all covered with, let us say, magmatic substances, somewhat like that, huge, large temperature is present, very high temperature is present. So what would the possible atmospheric condition during that time? That is known as a primordial atmosphere. At that time, you will be having hydrogen and helium only being present there, right? Hydrogen and helium being present there. So primordial atmosphere was composed of hydrogen and helium. Now, because if I am studying the evolution of atmosphere, we should understand there are a lot of stages through which the atmosphere has evolved. We are not talking about the layers of the atmosphere at present. That we will do in the topic of climatology and the climates and all those chapters will be done over there in the topic of atmosphere. Right now we are talking how it has evolved. So initially, when the earth just basically formed, at that time you will realize what the atmosphere would be, or that will be composed of hydrogen and helium. Now what happened is, because of the sun, you realize the terrestrial planets, if you see, are not gaseous in nature. See here, the terrestrial planets are not gaseous in nature because initially also strong solar winds basically wiped out all the gases from these planets. That is why they are not gaseous. Meanwhile, these are gaseous in nature because the solar winds, by the time they came here, were not so strong as experienced by these inner planets. That is why in the second stage, if you see, these strong solar winds, these are what? The solar winds from the sun, led to the loss of the primordial atmosphere. That means the solar wind basically wiped out these gases that were present in the primordial atmosphere. Next step that happened, you realize, concept of degassing. What is degassing? Cooling. See, initially the temperature of the earth was very high, right? Second step, that is why you had hydrogen and helium also. Second step is the solar winds basically wiped off all the primordial atmosphere that was present. Next is slowly the cooling of the atmosphere will take place. Now what will happen? The cooling of the earth later led to the release of lot of gases from the interior of the earth. This release of gases from the interior of the earth is known as degassing. Other gases, so many gases were released. So you have water vapor, you have nitrogen, you have methane, you have carbon dioxide, you have ammonia, and certain free oxygen. Very less amount, but released. That is why you realize nitrogen, carbon dioxide, methane, ammonia, and little free oxygen. Now this can be asked in your papers also. That degassing concept is associated with which of the following gases? Now, if they mention hydrogen and helium with respect to degassing, that will be wrong because it is associated with the primordial atmosphere. So, primordial atmosphere is dealing with only hydrogen and helium. Degassing concept is dealing with all these things, all the gases that came out from the interior of the earth. Now, what happened? You realize further cooling is taking place. Then comes the last stage. That is modification taking place because of the photosynthesis. Now, see, this is a very interesting concept. You should understand them very well. See, with the time you realize, as I said in this process, water vapor came out from the interiors. Now, water vapor came out, so there will be a process of rainfall that will also take place. Yes, because water vapor is there, then there will be rain also that will further cool the earth. Along with it, it will fill the basins and lead to the formation of oceans also, oceans or seas. So what happens? Rainwater falling got collected into the depressions forming oceans. So oceans formed within 500 million years from the formation of the earth. Clear? Now, 3,800 million years ago, MYA is million years ago, life began to evolve. Now, initially the life which began to evolve was within the oceans. Slowly you had plants and you realize that the process of photosynthesis started. Now, when the process of photosynthesis started, it released what? Oxygen. Now, oxygen content in the oceans increased and later on it basically led to close to 2000 million years ago, oxygen began to flood the atmosphere. So later on what you have see this, that the third stage, what we saw, what all gases are present, was slowly modified by the photosynthesis process. That led to nitrogen, major gas, then oxygen, water vapor, carbon dioxide, argon and all. So we have presently what we have is this, where nitrogen is in the maximum amount, then you have oxygen. Clear? So this is the concept of your formation and evolution of the Earth that we have done using so many concepts. This was the first lecture. Please remember this. We have done almost every concept that is present here in detail. Every aspect is covered. I would request you one thing very, very clearly. Make the best use of this lecture. You are getting a great opportunity. All teachers in every place will be doing a great job. Yes. But over here, what I'm doing is doing everything by hand, making the best use of what you can get out of these lectures. It is up to you. If you make the best use of these lectures, you will be really benefiting. And I'm telling you again, if you have listened to this lecture well, made the notes out of it, you will not face any issue in your prelims or mains examination. Yes, questions from current affair when comes, yes, you need to link them. But again, for that also basics are required. So hope you like the lecture. Hope you enjoyed the lecture. There will be other lectures also coming this week, and similarly the next weeks also. Till the time we finish the complete physical geography, we will be covering the geomorphological part also, the climatological part, that is the climate, then the oceans, oceanography as we say, and the biogeographical part also. I hope you enjoyed the first lecture and you got to know about so many concepts of geography. Similarly, we are here with the second lecture, that is interior of the Earth. Now students, please remember, before we begin this lecture, I am repeating the same thing. Please have your registers or A4 sheets along with you. While I'm explaining you, please note down these things. Pause the video wherever it is required and note down. There is a very big misconception that possibly just getting the PDF or downloading it from somewhere and simply copying it will not help. It is very important you see the lecture completely, make the best use of it, make your notes. By the end of the lecture, you will be having your consolidated notes which you can revise, which will be very useful for your prelims as well as the mains examination. Every single diagram over here is drawn by hand. So you will yourself feel that yes, we can ourselves also draw these diagrams. So my recommendation is going to be that please very carefully watch this video and make the best use of it. Let's begin with today's lecture. Now, first of all, the very interesting thing that comes is Earth's interior. Now today someone asked me, has any scientist gone to the interior of the Earth? We're not talking about Jules Verne books and those comedy lectures. No, nobody has actually gone. So now the question arises is, how do we know that the word like core, mantle, or what type of substances are present inside the Earth? Now that is a big question in itself. Now see, in spite of the fact of having so many technologies, we going to Mars and all, we are not able to understand Earth in totality. Now, we have the knowledge about the Earth or the Earth's interior based on various direct and indirect sources. Now, we will study all of them little, what is required by the civil services. But remember, even till today, we do not have a very, very precise information. If someone tells me, can there be some other metal that is present inside the core or let us say the mantle? Possibly yes. But based on the limited knowledge that the scientists have, we are going to study and analyze the Earth's interior. Now, let us begin. Now, the most important thing is, before we study the Earth's interior, we should actually understand from where we have got the information. Please understand, I could have taught you mantle, crust, core before even explaining this. But now let us assume that you are a scientist along with me who wants to study the Earth's interior. But how will you study the Earth's interior? So similarly, from that perspective, I'm going to teach you, right? So supposingly you want to study Earth's interior and you have no knowledge about it. So what would be the possible sources? Now, there are certain direct sources. I'm listing them here. We'll be explaining them also to you. Direct sources, that means directly you are getting to know about the Earth's interior. First, deep earth mining and drilling. Now, when you deep drill, let us say a few kilometers deep, possibly you can get samples of the minerals or the rocks that are present. Based on that, based on the extraction, you can possibly test them later on in the lab and get to know what type of minerals are present, right? Similarly, surface rocks, rocks that are present on the surface. and volcanic eruptions. We'll be dealing and understanding them again. So when the volcanic eruption take place, you know the lava is there. Possibly you can get to know what is the composition of the lava. Similarly, there are certain indirect sources. Now you're not getting to know directly because over here you can possibly test a rock. You can test the composition, but over here you cannot. So that is why it is known as under the category of indirect sources. There are certain temperature and pressure variations. We'll be understanding them in the next slide, don't worry. Meteors striking, gravitational anomalies, magnetic field and seismic activity. Now these are few of them which are very important from the indirect sources. Please remember one thing very categorically. While we are focusing on this content from the basis of NCERT, I had told you in the previous lecture also that I will be expanding the concepts that are present in the NCERT for your convenience, so that the gap between the NCERT and actually what is required for the civil services is basically filled. So that vacuum is filled, right? So let us analyze each one of them in a little bit detail so that you can write an answer also based on that. Let's see. First begin with the direct sources. Okay, let's remove the indirect sources from here. We have removed it. Now let's see direct sources. Deep earth mining and drilling. Now you know that it reveals the nature of the rocks. Example, 12-kilometer deep hole mined at Kola Peninsula. Now similar minings have been done in various regions. And based on that, you have basically extracted certain minerals, rocks, and then you have tested them. What is the possible composition? Now this is a direct means because you are basically testing. So you know that, okay, at this depth, we are finding these type of minerals that are present there. So deep earth mining and drilling also helps it, but it has a very big limitation. See, over here we see 12 kilometers depth. Now, if you go further, the temperature increases so much that mining activity is not possible. So if you see the complete earth as a slice, you will see if you want to go to the center, it is approximately 6,300 kilometers. Now we know. And you compare it with 12 kilometers, it is hardly anything. So drilling is actually has a lot of limitation because it requires a lot of money also. Even if it is sponsored by the government, even then you realize it is very difficult because the temperature keeps on increasing and mining activity is not possible. So that is why it has its limitation also. Though till 12 kilometers or approximately till whatever the mining is done, whatever rocks or minerals that you can extract or get to know, you can test it and get a brief knowledge about the fact what type of minerals are possibly present. What is the possible composition at that particular depth? Second, surface rocks. Now these are the rocks which are basically present on the surface. Now there are certain regions, obviously when you will be having volcanic regions or some other regions, you will be basically having certain type of rocks present there. On the other hand, some other places, some other types of rock will be present. So based on that, you get a basic idea that, okay, if these types of rocks are present here, so possibly they might be associated with some type of minerals that are present inside the earth also. So a brief knowledge, it doesn't give you an exact knowledge, but yes, it gives you a little bit, let us say, an estimation that these types of minerals or somewhat these types of minerals might be found in the interior of the earth. And this might be a possible composition also, right? So it gives you a brief estimation. You cannot give a 100% estimation because you know that rocks present in one region might have come here because of various activities, let us say transportation through various means. So there are a lot of possibilities, but it gives you a brief idea that certain rocks present on the surface of the earth, similar minerals might be present in the interior of the earth also. Next comes the volcanic eruptions. Now, you know, when the volcanoes are erupting, now you have the lava around them. Now, based on the analysis or testing of the lava, you can possibly analyze what type of minerals or composition might be present inside the interior. Now, when you analyze the lava, possibly you get to know that iron is present, nickel is present. So you have an estimation that possibly in the interior, iron and nickel might be present. Yes. So based on that also, you might have other composition like silica might be present, whether it is more or whether it is less. So you get to know that silica is also present inside. So a lot of things are possible over here and a lot of predictions can be made. But again, these, in spite of being the direct sources, you are not able to get a very precise picture. Please remember that. These are based on the estimations again, that this is possible, that is possible, this is possible. So, but these are important because they give you a brief idea. Initially, when concepts of seismology were not developed, these were actually helping the scientists to analyze what could be the possible compositions of the interior.
right? So firstly, we have done with the direct sources, that is, gives you a brief idea. Now, let us move on to the indirect sources, right? I had listed 5 of them. Among them, please understand, in spite of all these, seismic activity is the most important, because we will be analyzing seismology. What are seismic waves? How do we basically get to know about the interior based on these waves? So that gives a brief idea. So in the examination also, after we analyze these, in the examination, they can very categorically ask you a question, in the mains examination in particular, how do seismic activities help in analyzing or identifying the interior of the earth? Secondly, there are certain categorizations also of the seismic waves. They can be asked in the preliminary examination, and it has been asked multiple times also. So first of all, before going into detail with regard to the seismic activities, let us analyze the various indirect sources. First, temperature and pressure variations. Now, just tell me one thing. Whenever there is temperature or pressure variations, that gives you an estimation possibly that inside the earth there might be certain variations with respect to the matter, the state of matter. Right now, let us analyze. Before this was identified also, at present you have a basic knowledge that the interior of the earth, you have a core. The outer core is molten, but the inner core is solid, right? Now, right now, supposingly you don't have no information regarding this, but we have already studied them in the school. Have you ever thought that why the inner core is solid? The reason behind it is, please see, the outer core and the inner core have a very high temperature, there is no doubt. The outer core has a very high temperature, that is why it is in a molten state. But one would say that when you go inside, the inner core also should have higher temperature. Yes, it has. But the difference that arises is the inner core experiences much more pressure than in comparison to the outer core, because the outer core is also exerting a lot of pressure inside the inner core. That is why the inner core is in a solid state. Now tell me one thing, based on the pressure variations or the temperature variations, you get a brief idea that possibly there is different states of matter that are present inside the earth. Now, based simply on temperature and pressure variations, we might not be able to analyze or get to know. That is why what I've mentioned over is seismic activity. This is the most important. This basically helps you analyze these things also. So, right now, simply analyze that these variations help you to analyze what type of state of matter that might be present inside the earth. There are certain variations. What are the reasons? That will be analyzed as we go further in the lecture. Second, meteors. The surviving fragments of meteoroids give an insight about the earth. Now, these fragments basically falling on the earth, right? Some of them are able to fall also. So, those fragments, when are analyzed, they give us an estimation possibly what might be the interior of the earth. Why? So, there are a lot of theories. Like when in the previous lecture we were discussing about the origination of solar system, we basically said give theories like planetisimal theories and so many other theories, even Big Bang theory. So people basically estimate that if certain bodies were formed during the similar period, there is a possibility that the composition might also be similar. So it does not mean that merely analyzing the meteor tells you that these are the exact composition that is going to be inside the earth, but it helps you or gives you an idea that possibly these types of minerals might also be present inside the earth, because if we assume the Big Bang theory, 13.8 billion years ago, so where energy was slowly converted to matter, right? This is what it basically states. So possibly similar compositions might also be there. That is why meteors can be, or the remains can be basically used as a means of estimating that possibly these minerals or some type of this type of composition might be present inside the earth. It does not give you a precise information, because there's quite a possibility that various meteors or other bodies that are present might be having different composition. That can be there, but it gives a brief indication that possibly these minerals can be present inside the earth. Next, gravitational anomalies. Now, certain changes in anomaly, gravity, or certain regions where gravity is more. Right now, when we are analyzing this, I'm not going to give you the reasons precisely why it is happening, because that will be done in the next lecture where we will be doing seafloor spreading and all, right? Over here, let us assume you are analyzing. Right now, you do not know the interior of the earth, and then you are analyzing. So from that perspective, you are doing. So gravitational anomalies. So if you even observe, you will see the gravity is stronger near the poles. It helps to understand the distribution of material inside the Earth's crust. There are a lot of factors that are responsible for gravity being more at the poles, but from the prima facie observation, one can see possibly there is certain composition of minerals that are present that basically changes the gravity or gravity being more in certain regions. So possibly that helps us to understand the composition of the earth present or what is present more or what minerals are present more in certain regions. So this is a general outcome from the first observation. These anomalies again, when we go further, we will be analyzing how the shape of the earth, how the centrifugal forces and all these forces, centrifugal forces, they are balancing, and that are the reasons for the gravitational, let us say, forces being more at the equator and less being at the, more being at the poles and less at the equator, that we will analyze later. But over here, just seeing at the gravitational anomaly, the first thing will be possibly certain minerals are present at certain regions inside the earth that are possibly responsible for gravity being more at certain regions. So this is again the first or indirect evidence with respect to the interior of the earth. When I go to magnetic field, magnetic surveys reveal information about the magnetic materials in the earth. Now, if you realize that, if you see the Atlantic Ocean, you will be realizing that there are, in a way, seafloor spreading concept is associating, which we'll be studying in the next chapter. You will see that there are evidences of pole being reversed, North Pole and South Pole, a certain magnetic material being present there. By default, can we say that there are certain substances which are magnetic in nature or have magnetic-like composition or constituent, or let us say iron being present there, right? So by these things, by the magnetic field, or let us say the magnetic field being present here, we basically get to analyze that possibly certain materials are there which are basically adopting the characteristics of the magnetic field when they are coming out in the form of lava and aligning themselves to the magnetic field. So possibly we can get to know that there are certain substances which are magnetic in nature, right? That is why this also helps us to analyze what is a possible interior, what is a possible composition of the interior of the earth. Again, over here, it does not tell you the precise composition. It gives you an indication that this can be the possibility. Now, when you see all these four, they are indirect, yes, but along with them, they are not completely convincing with respect to what is the composition or the interior of the earth. The last one is that which is the most important, seismic activity. Seismic waves are the crucial sources of information about the earth interior. We will be analyzing this particular topic in a lot of detail because this is the source, the primary source in a way through which we have been able to analyze what is possibly the interior of the earth. Now, being very practical about this, you have read the direct sources, you have read the indirect sources, particularly the four. These again convey or give you an indication what is a possible interior, but does not tell you exactly what is the interior. So seismic waves have been able to resolve this problem to a great extent. Though new discoveries are continuously being made, so we'll analyze them also. Let's see. Seismology and Earth's interior. In the examination, as I've already told you, they can ask you very directly the types of waves. They can ask you how seismic activity is helping you to analyze the possible interior of the earth. A very good question, 15 marker can come, and this is the answer which we're going to study over here. Now, seismology and seismic wave. Now, what is seismology? Now, seismology is basically a branch of science which studies the various aspects of seismic waves that are produced during the earthquakes. So it is a branch of science which basically analyzes how and where the waves are being created, and along with it, the various aspects that are associated with those earthquake waves are basically studied by this branch that is known as seismology. This is a broad science. It has basically helped you also, this branch, in analyzing the interior of the earth. Now, this is a branch, but when I talk about what are we basically talking about, it is the seismic waves. Now, these are mechanical energy waves caused by an earthquake. Now, when you have an earthquake, you realize there is energy that is released. Based on that, certain waves are created. And these waves basically help us in analyzing the interior of the earth. How? We will see this. Now, please understand. The moment you hear about the seismic waves, you know that possibly that means there is certain earthquake that was caused and that led to release of energy. We will be studying earthquake also over here, so don't worry. So when an earthquake happens, due to any reason for that matter, energy is released. Now, energy is another form of waves. Now, when we are talking about seismic waves, we basically categorize them into various categories. Now, see, types of waves produced. There are two broad categories. First are the body waves. Now, the body waves has two further categories. P waves, that is known as the primary waves. S waves, that are known as the secondary waves. Right? Body waves. Now, these are the waves which are basically inside or the interior of the earth. Now, there are other category of waves, surface waves. When these body waves basically interact with the surface, it leads to the creation of surface waves. We will be seeing the definitions, don't worry. Those are known as the surface waves. The surface waves themselves are of two categories. First, love waves. Second, relic waves. So, again, let's see. Due to the seismic activities, two broad categories of waves are created. First, you have the body waves, then you have the surface waves. The body waves are of two categories. First, the P waves, the primary waves and the secondary waves. Then you have the surface waves, which are two categories, love waves and the relic waves. Done. You can just copy it down if you want. I'm giving you a minute. Quickly. Types of waves, body waves, surface waves, primary, secondary, love and relic. Now, having understood this, let us study each one of them in detail. When I talk about body waves, they travel within the body that is interior of the earth. When let us say an earthquake happens, the waves which travel inside the earth, right? There's an earthquake is caused, so waves that are traveling inside the earth. These are known as the body waves. That is why it is known as body, because it is traveling inside in a way, if you consider earth like an organism, its body, that is the interior, inside that the waves are traveling. So those waves that are traveling in the interior of the earth are known as the body waves in a broad category. Clear? Now, there are two categories, as you are already known, the S waves and the P waves. Now see, this question has been repeatedly asked in your preliminary examination. See, if I take last 20 years papers, you can see at least 4 to 5 times minimum. Questions have been asked directly and 2 to 3 times indirectly. So that means there is a great possibility of this question being asked in your preliminary examination. Obviously, in the mains, I've already told you the question, where they can ask you how seismic waves help you to analyze or decipher the interior of the earth, right? I will be giving you this question at the end of the class also to practice. Now, for that, you need to understand what these waves are. Let's see. P waves and the S waves. Now, please understand, P waves are by nature the fastest waves. They travel the fastest in comparison to the other waves that we have just now mentioned. Now, please understand there is unique nature of these waves. These waves can travel through solid, liquid, as well as gases. Now, when an earthquake is caused, let us say, and energy is released, that means P waves start moving, let us say traveling. I know very well that whatever be the composition of the interior of the earth, these waves will basically travel through almost all the mediums, because you will say inside the earth possibly there can be solid, liquid or gas, whatever be the case. Let us assume, right now we do not know the interior. Let's assume that. So that means P waves can travel through possibly all the states of matter, right over here, all the 3 states over here. That means solid, liquid and gases. So this is the nature. Now, they are longitudinal. Please understand, when you were in school in the physics chapter, when you study sound, you realize that sound waves are longitudinal waves, the way they travel. Similarly, the primary waves are also longitudinal in nature. That is why when you see, when the waves travel, there is compression and rarefaction between the constituents through which they are basically traveling. Like sound wave, when I'm speaking to you, you will be realizing there is compression and rarefaction within the air also. That is why the sound is able to travel. Similarly, the way they are moving, it is also related. Let us say they are moving from one, let us say they are traveling through a medium, let us say solid or liquid. There is compression and rarefaction. That is how they travel. That is why they are longitudinal in nature. Next, P waves vibrate parallel to the direction of propagation. Yes, that is why they are propagating or moving parallel to the direction of propagation. Right? See? Parallel. That is why this statement is written. They vibrate parallel to the direction of propagation of the wave. Now, these characteristics which I have presented to you right now are extraordinarily important.
every single statement over here forms a core of your understanding. So please understand them. They are the fastest. They can travel through solid, liquid and gases. They are longitudinal waves like the sound waves as we basically see or have studied also. And if they're longitudinal, what do we say? While they're traveling through a medium, there is compression and rarefaction. That is why these waves basically propagate in that nature. So that is why we can say they propagate in the direction parallel to the direction of propagation. They are propagating in the direction parallel to the propagation because it is also moving in this case, and there is rarefaction and compression within the same direction where it is moving. So that is why parallel to the direction of propagation. So these are the P waves. Now comes the secondary waves or the S waves. Now see, when an earthquake is originated, you will be seeing P waves and S waves are released. P waves can travel through solid, liquid and gases, but S waves have a unique characteristic because of their nature that they can travel only through solid. They cannot travel through liquid or gaseous state. Please understand that very well. Now tell me one thing, just based on this, if there is certain substance inside the earth which is in a complete liquid state, possibly we will not be seeing the S waves crossing that. Obviously, now the question will come, please understand. Question will come, sir, in that case, is mantle also, because see, mantle is also in a liquid state. See, these queries come in your mind. I'll not answer them right now. I'll be answering you after we have studied the interior of the earth. Keep it in mind. Remember, when we have completed this lecture, you will be writing this answer in the comment section. The question is, if we say the S waves are traveling only in the solid state, then can S waves cross the mantle? Now you will say, sir, we do not know what mantle is. Bache, you know which you have studied in the school. I'll be teaching you here, don't worry. Keep this question in mind. We will be coming back to this question after approximately 10 minutes. You'll see that. Okay. They travel only in the solid state. But when a medium is solid, they can travel. They cannot travel through a liquid or the gaseous state. Second nature, why this happens? Because it is transverse in nature. You have already studied, when you study the chapter of physics in school, you see that light waves are transverse in nature. Similarly, these waves, secondary waves, are transverse in nature. The direction of propagation is perpendicular to the direction of the wave direction. See, the direction of vibration basically is perpendicular to the direction of propagation. So what happens is, please understand, in this particular case, the direction of the vibration on the S waves is perpendicular to the wave in which it is moving. Because of this characteristic being there, we realize that it is not able to move in the liquid or the gaseous state and only in the solid state. Now, these two things which you have studied over here forms the core idea of the P waves as well as the S waves, which you should keep in mind. Having done this, you have 2 minutes to quickly note it down. These are the characteristics also, and which you can use to differentiate between both of them. Quickly note it down. The major thing, please remember, they are longitudinal. They are again transverse in nature. These P waves vibrate parallel to the direction of propagation. Their vibration is perpendicular to the direction of propagation, as I've already mentioned. These are the core differences that are there. Now let's move ahead. Second broad category are the surface waves. Surface waves are the body waves interact with the surface rocks and generate a new set of waves. They move only along the surface. They are known as the surface waves. Now please understand, when the body waves are generated, they will be moving through in all the directions. Let us say in the interior of the earth, if a earthquake or earthquake-like activity happens, seismic waves are generated. Now these waves will be moving in all the directions. The ones which are moving inside the interior of the earth, it is fine. We know them and the form of the body waves, but then certain waves will be traveling towards the surface also. Now these body waves, when they interact with the surface rocks, it will lead to a generation of a categorization of waves which are known as the surface waves. In a way, when the body waves interact with the surface rocks, it leads to a creation of a set of waves which travel only on the surface of the earth. That is why they are known as surface waves. Now they are traveling on the surface. that is why the most destructive in nature for us, because that will lead to, let us say, buildings falling, loss of human life, destruction on large scale, because these waves are traveling on the surface of the earth. That is why that they are known as the most destructive in nature for us. Clear? What is surface waves and what are body waves, you know? Now, within the surface waves, there are two categorization. See, love waves. Let us assume that there is a road, right? If a surface wave in the form of love waves is encountered by this road, let us say an earthquake happens over here and these waves are traveling, it will lead to a horizontal zigzag like shape over here. Like a snake like shape will be transformed from this shape to this shape. That means let us assume there is a road and there is an earthquake that happens, right? And let us say the waves which are basically moving and they come in contact with the road. They will deform the road. You have seen this earlier also, that there is deformation of the roads that happen. If there is a deformation in the form of a snake-like pattern, it is because of the love waves. Why? See, it involves horizontal or side-to-side motion like a snake. There is no vertical motion. That means, see, assumably, let us say this is a road, right? If you see from the top, you will see this is a road. Now, supposingly the road is shifted in a horizontal manner, left, right, like a snake, it is not shifting up and down, only zigzag horizontally. That means it is caused due to the love waves, because these waves only transform the things on the surface in the form of a horizontal manner, not in vertical level. That is why this involves only the horizontal side to side movement, because the snakes move like this. So that means if there is a single road and a love wave, basically this road encounters a love wave, there is a possibly this type of transformation of the road will take place, because it moves on a side by side horizontal direction, not vertical. So there will be no up and down thing that will happen. Understand that very, very well. Whenever you see such type of state or situation where there is only transformation left, right or zigzag pattern, that will be basically what? Due to the love waves. Now, this is something very important. You are seeing these things from a top view. Please understand. Supposingly you are in the space and you are seeing the road. You will be seeing from the top the road is straight, but after encountering the love waves, they will be transformed in this zigzag pattern. This is known as the love waves, right? So they move or transform or they travel in a way, let us say in such a manner that it leads to basically horizontal movement or transformation of the things that are present on the surface. Relic waves. Now these travel in rolling and elliptical motion. They cause vertical and horizontal ground movement. Now these are something important. These only called horizontal movement. These called vertical and horizontal movement both. In a situation, let us assume, there is a single road. It has been transformed left and right also, and certain places up and down also. Supposingly this road was like this, right? Now there is a transformation where this has been pulled up, this has been pulled down, and there is zigzag motion also. That means it involves horizontal as well as vertical motion. It is due to the relic waves. It is due to the relic waves. Now you'll ask me, sir, just tell me one thing. Why haven't you mentioned P and S waves? Beta, please, because P and S waves are body waves and they are in the interior traveling. When the P or the S waves, that means that the body waves interact with the surface rocks, it leads to the creation of these two types of waves. If there is transformation of the things that are present on the surface only in the horizontal or the snake-like pattern, it is because of the love waves. Otherwise, if there is horizontal and vertical transformation, it is due to the relic waves. Is it clear to everybody? This is a very simple concept. That is why I have told you this is zigzag also and up and down also. In this particular case, there is only horizontal transformation. Over here, horizontal and vertical transformation of the things that are present. That is why when you see post an earthquake, certain cases roads might be just zigzag from the straight pattern. Earlier they were straight, but later on zigzag. So that means love wave. Okay. Secondly, if there is certain transformation, or let us say impact of the waves, due to which there is zigzag pattern also, and some things have been pulled up and something have been pulled down, then that is due to Rayleigh waves. Done. This is a very, very important concept. This has not been explained in most of the books properly, and that is why the students find it very, very difficult to comprehend it. Please make sure that you understand this concept well. Repeat it again, see the video again. This is something very, very important. Clear? Okay. Now, before I move ahead, it is also important because to understand certain basics of the earthquakes, after that only I'll be able to explain you more about the S waves, P waves, and also about how seismic waves basically helps us to analyze the interior. So for 2 minutes you will have, for few minutes you'll have to wait to understand these concepts also, because it becomes very, very important. So these are some basics of the earthquakes. Now let us see earthquakes. Now earthquakes are vibrations of the interior surface caused by sudden energy release in the Earth's crust or the upper mantle. Now it might be caused due to various reasons, we will see, but there are what are earthquakes? These are vibrations. Now these vibrations lead to the release of energy. Now you've seen that these energy released is in the form of these waves, which you see in the form of the S waves or the P waves. Now that might be caused where? In the Earth's crust, or let us say the part of the upper mantle. Now what are the causes because of which it can happen? Now please understand there are certain concepts, like I'm using the words like plate tectonics and all, but you don't need to worry. We'll be doing the concept of plate tectonics in the next chapter also. Right now, just understand the brief concept, because it is important for you to understand this in order to understand earthquake. I could have avoided this concept of plate tectonics here, but it is important because we are doing the chapter here, so you should understand earthquakes also. Then obviously we will be completing this concept of plate tectonics, continental drift theory in the next chapter. So right now, just understand the basics here. Causes. Now the earthquake, due to the plate tectonics, you know there is certain release of energy during the tectonic activities in the Earth's crust. Let's see this. You know that very well that there are plates, right? Plates that are continuously moving. The details, which obviously we'll do in the next chapter. Now you see that supposingly this plate is moving down over here. These are due to the convectional currents that are created in the mantle. Supposingly, like you see in the climatology chapter also, the convectional currents are created. Similarly, we have similar convectional currents according to certain theory. That is the convectional current theory, where due to these currents, this plate, supposingly this is a plate, this is also a plate, this is also a plate. So because of this, because the Earth's core is really very hot, it comes here, there is because of this temperature, this leads to the rise of the convectional currents. Now this convectional currents pulls the plate further towards the interior. Now this plate over here, what you will see, it is basically being pulled down. Clear? Now because of this, you know that it might lead to certain earthquakes being generated. First thing. Similarly, you will see these plate tectonics can be of various kinds. Now see, this is just a diagram. Now see, when the plates are moving, it is not only of one type, it can be of multiple types. Let us assume over here, when you see this plate basically moving or subducting beneath this particular plate, can I see it from this manner? That means this is a destructive plate boundary where this plate is going to be destroyed because it is going to, this portion is going to melt as it is going to go inside the mantle because of the rise in temperature. This movement will lead to, again, lot of energy being released in the form of earthquakes, because as a plate moves, subduct, obviously energy will be released to compensate it. Secondly, if you see this particular portion, this part is going to move ahead, so that means new material will be coming out in the form of lava. And over here you will see new plates are being formed. This is something that you find in the Atlantic Ocean. That is why you find the Atlantic ridge and all. It is an outcome of this types of movement that is taking place. Now what happens? There is a lot of volcanic eruption that is taking place here. That can also lead to earthquakes, because volcanic activities lead to earthquakes also. Third is, rather than something being destroyed or something being created, there is a possibility that two plates might, let us say, move close to each other or sliding across each other. Let's see this. Right? Now, nothing is being destroyed over here. Like over here, you realize that plate moving down is being destroyed. Over here, new part of the plate is being created because there will be volcanic eruption and it will lead to creation of new plates. That is why it is known as a constructive plate boundary. There is destruction of this plate. That is why it is known as destructive plate boundary. Over here, nothing is being created or destroyed. That is why it is known as conservative plate boundary. But because of this sliding, obviously there is going to be release of energy. That can also cause earthquakes. Over here, I am not using complex terminologies because you haven't done plate tectonics. So right now, simply understand from a very simple concept that there are certain plates. One is being destroyed. It can also lead to earthquake. Something is being created and volcanic eruption is taking place. That is why lava will come out. A new part of the plate will be created. It is lead to construction, but it will release energy also. That can cause earthquake. Over here, then two plates are sliding across each other, along with each other. Though there is no creation or destruction, but because of this sliding, there is also release of energy that can also cause earthquake. Now, these are the factors which can release energy in the form of the P and the S waves. These are the causes, right? When someone asks you, rather than asking earthquakes, they can ask you a question, explain how P waves and S waves will be created. In that particular case, you should understand they're talking about the creation of earthquakes, and that is why because of those earthquakes, you have the P waves and the S waves. Secondly, they can ask you, in order to pull your leg, they can ask you, explain how the body waves, or in a way, even more, if they want to make it more difficult, they can ask you how the love waves or relic waves are created. That means body waves. So you should know that body waves are created because of the surface waves. Surface waves are generated because of the earthquake. Earthquakes are caused due to these factors which I am discussing right now. First is plate tectonics. When you would have done the plate tectonics in the next chapter, these things will become very clear. Over there also I will be talking about the creation of earthquakes. You don't need to worry. Right now, because we are doing seismology and the seismic waves, little bit details should be known to you so that you can correlate with these S waves and the P waves, right? So first is plate tectonics. Brief idea I've given you through this diagram. This diagram has been represented in a more easy format in this way. So the first reason is plate tectonics. Second is volcanic activities. If let us say there is massive volcanic activity, you yourself see that it will lead to a lot of vibrations within the crust, obviously associated mantle, and that can also cause earthquake. Please remember, earthquake and volcanic activities are related to each other. Volcanic activities can cause earthquakes, and earthquakes can also lead to creation of volcanic activities, which we will be doing in the next chapter in the distribution of ocean and continents. Second, rockfall. Very large scale massive rockfalls that happen can also lead to vibrations. I'm not talking about small rockfall, massive rockfall that can happen. That can happen inside the oceans also. So that can also lead to vibrations causing earthquakes. And mining activities. If you see, there have been a lot of cases in the Himalayan region where continuous mining activities or drilling activities that are happening for development causes that have basically led to vibrations, and that further have led to other vibrations in the form of earthquakes basically being generated. So that is a ripple effect. So these are the other causes. Now, how do you measure the earthquake? That is again important. Richter scale is basically measures the magnitude, amount of energy released. Mercalli scale is basically measures the intensity, that is effect of the earthquake. That means intensity over here means what scale of destruction is being done. Magnitude basically measures the amount of energy released. Now, amount of energy released basically helps us to understand what extent of these P waves and S waves are basically being generated, which will later help us to also analyze in a way, predict that what will be its impact with respect to the surface. Now, it depends upon where the earthquake is located, obviously, inside the earth. There are certain concepts that are associated with this particular aspect of earthquake generation, so please understand this very well. You have till now studied what is earthquake, body waves, surface waves and all. Now, let us see this because this is very helpful in analyzing the concept of body waves and surface waves and their issues associated with it. Now, supposingly, please understand there is an earthquake that is generated in the interior of the earth. Now, this is a surface or the crust, right? Let us say crust part, or this can itself be a crust, but this is the surface of the earth. Let us say this is the surface of the earth where you have the trees and the people living here. Inside the earth, it can be a crust or the upper mantle. where the earthquake is generated or the earthquake originates. When the earthquake originates at this particular point, this point is known as the focus or the hypocenter. See what? You can call it a hypocenter. Hypocenter or focus, same thing. So hypocenter or focus is a point from where the earthquake originates due to any activity, let us say tectonic movements we are talking about. From this particular point, because an earthquake generates means energy is being released, so that means energy will be released in all directions. When I'm talking about energy being released, what did I say about the body waves? I said that basically when we're talking about seismic waves also, these are what? Mechanical energy waves that are being generated. So over here, can I say when the energies are being released, we are talking about the body waves. That means S waves and P waves being generated. That means these movement that is taking place is in the form of P waves and S waves. So that means P waves and S waves are moving in all directions from this particular point. Clear? Now please understand. We will study the interior, obviously, how we will decipher it after a few minutes, but let's understand this. Now from this point, P waves and S waves are moving in all direction. Now when the P waves and S waves, basically that is what? The body waves. The body waves, when they reach the surface, let us say this. Now you will see that as these pink dots you are seeing, these are, let us say, P waves and S waves, right? When they come in contact with the surface rocks or the surface, it will lead to the generation of surface waves. And secondly, the point directly above the focus on the surface is known as the epicenter. Two things you have studied. The body waves will, in the form of the P waves and the S waves, will be moving in all direction. When they reach the surface, those body waves will lead to the generation of surface waves. First. Second, the point directly above the focus or the hypocenter on the surface is known as epicenter. That is why, please remember, at this point, massive destruction or the maximum destruction will happen because it is lying directly above the hypocenter or the focus, right? Because other regions, if you see this distance or you compare it to this distance is more. This distance is more, sorry, this distance is more, this distance is less. This distance being less means that energy will reach this point faster or it takes lesser time. So that means the energy that has taken from this point to reach this point is less. That means time taken to reach that point is less. So loss of energy is less. So more destruction will also be there. Over here also, the P waves and S waves will reach the surface, but it will take a lot longer time. So more dissipation of energy will have happened. That is why this point or the epicenter is a region where maximum destruction takes place. Clear? Secondly, second thing you need to understand, if assumably I'm taking 2 to 3 earthquakes of the same magnitude and all, right? Now if I say that the epicenter is here, or let us say the hypocenter is here, sorry, new hypocenter. This is, let us say, the old hypocenter. What does it mean? Let us say an earthquake took place in, let us say, 1900s. Then an earthquake took place in 2000s, let us assume. If I assume that the magnitude of these two earthquakes is absolutely same. What happened in 1900 and what happened in 2000, the magnitude is absolutely same. That means the energy released. Now, because the epicenter over here, this is the epicenter and these are the focus. If the focus is, let us say, closer to the surface, if the focus or the hypocenter, see, if the focus or hypocenter is close to the surface, if the focus is close to the surface, more destruction. More destruction. Why? Let us say this happened in 1900. Over here, what happened is that it was, let us say, very deep inside, let us say interior of the, let us say in the upper mantle only. But this is, let us say, in the crust part. Now, because from here, the energy is traveling, it will take a relatively longer time to reach this point. That is the epicenter. By that time, a lot of dissipation of energy would have happened. So what surface waves that are generated over here will be of a lesser intensity. On the other hand, if the focus is over here, the time taken to travel this will be less and the energy dissipation will be less, so more destruction will be there. So what you can analyze from this is, that closer to the surface, if the focus is located closer to the surface, more destruction will take place, provided the magnitude of the earthquake is same if you compare certain earthquakes, right? So we have got to know about the fact that these P waves or S waves, when interacting with the surface, will lead to the generation of what? The surface waves. These are what? Body waves. What are these? Body waves. Clear? Let's move ahead. This is a distribution pattern of earthquake. Now, there are certain zones which have been demarked, which are more prone. Now, if you realize this, what is marked in yellow is a very low damage zone. That means there is very lesser chances of earthquakes happening over here and lesser damage happening. So these are these regions over here, which are present here. If you go further, you will see second is a low damage risk zone. What is marked in pink over here refer to the low damage risk zone, all these regions surrounding the zone 1. Zone 3, moderate damage risk zone. That means, okay, relatively more damage can be caused if the earthquakes happens. So more vulnerable. So these, what is marked in white basically refers to the moderate damage risk zone. Fourth, what is marked in orange over here, high damage risk zone. These regions are the high damage risk zones. That means relatively higher damage can be happen because this is zone 4. The maximum is zone 5, that means very high risk. That means these regions are very vulnerable to the earthquakes. A lot of destruction can basically happen and problems can happen. So this is one map that I've drawn by hand, and it is very important so that you can basically use this while a question on earthquake is asked. Not necessary this has to be drawn when you are doing or answering seismology, but or seismic about the interior of the earth. But if it is asked with respect to hazard and all, then you can definitely use it, right? This is a hand-drawn map. Let's move ahead. Consequences of earthquakes. Damages and destroys infrastructure, settlement, transport and communication, you all know. Material and socio-cultural losses, losses of their lives happen obviously. Leads to fire, dam fires, landslides. Leads to death of people, economic losses to the people and also to the government also. They have to again spend a lot of money in order to build the infrastructure. So these are certain consequences of the earthquakes. Now please understand how to mitigate it also. Establishing earthquake monitoring centers, again important. That is why when you say observing these waves, various monitoring centers basically refers to detectors like seismographs, all these things being located at various parts, so that the moment anything happens, you are basically aware of it. Obviously, it is important because predicting earthquake, let us say, is a very difficult task because these are very dynamic in nature. Something just happens in a second and an earthquake is generated, and it is very difficult to estimate it from a perspective like they cannot tell you that after 6 months on this date the earthquake will happen. You cannot detect that. It is very dynamic in nature. Yes, geologists do work on it and they say there is a possibility that earthquake can take place in the coming time. That is what they can imagine or tell you for further planning. But again, when an earthquake is generated or originates, then obviously these monitoring centers basically detect it quickly and then quickly inform the people if certain further planning has to be done, particularly in cases of further outcomes that happen. Let us say if an earthquake has happened, possibly a tsunami happens. So it can be helpful in that case because these devices basically detect them and basically inform the people that you need to evacuate certain places because tsunami can happen, which is another outcome of earthquakes, right? Extensive use of geographical positioning system, vulnerability map, educating the people, modifying the house types and building designs again become important. Please understand this. In India, we should also take examples and references from Japanese architecture, where they know that every time they have most of the severe of the earthquakes, their construction is also in such a way that it can basically tolerate those earthquakes. So similarly, this should also be replicated in India, right? Now, having done P waves, S waves, having done the concept of epicenter, concept of hypocenter, how it is generated, how those P waves basically reach the surface and leads to P waves and S waves reach the surface and creates the surface waves. We have done that. Now let us come back again to the concept of shadow zones. Why I taught you the earthquake concept in between is so that you should understand the concept of hypocenter and the epicenter, right? Now this is helpful in analyzing how you get to know about the interior of the earth. See here. So emergence of shadow zone. What is shadow zone? Now see, across the various parts of the earth, even on the surface of land and ocean, there are a lot of devices that have been placed in order to detect the earthquake waves or these seismic waves, right? But while detecting, we can basically detect certain waves in certain regions, but in other regions, you're not able to detect them. Why does this happen? Now, because of these things only, we got to know about the interior of the earth. What are shadow zones? Let's analyze. The shadow zone is an area of the earth surface where seismographs cannot detect the P or the S waves from the earthquake. That is why the question arose, why is it that if I suppose within the earth there is a point where earthquake is generated, the waves are traveling in all the directions. So if let us assume this is the earth and let us say an earthquake is generated here, we know that very well that P waves also, let us say these are the P waves. P waves will be traveling in all direction. Similarly, right now we do not know what is the interior. Let us say similarly, let us say this is the S waves. S wave should also be traveling in all the direction. And earthquake generated over here should be detected over here also. The waves should be detected here also, here also, here also, here also, everywhere. But this does not happen. If an earthquake generated at a particular point, if it is releasing energy in all directions, the energy or these waves should be detected in all the parts of the surface. This is but obvious. But what happened is the scientists noted the fact that P waves are detected in certain places, certain not. S waves are detected in certain places, certain not. Then we got to know about the fact that there is a possibility of certain substances present inside the interior of the earth which basically are restricting this movement or creating certain impact that is leading to detection of these shadow zones. Now please understand this again. Before I basically explain you, let's see this concept. Let us assume this is a point which we can call as a focus, right? From the focus, right now I am not taking the S waves, I'm just taking the P waves so that you can analyze. We will take it independently. Supposingly, this is a point where the earthquake has originated. Now, can I say that from every direction, from this point, from every direction, the waves will be generated? Now, see what happens is, you should understand this very well. I told you that P waves can travel in solid, liquid and gases, but you should understand that when the density, when a wave is traveling from one medium to another, obviously the density changes take place. Now the density changes basically leads to a lot of refraction. That means if you see bending of these waves, in a simple way you can say refraction means bending of the waves takes place. That is why you see when the energy is released over here, if you have a seismograph here, you will be detecting everywhere these waves that are there. That is why if an earthquake happens in one part of the world, other countries also detect the waves, though the intensity, obviously the magnitude over there by the time it reaches is less, but you can detect it everywhere. But there are certain regions you cannot. So supposingly over here, everywhere seismographs are here, you are detecting the waves. Over here, obviously the surface waves will be generated. Here, seismographs are here and you are detecting the waves. But what happens is, in this particular region, you realize that you are not able to detect the P waves. Similarly, in this particular region, you are not able to detect the P waves. The question arises is why? Similarly, when you move beyond this point, you realize over here also you are able to analyze or observe these waves. Now the concept arises is the region where you are not able to, the region arises is the region where you are not able to observe these waves is known as the shadow zone, right? The shadow zone. By mistake, I had written the rain. It is not rain. It is just a shadow zone. So this is a region where you are not able to detect the P waves is known as the shadow zone. Why shadow? Because you are not able to detect the P waves over here. Why does this happen? The reason is the waves that are moving in all these directions are being detected, but when it encounters the core, it leads to, because it is again in a liquid state, now the outer core leads to the refraction of these waves, which leads to diversion of the path. See here, diversion of the path. So rather than simply coming here, this refraction leads to this region not basically receiving any, let us say, observation with respect to the waves. So that is why this is known as a shadow zone, because of what? The refraction. Had there been no liquid substance, it had all been solid, possibly the waves would have traveled like this, like this, like this. But that means there is certain substance which is in a different medium that has basically leading to refraction, and that is why this region is not basically receiving the P waves. And that is why this is known as the shadow zone, not a rain shadow, shadow zone. Clear? Now see why. P waves can travel through solid, liquid and gases. They refract due to density differences. Why? The density of the crust is different from that of a mantle that is different from the core, and the outer core is different from the inner core. Obviously, we have drawn a simple diagram. There is also changes with respect within the mantle also when you're moving. There are obviously certain diversions of path that takes place because there is density difference. But the question arises is over here, because it is a different state altogether, the outer core is in a liquid state. That is why the refraction that takes place is of a greater degree. Now the question arises, sir, mantle is also considered like a liquid state. How it is traveling through a liquid state? Please understand, certain books mention in liquid state, it is not liquid state. It is a plastic state. Plastic state, if you observe from the perspective of the waves, it is like a solid state. That is why, yes, there can be certain refraction within that. Yes, there is. Perceptible refraction is there, but when you compare it with the core, outer core, massive refraction of the waves takes place because the density difference is very high. That is why the question that I had asked you, why the P waves, though we say mantle is in a different medium like a liquid state, but it is not. Please understand this. So I had asked you a question, answer why the P waves are able to travel through mantle. This is the reason behind it. Clear? Now, let's move ahead. Let's move ahead. See here. I have studied the P waves. Now let us see the S waves for 2 minutes. If you see, let us see, if you can see, if you complete P waves, can I say from 105 degrees to 145 degrees is a shadow zone of P waves? Similarly, if you go to S waves now, from this very point that is known as the focus, energy is being released. Now, energy being released, the waves will be traveling in all the direction, right? All the direction. Now, if they are traveling in all the direction, the moment the S waves encounter the outer core, they are observed by the outer core because the S waves cannot travel through a liquid state. That is why the seismograms that are placed in all these directions, they can observe the S waves only to this level. That means beyond the 105 degree, all this region is a shadow zone for the S waves. So that means the shadow zone for the S wave is beyond 105 degrees. For the P waves, it is between 105 to 145 degrees. Why this nature? Because the P waves can travel through all the mediums, but the S waves can only travel through solid. Now coming back to the description, S waves can travel only through solid. S waves cannot pass through the liquid and the liquid, that is the outer core. And that is where the shadow zone over here, please understand. P waves undetected between 105 and 145 from the epicenter, and they are undetected beyond 105 degrees. So, can I say this, that the shadow zone of P waves is between 105 to 145 degrees and that of S wave is beyond 105 degrees. Based on this, the scientists were able to discover that there are certain things which are liquid in nature. Further observation and detection basically helped us to understand that there are various layers that are present. Now, how did they analyze? Because they focused on the concept how the P waves are refracting. Now, when you realize that there are a lot of let us say lot of layers present. So for every layer there is density variation. With every density variation there is refraction of the wave taking place. Even for the P waves also and S waves also, even if two substances are in solid nature, there will be a certain refraction taking place. But if it is solid, obviously the S waves can travel through that. It cannot travel through liquid and gaseous state. So based on this continuous work of the refraction processes that have taken place, and how and why these shadow zones are created, based on these concepts, we were able to analyze or get to know about the interior of the Earth. Let's see that. Now see, what did we analyze? This helps to identify there are different states of matter inside the Earth. Now, the more you analyze the refraction angles, the pace at which it is moving, because there will be places where when the density variation takes place, the speed at which the P wave is moving will obviously increase or decrease, right? There will be variation in the speed also with density, because the P waves can travel through all the three mediums. So please remember, change in the let us say substance, or state of matter also influences the speed also. So that is why based on that calculation also we were able to detect the interior of the Earth. So this helps in identifying the different states of substances inside the Earth. Further changes in the speed helps in identifying the nature of the substances. Waves help to identify the discontinuities in the interior. Discontinuities, please understand, between let us say mantle and core, there is a certain part, because density variation will take place, that region where the density variation takes place or the changes take place is known as a discontinuity, because it is a discontinuity because there are two states of matter that are present, right? It helps to understand the interior of the Earth as a whole. So these are the four important points that you should know. Now, having understood the seismic waves, having understood the concepts that are associated with the P waves, the S waves, the surface waves, the body waves, all these things have been understood well. Now comes, based on all this knowledge, what have we found out? That is the Earth's interior. Let's analyze it. Before I go into further drawing of this is a very simplest form of the interior that I have made. Now I will want you all to draw this along with me, right? In every slide I have already drawn it. Simply make like a cake or the pastry you are eating. This is the continental crust. This is the oceanic crust, right? There are various parts. 1, 2, 3, 4, 5, right? Next step. Pause the video. Next step. Just I have marked it to differentiate it. This is the continental crust. This is the oceanic crust. Then you have certain various parts over here. Let's see them. This below the crust, you have a layer which is known as upper mantle. Upper mantle. Below the upper mantle, you have a region which is known as a transition. Many books do not include this, but there are new classifications that have come up that are actually being presented by the geological departments of United States also, and various books also. So that is why I've added this. So you can incorporate it. Below the upper mantle is a transition zone, because between the upper and the lower mantle, this transition zone, because there is change in density over here, that is why it is known as a transition zone of the mantle. Below the mantle, below this transition zone lies the lower mantle. Below the lower mantle lies the outer core, which is in liquid state. Obviously, we got to know based on the seismic waves. And then is the inner core, which is solid in nature. Now, further, if you add or label it, see here, Now, these distances were even found out because of the changes in the speed of the waves that took place, and how these refractions were taking place. Based on that, these distances were calculated. And with every thing that is changing, please understand here, like the upper crust and the lower crust, there is variation in the density and the nature. That is why between them there is a discontinuity. What do you mean by discontinuity? Something that is not continuous in nature. That means there is certain variation in the density or the nature of the rocks or the substances. So that means the line or a fine difference between both of them is known as a discontinuity. Very simple. That is why between the crust over here you see a Conard discontinuity. If you want to understand, let us label this also. See here, between the upper and the lower crust, you have a discontinuity that is known as Conard discontinuity, which is between the upper and the lower continental crust. Please mark it, continental crust. If you see between, there is another Mohivic discontinuity. It is between the lower crust and the upper mantle. Please mark these things. All of them are not present in the NCERT also. This can be asked or and has been asked in various examinations of civil UPSC. Between the lower crust and the upper mantle, you have the Mohivic discontinuity. Now, there is a discontinuity known as Repeti discontinuity, that is between the upper and the lower mantle. Now, please, over here, this part can be treated as a between transition zone and the lower mantle, but you can take it as upper lower mantle, then also it is not wrong, no problem in that. Because certain books consider the transition zone as a part of the upper mantle also. That is why these things have been mentioned. Otherwise, this is correct. There is no problem. You can mention the transition zone of the mantle and between lower mantle, then also it is correct. You mentioned about upper and lower mantle, then also it is correct. There is no problem. Then comes the Gutenberg discontinuity. It is between the mantle and the core. Lehman discontinuity is between the outer and the inner core. You should be well aware of these. Now comes the fact that what are the distances that are located or the depth as we see. The continental crust is generally 35 to 45 kilometers. It depends. Continental oceanic crust is 5 to 7 kilometers. We will be answering this why in the next chapter, where we are going to study the concept of plate tectonics, continental drift theory, seafloor spreading. Over there, we will be analyzing why. Right now, our topic is the interior of the earth. That is why I'm not moving into those directions, which we will be analyzing in the next chapter. See, till 370 kilometers, you have the upper mantle. From 370 to 720 kilometers, you have the transition zone. From 720 kilometer depth to 2900 kilometers depth, you have the lower mantle. And from 2900 to 5100 kilometers, you have the outer core. And from 5100 to 6372, you have the inner core. So this is the complete segregation of the interior of the earth based on the seismic evidences that you have found. Through seismic evidences only you have found these discontinuities, because there is again refraction that is taking place, speed is altering, and based on that analysis over a long period of time through a lot of seismic information and all, we have created this. Clear? Right now nobody has gone inside. There are further studies also that possibly for various transition zones might also be located over here. Continuously the scientists are working on that. Right now this is the information that we have. There might be further transition zones and other things present in the earth. Possibly we'll find out as the instrument become more advanced. So you can note it down quickly. Okay. Now the question comes, let us analyze each one of them in detail. Let's see that. Firstly, I am taking crust. See, I have put the diagram over here on the side. Let's analyze what is crust. Now, you know that very well. The crust over here is the outermost layer of the earth, right? It can be continental crust present on the continent, or the oceanic crust below the oceans. Also the bed over there is also, you see, the oceanic crust is present. So the crust is the outermost layer of the earth. Now these are certain factors and aspects that you should know, because this can be asked in your prelims also, and the mains also you can ask you. It is almost 1% by volume and less than 1% of mass of the earth. So very less if you compare it with volume of the mass, but again a very important role. It can be divided into the continental crust, as you have seen. This is a continental crust. This is the oceanic crust, right? Conard discontinuity separates the upper and the lower crust of the continental crust. So this is something, again, this is a very, very important thing. Conard discontinuity also, you should remember it properly. Clear? Crust primarily comprises basaltic rocks rich in silica and oxygen. This is a question that has been asked in your prelims as one of the statements also. That is why I'm telling you every single statement that is present here should be present in your notes. If you are not writing these, I am telling you in the examination, this statement will be picked up and put in your papers. At that time, possibly you will not be able to answer them. Please understand this very well. Right? So crust, again, it is the outermost layer. It is about 1% by volume and less than 1% by mass of the earth. It can be divided into continental and oceanic crust that you've already seen. Conard discontinuity basically separates the outer and the inner crust of the continental crust. The crust primarily comprises of certain substances like the basaltic rocks, which are rich in silica and oxygen. Right? Now see here. Because I had mentioned oceanic and continental crust, so you should have some idea of what are the differences. You saw that I told you that Conard discontinuity is present in the upper and the lower crust. The reason because the thickness of the continental crust is very huge. So the upper ones might be lesser dense. The inner ones, the inner part of the continental crust may be more thick. That is why the thickness of the continental crust is more. That is why you have the Conard discontinuity present, which reflects the density variation. While the continental crust themselves are very thin, so there is absolutely lesser chance of them having a discontinuity within them, right? So that is why if you see, continental crust is 35 to 45 kilometers, whereas oceanic crust is 5 to 7. We'll be going into details regarding this in the next chapter, obviously. These are very old, 3.8 billion years. These are about 200 million years old. The reason, again, we will be analyzing based on the continental drift theory in the next chapter. Majorly granitic in nature. These are majorly basaltic in nature. Density, these are relatively less dense. That is why you always see the continental crust is here. Then the oceanic crust is subducting because it is more dense. Always observe this. That is why the oceanic crust is more dense in nature. That is why it is the one that is moving below the oceanic, below the continental crust during the time of plate tectonic movement. Please understand that. We will be doing this in the next chapter. But right now, just analyze them, right? Less dense, these are more dense. These are more stable. These are continuously recycled as subducting. Overall area wise, you realize these are 40% by the total area. These are 60%. The continental crust, right? The oceanic crust, sorry. This is the oceanic crust. This is the continental crust. So by area, 60%. By area 40%. By area, 60%. So if you are asked that the oceanic crust comprises more area, then that statement is correct because 60% is the oceanic crust, 40% is the continental crust area overall. Next comes the mantle. Now, if you see, the mantle stretches up to a depth of 2900 kilometers. See, from the crust till the 2900 kilometers is the mantle, right? So that means it is occupying the maximum part. So you can see that it forms 83% of the Earth's volume and 68% by height or depth. So this can be asked. This is again a very important statement that has already been asked in civil services. It comprises silicate rocks. Now please understand there are very important elements that are present here. 45% oxygen, 12% silicon and 23% magnesium. You can be asked to state them in order also in your prelims examination. So how you should remember? OSM, OSM. They will not ask you the percentage, but in order. O for oxygen, S for silicon, and M for magnesium. Oxygen, silica, and magnesium. Awesome. This is in order. So that means these are the most important elements that are present inside the mantle. Now the Mohevik discontinuity basically separates the crust from the mantle, which you have already done that. You would have drawn the diagram also. Now it has three parts. First is the upper mantle. Then is a transition zone, and then there is a lower mantle. So you should know all of them. Let's move and study them. Quickly note this down. The most important thing is OSM, oxygen, silica, and magnesium. Upper mantle. See, it stretches till 370 kilometers. From the crust, below the crust lies the upper mantle. It is still 370 kilometers, this complete part. It is a primary source of magma. So what volcanic eruptions are basically taking place, the magma is coming out from here. plastic in nature. That means for the waves, P waves and the S waves, it is like a solid state only, right? Transition zone, below the upper mantle lies a transition zone. Many books do not even mention this transition zone because of the nature, because older versions are present. New researches have not been incorporated. This is again a mantle. The only thing is it is little more denser in nature. That is why you see in a way that this is a transition zone between the upper and the lower mantle. That is why it has been mentioned over here. Between 370 to 720 kilometers. So from 370 to 720 kilometers, this is a transition zone. Clear? Below that is a lower mantle, 720 to 2900 kilometers. This is obviously the more denser part among all the mantles. So this is the lower mantle. Clear? So we have done the mantle also. Now let's come to the next part, that is the core. Now see, this is a core from 2900 to 6372 kilometers. So from 2900 to 6372 kilometers. Now please understand, Wetschart-Guttenberg discontinuity separates the mantle from the core. You know that very well, you should understand that also. This continuity is separating the mantle from the core. Density increases with depth and thus increases the speed of the primary seismic waves. Now see, when they are crossing the core, the speed of the primary waves increases rapidly because the density is more. Clear? The density is very high, so the speed will increase. So these are the ways through which we have basically found out that interior has these solid, liquid and various different parts that are present. This is something that you should, this is a very important statement. The layers are outer layer, outer core and the inner core. That means the outer layer or the inner layer, there are two parts. Now let's see them. Outer core and the inner core. See here, outer core is from 2900 to 5100 kilometers depth, and from 51 to 6372 is the inner core. Clear? Now see here, outer core extends from 2900 to 5100 kilometers depth, comprises iron mixed with nickel and traces of other lighter metals. It is in liquid molten state. That is why you see the S waves cannot cross them and they are observed by the outer core. Clear? Inner core extends from 5100 to 6372 kilometers, comprises primarily iron, that is 80%, and some nickel. It is in solid state. So you should be very well aware of the fact that over here primarily iron is present. Now it is a solid state. Now the question comes, how is it possible that a solid body, a round solid body, is basically being surrounded by the outer core, which is in itself in liquid state? This is a solid state, right? If I see in this way, this is a solid state. It is in liquid state. How come this is in solid state and the outer part is in the liquid state? Please understand this. I'm telling you the answer, but I want each and every candidate over here to write the answer in the comment section. Why? I'm telling you, this will clear your concept when you write it. By merely listening, this will not help. Write the answer. The question is, why is the inner core in the solid state while the outer core is in the liquid state? Please understand this. I'm telling you the answer. Simplify this answer in your own words and write it in the comment section. You know that very well, as you move inside the earth or interior of the earth, the temperature is increasing. There is no doubt about it. With it is increasing the pressure. Why? Supposingly something is over here, the pressure is only being exerted by the crust. If something is over here, the pressure is being exerted by the crust, the upper mantle, the transition zone, and obviously the lower mantle. If something is over here, all these layers, and if you are here, obviously the whole pressure is on you, right? Just for reference. If you see in this particular zone, obviously the temperature is very high. Temperature being very high should lead to, let us say, some liquid state being there. That is why when you move inside, over here, the temperature is high, the outer core is in a liquid state. Done. Over here, the role of temperature is more than the role of pressure being exerted. On the other hand, when you go inside, the temperature is high, yes, but the pressure that is exerted is extraordinarily high. That is why the interior or the inner core is in a solid state where there is predominance of the pressure that is exerted in comparison to the temperature. Yes, the temperature is high, there is no doubt, but the role of pressure increases. That is why that leads to the body being in the solid state. Please understand this concept well. This is the reason. Till now, obviously there might be new reasons that come up. With new researches, definitely we'll add to that also. Clear? So, this is the outer core and the inner core. So, we have done with the interior also. Now, please understand, all these information that you have gathered, which I've told you till here, is based also majorly on the seismic studies or seismology. Clear? Before this division was given, there are other divisions or classifications that were given of the interior of the earth. They have been helpful, but again, this is a more precise one. But we should know them also, right? So let us see the other also. In the examination, you can be asked, let us say if they ask you, write the on the interior of the earth. So you will be using majorly the classification of the crust, mantle and the core that I have given you based on the seismic studies. Or if they ask you the classification of the interior of the earth based on the seismic studies, then also you will be mentioning about these classifications, right? But in the examination, if they ask you, give the mechanical division of the earth's interior, in that particular case, you will have to write this answer where you have to divide into lithosphere, asthenosphere, mesosphere and barysphere. These are the mechanical divisions. Again, there is one more division, that is the chemical division by Edward Suez, that is the Sial, Sima and knife, which we will be also doing. So these names you should be very well remembering, that this is the mechanical division. The previous one is the division of the earth based on the seismic studies. Clear, everybody? Now see. Again, this is basically, if you have studied crust, mantle, core, you already know. Based on that, we have basically mentioning this, right? Lithosphere. Lithosphere basically forms the crust part and the upper mantle. So crust or the upper mantle region forms a lithosphere. The thickness basically varies from 10 kilometers to 200 kilometers. And lithosphere is a region where tectonic plates are basically moving. So this is the lithosphere. So that means if you have understood crust, mantle and all, so from that perspective you see crust, whole crust part and the upper mantle region till the depth of 200 kilometers can be considered the part of the lithosphere, and this is the region where tectonic movements are most active, right? Next, asthenosphere. The uppermost part of the mantle below the lithosphere is known as the asthenosphere, right? It lies below the lithosphere between a depth of at 80 to 200 kilometers below the surface, and it can extend to 400 kilometers. So we can take it as a form that it can extend till 400 kilometers. It is a plastic zone. Again, we are talking about mantle. This is the mantelic region only, so that is why it is a plastic zone. It is a different type of classification, but again, if you know mantle, core and crust, so it is easier to understand. Capable of bending without breaking in the convectional currents. So obviously, you know that mantle had convectional currents because of which the tectonic activities take place. So this is also a asthenosphere through which basically the tectonic activities, the convectional currents are taking place, because of which tectonic activities take place. So it is again till the depth of 400 kilometers. If you see from this diagram, it is basically referring to the region of transition zone and this part of the mantle. Clear? So this is where convectional currents in a way are also taking place. Clear? Let's move ahead. Mesosphere. Below the asthenosphere, till this part, a lithosphere was still here, let us say 200. From 200 till 400 kilometers was your asthenosphere. From below 400 kilometers till 2900 kilometers, that is the remaining part of the mantle, is known as the mesosphere. That means extends till 2900, temperature is very high, 3800 degrees Celsius. Next is the barysphere. It is a complete core. Now over here, please understand, it is not differentiating that outer core, inner core, it is simply saying barysphere. Barysphere means it is talking only about the core, which comprises inner and outer core both. Extends till the innermost part, 6372 kilometers, very high temperature and pressure, but we know based on the seismic studies that the outer core is in liquid state and the inner core in the solid state, though this does not tell you that. Clear? This is what is the mechanical division. Let's move ahead. Next comes the last one over here, classification is model of the Earth's chemical composition or interior by Edward Suez. Now this is a very old classification, but important because we all study. It basically says that there is an outermost layer crust, again that is fine, but they're talking that there are 3 layers: Sial, Sima and Knife. These Sial, Sima and Knife are basically based on the composition that is present there. If you see over here, it is chemical composition. Sial means silica aluminium, Sima means silica magnesium, Knife means nickel and iron. Ferric Fe is representing iron. So it is basically representing the chemical composition that is present there. Clear? Let's move ahead. Sial layer. What is Sial? It is just located beneath the sedimentary cover. That means that the crustal layer below that. Sial layer comprises granites. So this is basically talking that this layer comprises granites. It is primarily characterized by a high level of what? Silica and aluminium content. That is why Sial means, Si means silica, Al means aluminium. Average density is 2.9 grams per centimeter cube. So over here what we can say? 2.9 grams per centimeter cube is the average density. Thickness varies from 50 to 300 kilometers. It is rich in the acidic material. That is why you should analyze that silica is again contributing to the acidic nature also over here. Now please understand that Sial means silica aluminium, density of 2.9 grams per centimeter cube, thickness from 50 to 300 kilometers, and this is basically this particular part. Clear? Now let's move to the next part. Sima. Below the Sial, you have the Sima. Now, below the Sial layer consists of basaltic source of magma and lava for the volcanic eruption. This dominant constituent is Sima, S-I-M-A, that means silica and magnesium. Average density varies from 2.9 to 4.7. So that means as you're moving down, the density is increasing, again because of the mineral composition. Thickness varies from 1000 to 2000 kilometers. Now please, you will see this classification is old and it is a very generic classification. That is why the first classification based on the seismic studies were given is the most appropriate one. But these are present in the books, that is why we are understanding them. So density over here is 2.9 to 4.7 grams per centimeter cube, right? Next, Knife. By word you can say that it is the inner layer below the Sima. This is the Knife layer, as I mentioned here. Knife means nickel and iron, and it extends till the interior, that is 6372. Density is very high, 13 grams per centimeter cube. Again, this is the third division that you should know, right? Last thing that you have to do, this I personally believe is the most important part. This has been asked in CAPF examinations, PCS examinations and civil services examination also. There are two things that you should analyze. First, the composition when you're talking, or the proportion of the elements that are present in the Earth's crust and overall Earth. Please understand there is a difference. In the crust, what is the composition of the minerals or the elements, and what is in the entire Earth? See over here. If I see the Earth crust comprises which element which is present in the maximum proportion is oxygen. Many people will assume that some other mineral, possibly silica. No, it is oxygen, then silica, then aluminium, iron, calcium, potassium, sodium, magnesium and others. They can even ask you to arrange this in order. Calcium, potassium, sodium, arrange them in order with respect to the Earth's crust. This has been asked in UPSC CAPF paper. So you can very well know the importance. See, you can create mnemonics out of it obviously, but you should, when you read it multiple times, it will be easier for you. There are certain things, at least these two to three things should be at least known by you: oxygen, silica and aluminium, right? Because most of the people mark it wrong. They assume that silica is in the maximum extent. This was the crust. But when I talk about the entire Earth, you should understand it. We're talking about the mantle, we're talking about the core, we're talking about the crust, everything. With that proportion, iron is maximum. Iron is maximum, second is oxygen, third is silicon, then fourth is magnesium, sulfur, nickel, calcium, aluminium and others. So these are two things. The NCERT does not mention both of them. They simply mention about the Earth's crust. That is why the questions have been asked from the interior of the complete Earth also. So you should be very, very well aware of both of them. Now, based on this, we have studied the complete interior. We have done seismology, we have done earthquake, we have done surface waves, we have done body waves. All these things have been done completely. I would request you all to go through the lecture completely, properly, if not once, twice, because everything has been explained in a lot of detail. This is a one-stop solution for you to complete this chapter properly. Because there are a lot of queries that I've asked you. Once again, I'm repeating, I want the answer of the question in your own words. Why the inner core is in a solid state, but the outer core is in a liquid state, right? So please write this answer in the comment section in your own words. Clear? Hopefully you enjoy the lecture too. The next lecture that is going to come is the topic of ocean and continents, which I'll be explaining you in detail, where a lot of things which you have studied in this chapter have remained unexplained, like why the oceanic crust is thin, the continental crust is thicker. How the plate tectonic movements basically happen. All these things will be explained in the next chapter, because it was difficult to add that to here, because the NCERT basically explains them in the other chapter. So we'll be following that pattern. By the time your NCERT is complete, every single concept will be clear. Again repeating, if you follow this series carefully, you will be able to attempt every single question from the UPSC Prelims and the Mains examination from the physical geography of the world. Third lecture of the physical geography series. Please remember, though, as I've already mentioned, this is an NCERT series, but we are not going to confine ourselves to the NCERTs. We are further going to go into the details of the concepts that have been mentioned in the NCERT but not explained. So this will fill the gap between what the NCERT says and what is the demand for the civil services examination. Hopefully you enjoyed the previous two lectures of the physical geography. We are going to build or carry forward those concepts in this particular lecture. So let us begin with this interesting third chapter of the physical geography series, that is distribution of ocean and continents. Please remember, now just have a look here. This is a map, again, as we have already seen, a hand-drawn map. Many people say that it is not hand-drawn. It is definitely a hand-drawn map, which I have been continuously practicing, showing you also in front of you that how we can draw these maps. Now see, what I have marked in green is basically representing the continents, right? You can see over here Antarctica also, Africa, Asia, Europe, Australia, South America, North America. That means the continents, that means the land. In a simple words, land. What is marked in blue or in dotted, I've just dotted these places. So this is basically referring to water bodies in the form of, let us say, oceans, seas. Now, based on this observation which you see here, there are certain inferences that we can draw. Now let us see these inferences, and then we will build on these concepts, how these continents have originated, how they're possibly moving. So there are a lot of concepts that are very important for your prelims as well as the mains examination. Let us see them. Looking at this, let's build some concepts. If you see, there are certain observations I've mentioned. If I take the total surface of the Earth, water basically comprises 70.8% of it, while land 29.2. So if, let us assume, this is a complete sheet. Please remember, when we actually depict them on this model, 2D model, it becomes really little difficult, because when you see a globe, you have a better aspect of viewing how much water cover is there on the surface. Because obviously over here, we cannot mold it into a globe. But based on the observations, based on the measurements, if you see, basically water covers 70.8% of the surface, whereas land covers only 29.2. Now this something is very important. This particular sentence itself is important, because this was asked in the CAPF also examination, that is also civil part of the UPSC examination. This statement has been asked, I think, 10 to 15 years back also, along with the other statements. So these basic things form the core of your understanding for civil services. Let us assume if you haven't read them. Possibly they'll mention
60%, possibly they might mention 85%. At that particular point of time, there is quite a possibility that you might make certain errors. Now, this is based on the new reports that have been there. So, we will follow the standard format. More than 75% land is in the northern hemisphere. Now, if you see, this is the equator. Large patches of land that you see over here. So, that means based on the observation also, if you see, you can say 75% of the land is in the northern hemisphere. Now, these can be themselves as statements that can be asked in your preliminary examination. That is why you should be well aware of them. Third, North Pole is surrounded by water while South Pole by land. Now, the reason is we have done the mapping video of Antarctica. You know that very well. Antarctica is a landmass. It is a continent also. So, this is Antarctica. Now, it is land and the South Pole is located over there. When you see the North Pole, it is basically Arctic Sea. That is why if you see, North Pole is surrounded by water and South Pole by land. Now, again, an important statement. Sometimes in the hurry while you are basically writing your answers or marking your answers for the preliminary examination, you might make some mistakes. So, you should be very well aware of them. Continents roughly triangular in shape except Antarctica and Australia. Now, this is again this statement has basically been made by few thinkers who are geographers. So, they have said roughly they are in triangular shape except for these two. So, this can also be a statement like generally observed the shapes of the continents are triangular. Now, at that particular time in the prelim examination, you will say, no, it is not, we will mark it wrong. Generally, it is not saying every continent, it's saying generally. So, this statement will be right in that case. So, that is why please remember, these all statements become very important for your brief understanding based on the observations that you have made here. Clear? Please remember, along with this, you know that along with the geography series, we have a mapping video that comes every week. So, that will be complementing the understanding of your mapping, right? Let's move ahead. Now, please understand, when you study the NCERT, in the NCERT, you will see that the theories that are mentioned basically are the continental drift theory by Wegener, that also in 2 paragraphs. Then they basically mention in 1 sentence the convectional current aspect. Then in 2 paragraphs they mention seafloor theory, and then they mention the plate tectonics, that also in very brief details. So, it is difficult to comprehend. Now, please understand, it is not that the NCERT is not telling you what is required. It is absolutely telling you. They will pick up things from the NCERT also. But remember, there are a lot of things that are missing. Now, these things are often asked in your mains examination also. Now, for example, please remember there's a PYQ, previous year question, which talks about continental drift theories. In that case, you could have mentioned there is another continental drift theory by Taylor. There is another theory by Wegener. There have been questions on this. Repeated questions have been asked on plate tectonics. Repeated questions have been asked on seafloor spreading. So, that is why please understand these concepts become very important. Now, I have mentioned even those theories which have just been mentioned and not explained. So, it is your task to use this lecture very precisely, very religiously, so that you note each and every detail while making the notes. I am requesting you again, please do not go with the fact that you will just download this particular PDF and write everything down. Remember, you will miss a lot of things because there is no dearth of material in the market. If you are simply behind market that, okay, the lecture has come, let us download, who will see the lecture? This is again one of the wrong strategies which students adopt, because there are a lot of things which I'm going to speak and explain which will not be mentioned in that particular PDF. So, using the lecture along with the PDF becomes very important. Clear? So, please let's move and study all these. There are a lot of views or theories for the evolution of ocean and continents. Now, one more thing before we begin. This does not mean that every theory that is mentioned is completely correct or there are no flaws. That is completely wrong. Even the latest plate tectonics theory is not completely correct. There are a lot of issues. Similarly, when you will come across or read these theories, which I'm going to explain to you, you will see, like for example, the Tidal Hypothesis. This is again a very basic student of class 10 can also say this is wrong. But it does tell you something or some concepts which help you to build the other theories. That is why whenever you read theories, first understand what the person or the thinker who has given the theory has told you. After that, criticize that, right? That this is a possible criticism. So, based on these, this is a particular flow in which we're going to study. So, let's begin. First is the tetrahedral hypothesis by Lothian Green, 1875. Then you have the continental drift theory by Taylor. Please remember, there are 2 continental drift theories. Before Wegener, which you read, Taylor had given the theory. So you should be aware of that also. It's quite possible that in the examination they might ask you, give the continental drift theory by Taylor. They can ask you, because nowadays in general studies also they are asking such questions. Continental drift theory of Wegener has been asked repeatedly. Give the evidences also. That is also covered here. We'll see that. Then this convectional current theory. Please remember, to understand the plate tectonics, you need to go through and understand the continental drift theory, the convectional theory, and the concept of seafloor spreading. When you understand these things only, then plate tectonics theory will make relevance or importance for you, right? So let us begin. Let us begin with the understanding. Okay. First theory is tetrahedral hypothesis. Now, please remember, in order to understand what is tetrahedral hypothesis, this is a diagram that I have made in front of you. You should first understand what the diagram is. Leave these two for 2 minutes. Let us assume you have a 3D figure in which there are, let us say, 4 triangles. Let us see this. Let us say there is a triangle. Supposingly you have a cardboard box. Let us make it clear. You have a cardboard box which is in triangular shape. This is also a triangle. You close it. You close it from here. You close it from here. Do you realize that you will form a tetrahedron where it is made up of 4 equilateral triangles? This is also an equilateral triangle. This also, this also, this also. Now this is supposingly the base, right? And I close this, and I close this, and I close this. What will it form? It will form a structure of this form, where the base is also an equilateral triangle, this is also an equilateral triangle, this also, and the back end also. So there are a combination of 4 equilateral triangles which is making this particular figure. Now this figure can be made based on these 2 things. Either you can close this, you can form, or you can combine and fold this, then also you can form an tetrahedron. There was no need to draw this, but I've just shown you so that how you can basically conceptualize the shape of a tetrahedron. Again repeating, tetrahedron basically is a figure that is formed by basically joining 4 equilateral triangles. One equilateral triangle at the base, then merging it, let us say closing this, closing this, closing this. And the figure that is formed, this is known as a tetrahedron, right? Tetra means 4, right? Now see, let us understand, you've basically understood what tetrahedron basically means. Now let us understand the theory. Tetrahedral hypothesis by Lothian Green, 1875. This hypothesis is based on tetrahedron, which is a solid body of 4 equal places surface, each which is an equilateral triangle. So they have the equal plane surfaces. They are equilateral also. So this is combining them forms this tetrahedron. Clear? Now, please understand, right now again, forget the fact that Earth is in which shape, forget all those facts, just understand what the theory is saying. So, it is based on the fact that there is a tetrahedron that is existing, which is basically formed because of the 4 equilateral triangles that have been basically joined. 1 at the base and 3 are joined at the top so that it forms a 3D figure. Clear? Now, this is the premise on the basis on which this theory is given. Now, having understood the shape, let us begin with the fact that he gives a particular view. Now, for 2 minutes, understand this very, very well. This is a shape in front of you. Now, how you need to imagine it, you need to understand this. Let us assume I take this shape and turn it like this. I reverse it. When I reverse it, do you realize there will be a plane on the top? Yes. Similarly, what is going on here is, supposingly the base, the top which was pointed is pointing downward, and this is a top part which I have reversed. Now, what this theory is saying is, basically it is marking certain points that the continents are present in certain regions and the oceans are present in certain regions. Please again conceptualize. Reverse this particular shape. You will have a base on the top, and this is pointing down, and obviously this is pointing outwards, right? Now, he said that this is possibly a depiction of Earth. Now, how he's saying, let us first of all see the points. He says that Earth was earlier a sphere, a spherical shaped body, but later on, due to cooling, a tetrahedron was formed. What does Lothian Green say? He said that earlier the Earth was a sphere, but as the cooling of the Earth took place, it formed a tetrahedron shape. Now, you would be imagining how stupid this person is possibly, that we can see our Earth from the satellites, we can see from the spaceships, we know it is not in a tetrahedron shape. Yes, those are the criticisms. Right now, what Lothian Green is assuming is possibly it is in a tetrahedral shape, right? Now, tetrahedron. Now, epics are the continents or land and flats are the oceans. Now, see epics, what does it mean? That means this pointed sides. Now, this is Europe, one pointed side. This pointed side is Asia and Africa. This pointed side is North America and South America, and this pointed side is Antarctica. That means the pointed or the apex positions are the continents and the flats are the oceans. Now, how you can assume this? He is possibly saying this region is the Arctic Sea. This flat region is the Arctic Sea. This flat region is basically representing what? The Atlantic Ocean. This is possibly representing the Indian Ocean. Now, you are forgetting one more thing, that there is a backside of this. Backside of the tetrahedron. That backside is represented by the Pacific Ocean because Pacific Ocean is larger according to Lothian Green. So what do you see? The pointed sides of this 3D figure are represented by continents and the flats are represented by the oceans. See here, supposing these pointed things are representing what? The continents, and the flats are representing the oceans. That is what? I've just reversed the diagram as according to the Lothian Green's view. So these flats, this is Arctic Sea, this is Atlantic Ocean, this is Indian Ocean. Backside, if you go, that is basically what? The Pacific Ocean. The pointed sides are Asia and Africa. This is Europe, this is North America, South America, this is Antarctica. Now, this is what is the view. Now, you will see there are a lot of errors in that. Yes, there are. But this is the view that is presented. Clear? Again, it was earlier a sphere, then later on due to cooling, tetrahedron was created. Epics are the continents or the land, flats are the oceans. Back represents the Pacific Ocean, as I've showed you. Behind this, the side that is present, that equilateral triangle, represents the Pacific Ocean. Clear? Okay. Having done this, you very well know, this sounds very funny also that somebody is creating such theories, but again, there were lack of observations from the perspective of, let us say, spacecraft, or we going to space and observing. So that is why these theories during the initial times did basically rise up and people started popularizing them also. So leaving that apart, we should understand that balance of Earth cannot be maintained if it is in a tetrahedron shape and it is basically revolving or rotating in that particular manner, right? It shows permanency of ocean and continents. It shows that the ocean and continents are permanently fixed there. And you know in today's time also they are not fixed. They are moving. The latest plate tectonics theory says that the plates are moving. And the third, which I have not even written, is basically when you go to the space and you have photographs of that, Earth from nowhere is similar to the shape of a tetrahedron. It is a geoid shape, right? So we all know. So this is again, you can write the third, you can write even the third criticism, that it is not a tetrahedron as tetrahedral shape because it has been observed through the various satellites, through various imageries, that this is not the correct shape. So this is the first view, which is basically the tetrahedral hypothesis, which you should be aware of. In the NCERTs and old NCERTs also, they have basically mentioned this word, not even explained, which I have explained you what it basically means. Now moving on to the second view aspect, that is the continental drift theory. Now please understand, when we will do the plate tectonics also, you will understand it completely. What the perception of the people who have given continental drift theory is that what happens actually, according to them, is because they believe that continents are moving. There is no doubt in that. The only thing is because they see continents are above the sea level or the ocean. So that is why the part that is moving, they assume that only the continents are moving. Later on, plate tectonics say that the plates might be extending even till the ocean level also, though those plates are moving, not merely the continents. This is a very important difference that you will understand once you have done all the theories. Over here, the continental drift theory, either by Tyler or Wegener, they're basically talking about the continents which are moving. Clear? Let's see. So this is the older continental drift theory. The newer one is Wegener. In case, supposing a question is asked in 10 marker about continental drift theory, generally they ask in 15 markers only. And in that case, your preference will majorly be on Wegener, but you can also mention about Tyler's theory.
There is nothing wrong in that. You will be awarded more marks only. So you should be aware of both the continental drift theories. Now see, what is the main purpose of this particular theory? Now see, these I have very systematically arranged the purpose, their theory statement, the diagram, the criticism. So this is the pattern in which you write in your mains examination also. And when they ask you in the prelims also, if you have this knowledge, you will be able to answer all the questions, right? What is the main purpose? The hypothesis tries to explain the origin of folded mountains in the tertiary period like the Rockies, Andes and the Himalayas and the Alps. Now you know that very well that these are the young fold mountains, the Rockies, the Alps, the Himalayas. So these are young fold mountains. So basically Tyler wanted to explain how these mountain ranges basically originated. This was his main purpose. In order to fulfill that, he has given this theory. That was his purpose, right? Now let's see. Theory statements. He says that there were two land masses during the Cretaceous period. Cretaceous period is basically from 64 to 144 million years ago. Now he says there were two land masses, one land mass and two land masses. Now the thing is, one is Laurasia and other is Gondwana land. Laurasia is located near the North Pole and Gondwana land near the South Pole. So if you see that diagram over here, this is the shape. It says that one landmass is located near the North Pole and other close to the South Pole. And this is known as Laurasia, the northern one. And this is the Gondwana land, which is the southern one. So this is being presented. This view is being presented by what? Taylor. Please again understand, these things do not assume that, okay, this is only has happened. No, because we are studying the various concepts and slowly we will be knowing the advanced concepts also. So just now, please assume that this is what the thinker is saying. It is not necessary that this might have happened. Please remember that, right? So this is Laurasia located in the North Pole and this is the Gondwana land located in the South Pole. So now when you are drawing the diagrams, I have drawn all the diagrams, so that makes it easier for you to remember also. Now, Taylor says that there are two movements or two basically types of forces, forces being exerted so that there are two types of movement that are taking place. One is the equatorial side or equatorwards movement. Now both the bodies are moving towards the equator. So that means there is equatorwards movement. Second is, along with it, there is westward movement also. So there is westward movement also. So there are two basically ways in which the movement of the land masses are basically taking place. Now please remember, when you see this thing, it says basically this is the landmass, this is the landmass, other parts are completely covered with water. And two forces being exerted, one equatorwards, one westward. Now what happens is, the driving force responsible for both the movement of the tidal force of the moon. So the force that is exerted by the moon, which is known as tidal force. In a way, you can call it a gravitational force also, but the word is tidal force. The tidal force that is being exerted is causing these two types of movement. Now, right now you'll be saying, how is it possible? But you just have to understand what the thinker is saying right now. So they say that this is a force being exerted. The moon is exerting the force, which is basically causing the landmass to move towards the equator and towards the western side. Clear? Now see, according to Taylor, during the equatorwards movement, the continents were deformed and their edges forming large lobe-shaped folds and mountain ranges. So what is he trying to say? Because he wanted to explain the tertiary mountain ranges formation. He said while moving towards the equator, there was a lot of deformation within the continental masses that took place, and that basically caused the formation of mountain ranges. He did not go into a lot of detail. He simply said because of the forces of the movement of the continents towards the equatorwards, there was deformation of the edges of the continent. Obviously, he assumes that because the movement is taking place, there will be again deformation at the edges, particularly because it is moving down, and that led to the formation of what? The mountains, particularly the ones which are mentioned during the tertiary period, right? Now the criticism, please understand, you by default know that there is a lot of issues with regarding to this theory. Taylor made the continents move to great extent to explain the mountain formation. So the criticism is that just to explain the mountain formation, you have completely moved all the parts of the continent here and there. And it is not necessary that such processes might have taken place, or to such scale it might have taken place. Second is, tidal forces are not so strong. He said, see, tidal forces or the gravitational pull of the moon can be okay and play an important role. It can form tides, Yes, there are certain these forces exerted can impact to certain degree, but it cannot cause complete continents to move towards the equator or even move towards the western side. So that was a very big exaggeration with respect to these forces, or that these forces can cause such massive movement on the surface of the earth. Next is forces within the earth have not been considered. So just remember, today's time we know that there is let us say convectional currents in the mantle, what is basically one of the reasons for pulling the plates and all. While in that particular case we are talking about the internal forces which are responsible for such movements taking place. Have all those factors been taken in this theory? No. They are not talking about the internal forces might be responsible for such movement. That is why this is very heavily criticized. They said you have mentioned about an external force which is causing. What about the internal forces? Similar problem is with Wegener also. You will be seeing that. So this is again the third criticism. Clear? So we have done with what? Two theories, tetrahedral hypothesis, and then we have done with the continental drift theory by F.B. Taylor. Now, when we have done this, we come to the third theory, which is again very commonly explained, mentioned also various places, and this is the one which is generally mentioned as continental drift theory. People neglect Taylor's theory, but again that will be incomplete. You should be aware of the continental drift theory by Taylor also. Now what does he say? What does the continental drift theory of Alfred Wegener say? Now please understand. What is the main purpose of this particular theory? There is again, whenever a theory is created, or let us say presented, there is something in the mind of the thinker or a geographer for that matter in this case. They want to explain a concept. Now to explain that concept, they create a theory, and obviously then it becomes public that these theories have been presented, those views have been presented. So there is always a purpose. So what is the purpose here? The continental drift theory grew out of the need to explain the variations in the climate in the past. This is again very important. This can be asked also, right? He wanted to explain how the variations in the climate basically took place in the past time. Let us say thousands of years back, more than that. So there were variations in the climate. How did it take place? Now see, there is an assumption that Wegener takes. Wegener says that he assumed, that means he's assumed that this is the fact that has happened, and based on this assumption, I'm going to give my theory. He says that the continents were moving while the climate belts were stationary. He says that the climate belts that are there, that certain climate is in certain region, that is fixed. Only the continents are moving. So when a continent moves and come to that belt region, that continent will be experiencing that particular climate. When that continent moves and another continent comes to that region, that continent will experience that climate. So he says that the climate belts are stationary, but the continents are moving. Now this is the assumption that Wegener basically takes in order to give his theory. Two things you have done, the reasons, why he wants to explain what is the purpose. Second is the assumption that he takes. You can copy it if you want, right? Continents are moving while the belts are stationary in nature. They are not moving, right? Now, when we move ahead, let us analyze the theory statements. You've already done in the previous lecture what is Sial, Sima, and knife. So what he does is, Wegener believed in the three-layer system of Edward Suez. His first statement is that he believes in the concept that was given by Edward Suez. That means that there are three layers in such form of Sial, Sima, and knife that are existing. Now this is his first statement in his theory, and you have already studied what are the densities, what are the compositions and all in the previous lecture. We're not repeating it here. Neither you have to mention it, because you just need to mention that he believed in the concept of Edward Suez, right? Next, Wegener considered Sial to be limited to the continental masses. Now see, understand here, these statements which have been mentioned, you know that very well there are ratios in that, you will assume. Just remember what the statements are being said, those are more important for you, right? Now see here, Wegener considered Sial, that means made up of silica and aluminium, to be limited to the continental masses, whereas oceanic crust were represented by upper part of Sima. So that means he is trying to say that the Sial is basically limited to the continental part only. The oceanic crust basically, because it is thinner, he assumed that the Sial is not present on the oceanic crust, only in the continental crust. This is what he's trying to say. Clear? Now, all the land masses were united in the form of one land mass known as Pangaea. Now, please see. He, in contradiction to the view of Taylor had mentioned there is Laurentian on the top, North Pole, and Gondwana land on the South Pole side, right? And they were moving towards the equator and westward. Clear? Here, he says that there is one landmass. This is the landmass and all other parts of the earth are completely covered with water. This landmass is known as Pangaea, and the complete large water body or one ocean that we say is known as Panthalassa. What? Panthalassa. Now see, there is something very important here. When you read Tyler's theory, you will see something very important. He talks about these movements taking place during the Cretaceous period. That means 64 to 144 million years ago, this is the time. While Wegener's theory talks about Carboniferous period, that means these movement which he is talking about is during the Carboniferous period, that is from 286 to 360 million years ago. Now coming back to the statement, first he said that he believes in the Edward Suez classification, the chemical classification that is given of the earth of Sial, Sima and Knife. Second, he says that the oceanic crust does not have the Sial, it only has the Sima, the upper layer of the Sima, and that means the Sial is basically confined to the continental crust. Now second thing, he says that there is a huge landmass that is existing, one united landmass, that is Pangaea, and the complete other parts of the surface of the earth are covered with water, and which is basically Panthalassa. So that is why it says that all the land masses were united in the form of one huge landmass that is known as Pangaea in the Carboniferous period, that is 286 to 360 million years ago. And there's a huge water body known as Panthalassa. That means other parts are completely covered with water, one water body, right? Now this is the basic thing. Now let's see. Now please understand, this is basically the representation or a handmade diagram of continental drift theory. This thing started breaking, and then 225 million years ago, you will realize that there is certain breaks that are taking place. These continents further started moving apart, and you see this part is moving up, this part is further moving downwards. Then you see 100 million years ago, you will see there is further separation taking place. This will form the North America, this is South America, this will form Africa, this will form Europe and Asia, and this is the peninsular part of India which is moving, and it will crash into the European plate, and this is Antarctica. When you finally come here, you realize that this part has formed this part has formed South American part, this part has formed your what we say as your Africa, then other parts of Australia, Antarctica, and so on and so forth. This is the continental drift theory basically talking about. Now, this is all handmade. Now, you will say, sir, it is very difficult to make such precise. Please understand, you don't have to be artistic in your approach while you're making the diagrams in the examination, but at least it should not look like a way that it is not even close to what is being represented. At least try. Please remember, the more you practice, better you will be at drawing these diagrams. If I have made in front of you, so possibly you can also. If you draw it twice and thrice, possibly it will be ingrained in your mind. Please remember, very often people assume that while drawing these diagrams or the maps, it takes a lot of time. Let us avoid it. We can do it at the later stages. The problem that is, because of not drawing these diagrams or maps, you are not able to comprehend the concept, nor you are able to remember them. The students who make these diagrams are able to remember the concepts also very well. Now just remember, other things, whether it was Pangaea, Panthalassa, Sial, Sima, everybody will basically be able to remember them. The one who draws the diagram somewhat similar to this will be able to gain at least 1 or 2 marks more in the examination. A direct question has come, I think twice or thrice in the past 10 years based on continental drift theory. Straight away asking what is continental drift theory, how the oceans and continents are moving apart. What are the evidences in support of that? Now, this is a complete answer which I'm writing right now is a complete answer that gives you out of 15 marks, it can give you even 11 marks if you write it properly. These are low-hanging fruits, so please remember that. Now see, from this part to this, to this, to this, to this. So what do you see? That one combined Pangaea is breaking, moving because of what? The tidal forces. We'll see the forces also, obviously. We'll see the forces because of which it is moving, and because of that it finally takes this form. We'll see the forces also, don't worry. Now see, over here he says that Laurasia consisting of the present North America, Europe and Asia form the northern part of Pangaea. Now please see, he also uses the same word of Laurasia and Gondwana land. When this Pangea started breaking, the northern part of it was known as Laurasia, the southern part of it was known as Gondwana land. Please remember, what did Taylor do? Taylor basically already supposed that the Laurasia was on the top and Gondwana land was in the south. But what does Wegener do? Wegener combines it that there is one landmass, and this landmass possibly, let us say, broke. The broken upper part was known as Laurasia, the southern part was known as Gondwana land. And then what does he say? You will be seeing these countries, all these countries will be part of what? The Laurasia, the southern, this part will be what? Part of Gondwana land. That is why he says that North America, Europe and Asia form the northern part of Pangea. See for yourself, this is again, this part will form what? North America. You will see this part will form Europe part, this will form Asia. So in a way, we are representing or saying the same thing, but from a different perception. So northern part of this Pangea, when it broke, formed the Laurasia, southern part formed the Gondwana land. Clear? Now let's move ahead. Now the southern part formed the South America, Madagascar, Peninsular India, Australia and Antarctica. This is obvious. Now Pangea was disrupted during the subsequent periods and broken land masses differed, or let us say moved away. Now please remember, again, they're talking about that as Pangea broke up, various land masses started drifting, firstly in form of a broad mass, Laurasia northern part and Gondwana land the southern part. Those land masses further started drifting apart and started breaking, and that led to the formation of what is known as the various continents or the smaller land masses, which you can see over here according to Wegener. From here, further breaking apart, this further broke up into African part and what? South American part. So this is separated. Then finally this. So there is certain repeated breaking and drifting that is taking place. Now please remember, what are the forces that are taking place? Now these forces or the names that have been given, see certain books simply mention that yes, the tidal forces are responsible. Right? Tidal forces are responsible. Again, a similar view. Certain books also mention that there is an equatorwards or movement that is taking place that is due to the gravitational differential forces, due to the differences in the gravity in different parts of the region. And second is westward movement is also taking place, that is also due to the tidal forces. So this is very similar to what we have basically seen in the view of Taylor. In a way, if you want, you can basically say that there is similarity in the Taylor's and Wegener's view, where when you're talking about when the movement is taking place, certain movement is again westwards, some which equatorwards, some let us say moving towards the other direction. So there is again a problem. First of all, these forces which are mentioned here do not comprehensively cover all the directions that are possibly taking place. It is not only towards the equator or only towards the west. There are other directions also in which the continents are moving. So the problem over here is this is not comprehensively basically telling us that. The major thing it is telling is that there is differences in the gravity which the continents which are undergoing. That is because of the differences, the land masses are possibly breaking and moving apart. That is why this is mentioned as equatorwards force. And then westernward direction certain continents are moving. That is because of the tidal forces or the gravitational force of the moon. Again, this is a very limited point and a wrong statement also, but we will not comment on it right now because we have to understand what the thinker is saying right now. Clear? Now let's see. When he stated this statement, this is a theory. Now he gives certain evidences to prove that, see, what my theory is, it is completely correct. Now what is the theory? Please understand. First evidences that he says is juxtaposition of continents. He gives evidence that, see, what I have said is correct. See the theory, see the evidences. Juxtaposition means that if I bring Africa and South America close, they will almost like a jigsaw puzzle fix with each other. Right? Why? Because he showed that, see, over here, they were almost together, and that is why later on they separated. So if he gives this evidence, he is trying to show that my theory is correct. So juxtaposition is this, that they will, like a jigsaw puzzle, basically join together if we bring the continents together. So the shoreline of Africa and South America facing each other have a remarkable and unmistakable match possibly, because they can basically almost fix with one another according to what? Wegener. So this is known as the juxtaposition of continents. First evidence. Second, rocks of the same age across the ocean. Now there was certain dating methodology. Dating means to find out the age of the rocks. When you find out the age of the rocks of surrounding, let us say, this North American part, Greenland, Iceland, European part, African part, these regions, they are of almost the similar age. Similar age that is close to 2000 million years ago or old. This is quite possible only if supposingly they were close to each other as one landmass. So this is also an evidence that is presented by Wegener in his theory. So that means similarity in the age of the rocks. You can draw these diagrams also. Please remember, I have drawn all these diagrams by hand. Many people, many aspirants I have come across while teaching online, offline. People say, sir, everywhere the books have basically drawn the diagram, and those printed books, diagrams and maps are there, and it is not possible to draw because the teachers just show us the map and they expect us to draw, while they themselves possibly don't draw. That is why, in order to resolve that problem, every single map has been drawn by hand, every single diagram is drawn by hand. You will see after a few slides the level of diagrammatic representation that I have made. Now, so that is why please don't be lazy. Don't be a person who doesn't want to work hard and simply just copy these things. Don't do that. Work hard, repeatedly revise these things, repeatedly make these diagrams. You should improve your abilities and capabilities if you want to qualify this examination. Remember that very well. UPSC will never ever come to your level. You have to reach the level of UPSC in order to qualify this examination. I always tell them in my batches also, my geography lectures also, society lectures also, or even when I'm going offline. It is basically a basic understanding that if you do not match the UPSC, they're not going to go to your level to possibly match that level. Please remember, it has a standard, it maintains that standard. When your copies are being checked, they do not know whether you come from a rural background or an urban background, whether you are educated from St. Stephen's College or some other college, whether your medium is XYZ and you're writing in some other medium. They do not know. They simply have a copy in front of them and they're going to check it. Now, please understand this. We might make excuses for the fact that this happened to me, this is a reason, that is a reason. In front of the examiner, they are not going to tolerate that. Please understand that very, very well. Okay. Having done this, we have done justification of continents, rocks of the same age across oceans. Next is the tillet. Now, please remember, we will be seeing these tillets or understanding them in detail when we will be doing the landforms, particularly the glacial landforms. So these are sedimentary rocks that are formed out of the deposits of the glacier. So these are glacial deposits, right? Particularly these deposits have formed in the glacial regions, but if they're found in other regions, that might be possible because those regions might have undergone ice age. And that is why certain deposits might be present in certain regions. So when we observe that there are tillets deposit found in this region of South America, this region of Africa, Antarctica, Australia, and Deccan Peninsular region of India. This basically explains us that possibly when this continent was one, there would be, let us say, and at that time, let us say tillet deposits might have been made during that time. And similarly, this is a particular pattern in which when we bring the continents, let us say in this shape, we will say it is forming like a shape over here. And these tillet deposits are formed. So they said possibly this is one of the reasons that the continents, these continents which we study together, were possibly together. And that is why we see this specific pattern, this pink region where tillet deposits are found, because they were together. So this is one of the other evidences which has been mentioned by Wegener. Next evidence is placer deposits. Now see, these deposits are of sand and gravel in the bed of the river. Sometimes valuable minerals like gold are also associated with it. That is why when you, let us say, combine certain, let us say, bring these continents together, you will see certain regions which are very close, which have placer deposits. Now, it says possibly because during the old times when the continents were together, possibly some flow of rivers were taking place because it was one landmass, and that is why these deposits of, let us say, gold and all are found in these particular regions. Because I said, these are deposits of the sand and gravel, which generally contains valuable minerals, particularly like the gold. Not necessarily gold, it can be others also, but placer deposits are majorly associated with a terminology or mineral with gold. It can be others also. So that is why possibly that these are the regions when if we bring them together, you can see in Indian peninsular part also, Australia also, South American and African region also. So possibly it was one, there were rivers flowing, these deposits were made, and that is why when the continents separated, we still find the evidences of these placer deposits when presumably this continent was one. Let's move ahead. Distribution of fossils. See, now there are a lot of fossil deposits that are found of animals and animals and plants. Now, I have mentioned few of them. You can remember one or two, it will work. Like we have Cyanogathus, we have Glossopithecus, we have Mesosaurus, we have Lastrosaurus. So, if supposingly, based on the evidences of the fossils that are found, let us say we found certain evidences of Cyanogathus in these regions and this region. We found certain evidences of Glossopithecus over here, 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 and here. So, if you bring the continents together, it will form like a bridge possibly where the animals might have migrated. Or let us say certain plants were present in certain regions. So, this shows us possibly this landmass was one. And that is why we have certain animals or evidences of these animals common to these particular regions, if presumably they were together. That is why this forms a very important evidence for the continental drift theory by Wegener. Now, you don't have to remember all of these names of these fossils. You can presumably remember one or two. It will be more than sufficient. So, these are the 5 evidences that have been presented by Wegener. Now, the problem that arises is it is full of problems in a way. We have already seen. Let's see them. First, lack of mechanism. See, Wegener could not explain a satisfactory mechanism how these continents are moving. Merely giving the name of gravitational differential or the tidal forces does not basically give you a proper mechanism. He has not explained. He's just mentioned them and said that they are moving in order to satisfy his theory. But he's not explained any proper mechanism. Next, ignored the oceanic crust. Now, Wegener's theory mainly focused on the movement of the continents, and it did not adequately account for the behavior of the oceanic crust. The problem is that the scientists of these time presumably assumed that because they could see only the continents moving because they were above the water level, so possibly they assumed only the continents moved. They had no mention about the oceanic crust, and that is again a very big flaw, which you later see plate tectonics basically covers up because it considers the concept of plate rather than only the continent, right? No complete justification. Now, when we see over here, we see that there is justification, but if you bring it together, you will see it is not a complete justification. So, many thinkers and geographers have said that this statement is absolutely wrong because by merely having a shape that is similar, which could fix or little bit fixed, does not mean that they were possibly the part or they were together. So, this is again a very important criticism that has been made over here. Wegener did not elaborate on the direction and sequence. Now, he was very random. He mentioned about the equator word, he mentioned about the westward, similar to Tyler, but he did not go into further detail because the problem is those were not the only direction in which the continents were moving. So, he did not elaborate on that. That is again a very, very important or let us say major issue that is present in this particular theory. So, this is the 4th problem or the criticism here. So, let's move to the next concept. We have done Lothian Green's concept of tetrahedron hypothesis. We have done continental drift by Taylor. We have done continental drift by Alfred Wegener. Now comes the convectional current theory or concept by Harry Hess. Now, this is something very common, very to understand, very easy to understand, very important also. We have done in the previous lecture the concept of what is lithosphere, asthenosphere and all. We have already done what is the crust, what is mantle and core. We have already done those parts in the previous lecture. So, I'm not going to repeat those concepts. Using the concepts basically from what we have learned in the previous lectures, I'm using them here. Now, let's see. What is the main purpose of this theory? To explain the Earth's lithospheric plates and the dynamic processes that shape the Earth's surface. So, he says that the lithosphere movement has to be explained. So, possibly in order to explain that, he gives this particular theory, that is the convectional current theory. So, this is the major purpose. Now, see what is the process. Now, please see here, I will be showing you the diagram. Let me explain you the diagram in 2 minutes and then possibly you will be able to understand it well. Now, see. See the core over here, you know that it is very hot. This is the mantle part. Now, this is supposingly the crust, and obviously the lithosphere also includes the crust and the upper part of the mantle. So, he says there are, like as we have when you even heat a water, you see the convectional currents forming, right? Similarly, he says that over here, let us say this part is what is warm, basically because of the temperature, it basically rises. As it moves up, because the temperature over here is relatively cooler, it basically forms a convectional current where the sinking takes place, and then again this movement and this convectional current is formed, right? This is basically taking place inside the mantle. What does he say is, because while the convectional current is formed, this movement basically pulls this lithospheric plate also along with it, because the convection current that is moving is exerting a lot of force. Now, this forms the basis of your plate tectonics theory also, which we will read. So please understand. We'll come back here again. Now let's see. The Earth's mantle is a layer of semi-solid rocks beneath the Earth's crust. This is the view of what? Hess. Now, within the mantle, heat is generated by the radioactive decay of elements. Again, there are radioactive elements, so that is why a lot of heat is being generated. Now, what is there is heat generated in the mantle creates a process known as convection. Obviously, there is heat generated, so convectional, something which is heating will rise. You will see this in the climatology chapter also. You will see when you are heating water also. So when something is getting warm or heated, it will rise. The hot, less dense material rises up. Now, if you see here, this is a hot, dense material. It will rise hot because of the temperature from the core, outer core. And obviously, if it is heated, then it will rise. So it has risen over here. Now, this process of rising over here is known as upwelling over here also. See here. The hot, less dense material rises upwards. This is known as upwelling. You will see similar concept in oceanography also. Just understand this concept. Now, this is what? Rise. This rise that is taking place is known as upwelling. Now, what happens is, while the cooler, denser material sinks downwards, now this basically will move this part, and after some time it will move down, obviously, because it has cooled. So this is what? Moving down. This is known as downwelling. But the thing that is important is, during this process of upwelling and downwelling, the movement of this mantle or these convectional currents within the mantle leads to these slabs or these lithospheric layers being pulled. This is what is being explained, and this also forms a core of the plate tectonics which is studying. See here. The convectional currents are responsible for the motion of the tectonic plates or the lithospheric plates which are being studied right now. This is the concept of convectional current theory. Just remember that. It is very simple, very easy to understand. Again repeating, see, this is a region because of the heat that is supplied by the radioactive decay. Over here, the temperature rises. So let us say there is this upwelling process will rise, or there will be a rise of the material because it is heated. It will rise, move up. It will further move, and then because it has risen to the higher height, so what will happen? It will cool, and after that cool, it will sink because it has already cooled. So when it will be sinking, this is known as downwelling. While this process of moving from upwelling to downwelling, this movement of the material exerts a force on the layer that is above that is the lithospheric layer, and it basically, along with this movement, this layer is also pulled. That is why they say that the lithospheric layers are moving, because of the pressure that is exerted, the force that is exerted by the convectional currents that are moving inside the mantle. This is what is mentioned by Hess. Clear? Now there is another concept which again forms the basis for the plate tectonics theory. Please understand, if you want to understand the plate tectonics, you need to know the concept of continental drift. There are errors, but still the concept was important. Second is the concept of convectional currents, which is again important. Third is the concept of seafloor spreading. This again is important to understand. This forms again the basis for the plate tectonics. See, seafloor spreading by again Harry Hess. Okay, quickly write the heading. So everybody please remember this. The concept of seafloor spreading is given by Harry Hess. The concept was earlier given by Arthur Holmes. One more thing, there are certain books which have even mentioned that convectional currents theory has already also been explained by Harry Hess, but the first person who has given is Arthur Holmes. So just please note this. In certain books, what is mentioned is that Harry Hess has also contributed, but the main person who has given this theory initially is Arthur Holmes. Certain books even mention Arthur Holmes and Harry Hess, but please note this. This is again a concept that is like a correction only, you can take it, but mention Arthur Holmes over here because this is the person who has first or the majorly contributed over here. Okay, let's move ahead. Concept of seafloor spreading by Harry Hess. Now this concept is exclusively, majorly or primarily given by Harry Hess. Now let's see here. What is the main purpose? First of all, in 1960, Harry Hess gave the unique concept to explain the mid-oceanic ridge. If you ever see, let us see here, let us go to the map of the world. Over here, you will be seeing that there is a mid-Atlantic ridge that is present over here. So there are mountains inside what? The Atlantic Ocean and chains of them. And new mountains are continuously rising, volcanic activities are also going on. Similarly, in other parts also. So the problem that arose is how is this concept basically working? So always that was a point of curiosity in the minds of the people also. So please understand what happens is seafloor spreading. So he wanted to explain the mid-oceanic ridges. Similarly, in other parts also of the world or inside the oceans, you realize there are certain mid-oceanic ridges present. But in Atlantic Ocean, you can very predominantly see them. So he wanted to explain the reasons behind them. Statement. He postulated that mid-oceanic ridge was located on the rising limb of the convectional current. Rising limb of the convectional current. Now see here. That is why I am telling you, both of them, Harry Hess and Arthur Holmes, both have contributed directly and indirectly to both the theories. But for convectional current theory, first at Arthur Holmes, then possibly Harry Hess. But for seafloor spreading, again, the main person is Harry Hess. Indirectly, obviously, Arthur Holmes has also contributed. This is a mid-oceanic ridge, right? Over here, it is saying that because of the upwelling processes that are taking place, it is leading to, let us say, what? Possibly new material or let us say basaltic outcome that is taking place, right? So basalt is coming, basalt formation will take place because of the outpour of what? The magma. Magma will come out in the form of lava. So that means it will lead to formation of some ridge-like structure over here. So what is being said here? That mid-oceanic ridges were located in the rising limb of the convectional currents. So this is a rising limb. So what is going on? This basically will lead to certain outpour. Why? Because this force will lead to this lithospheric plate basically pulled or moved towards or inside the mantle. This will get destroyed. So further, this mid-oceanic ridge is basically creating new lithospheric plates or the crust, you can, in a way you can say. So please understand this. Rise of the convectional currents, tensional forces on the surface, spread on the opposite direction, spreading point. What does it mean? Rise in the convectional currents, tensional forces on the surface. This exerts force on the surface, which will lead to it moving this way. And then the outpour that is taking place from the magma will lead to the formation of new substances being deposited here and new lithospheric plate, or let us say these new crustal formations taking place. Spreads in the opposite direction. So because this convectional current will pull the slab inside and new outpour that will take place will form new lithospheric plates over here. This point over here where the spread is taking place is known as the spreading point. This is known as the spreading point. We will be getting to know or understanding this better when we will be doing the plate tectonics. So you can see lithospheric plates are over here, crustal plates also you can say, because again lithosphere basically forms crust and the upper mantle part. So this is being new crustal formations are taking place, and over here they are getting finished because it is again moving inside the mantle. Slowly it will deform, right? So this is known as the spreading point. On the other hand, please see, places of the descending convectional current, that means the places of the descending convectional current, basically over here compressional forces are taking place. Why? See here. Over here already a lithospheric plate is there. This plate is moving thisward. So there is compression that is taking place. Descending crustal material. So this crustal material will further move inside what? The mantle, and slowly it will just diminish or vanish because of the high temperature that is there. So this region is known as the subduction zone, where one plate is moving or subducting another under another plate. So this is known as subduction zone or point. Where it is spreading, it is known as spreading point. Where one plate is moving under or subducting another, it is known as subduction point. Now, please understand, That is why you will see the convectional currents basically focuses on the internal part. Seafloor spreading is talking what is taking place on this part. Both of them are intricately linked. That is why in the various books, you sometimes see convectional current and seafloor spreading by Arthur Holmes and Harry Hess. They might combine both of them because both of them are very closely intricately linked. Convectional currents focuses on the internal mechanism and what is going on. Seafloor spreading talks about the external part, obviously in reference to the internal part. Clear? Next, the crustal materials are spreading from the mid-oceanic ridges. So this is a ridge, this is spreading outward. The sea floor is moving on either side is known as seafloor spreading. So you can say, let us say if it is inside the ocean over here, this is moving. Supposingly there is a volcano over here. There is a, let us say a volcanic like substance or some structure over here. After a few years, possibly what will happen, this what was present here will reach this. Why? Because new crust are being created or lithospheric layer are being created, it will move apart. So that means there is movement that is taking place away from this particular region towards the other side. So that means from the mid-oceanic ridge, the sea floor is basically spreading outward. Now this is known as what? The sea floor spreading. Clear? This is known as sea floor spreading. Let's move ahead. What is the evidence over here? Now, the most important thing is understanding the concept. Yes, there might be spreading of the oceans and seas. That is fine. But what is the evidence? The most important evidence is with respect to the magnetic properties. Now, see here. Supposingly, there is again upwelling taking place. I've shown you just the upwelling part, now the downwelling. So, this is a limited part over here. Now, let us assume there is a again outpour of what? Magmatic substances taking place. Now, what happens is the magma which comes out, it is known as lava. It has what? Iron, nickel and all. Magnetic substances are present. Now, when they are at such a very high temperature, they come out. What is the direction of magnetism present on the earth during that time? They basically align themselves in that particular direction. Supposing in North Pole and South Pole is present. When the substances or the lava comes out, those iron and nickel basically will align themselves according to the magnetism or magnetic properties of that time of the earth. One more thing that has happened is because of the convectional currents direction sometimes changing inside the core also and mantle also, there can be a possibility where reversal of the polarity takes place. That means North Pole becomes South and South Pole becomes North. Now, this has been observed in the sea floor. Supposingly, let us assume that magnetic material have come out in the form of iron nickel and they have aligned themselves in this direction, right? Because the magnetic properties, or let us say the direction of magnetism was in this direction. But let us say a few thousands of years ago, it was reversed. So possibly they will align themselves in this direction. So because it is moving apart, you will see there is an observation that there is differences in the polarity that is present here. Now, this was very, very confusing why this happened, but this can be observed through multiple means. First, if you basically do the dating of the material that is present here, it will be young. If you date this substance, it will be very old. That means this is being created of late and this has been created very late. That is why this is very long ago. So that is why it is basically moving apart. Polarity reversal is also an indication which you can match that supposedly long time, let us say few thousands years ago, there was reversal in polarity. And similar thing you note it over here. Similarly, let us say few thousand years ago, before that, there was reversal in polarity and you can note it on the mid-oceanic ridges region around that. That will give you an idea that means the reversal in the magnetic properties reflect the magnetic properties or the direction in the mid-oceanic regions and surrounding them. So the outcome is that in a way you realize that there is a spreading of the mid-oceanic region, or that means spreading of the sea floor is basically taking place. Now this was a breakthrough that took place. That is why it forms a very, very important ingredient. So see here, the survey of the mid-oceanic ridges for the magnetic properties was done. Alternative bands of normal and reverse polarity were found in either side of the ridge. Now, this was correlated with the times when the magnetic or reversal took place, and it was found exactly the same. And after some time, what happens? Again, new magnetic substances are coming and they're moving apart. And dating methodology also helps us that this is young, this is old, because over here new crustal formation will take place and these by that time will move ahead on this direction. So these are old. So in a way we realize that the sea floors are basically spreading or moving apart, an outcome of the convectional currents. So this was an evidence, most important evidence that took place, which we will even see in the plate tectonics theory. Let's move ahead. Plate tectonics theory by Mackenzie and Parker, 1967. Please see here. This theory tries to explain the dynamic movement and interaction of the Earth's lithospheric plate, which makes up the outermost layer of the planet. Now see, lithospheric plate movement, what is the reason, why it is taking place, what are the mechanisms, everything. He wanted to understand and explain them more comprehensively, because the theories which had come prior to that have also done their part. Seafloor spreading, convectional current theory, continental drift has explained its various dimensions, but they were not able to satisfy it completely. So that is why this theory came. It is again, this theory is said in the form of theory, but it itself is not a theory, because it basically takes up all the concepts of convectional current theory, seafloor spreading, in order to explain this particular theory. So this theory tries to explain the dynamic movement and interaction of the Earth's lithospheric plates, and which makes up the outermost layer of the planet. Now, definition first of all. The rigid lithospheric slab or rigid or solid crustal layer is technically known as a plate. Right, so lithospheric plate or plate. Now the plate you very well know over here, latest means the basically a lithospheric plate, which means the crust as well as some part of the upper mantle, right? What is plate tectonics? The whole mechanism of evolution, nature and the motion of the plates that is taking place is known as plate tectonics. So everything, what is the nature, how the movement is taking place, how it basically evolved, how it is created or destroyed, what are the things that are created during the process of this movement, is everything covered in the concept of plate tectonics. So this is the definition. Now, basis of the theory, first of all, we will not be repeating these theories, but see, first is continental drift theory by Wegener. Why? Because he at least gave the view that there are some movement of continents taking place. Though over here we realize that the plates are moving, not continents, but it formed the basis that some movement is taking place. That is why the conceptually continental drift theory forms a basis. Second is seafloor spreading by H.H. Hess. When I mentioned about seafloor spreading, please remember that when I'm talking about seafloor spreading, it also covers the concept of convectional currents theory by Arthur Holmes. So if you want, you can write seafloor spreading and convectional current theory by Arthur Holmes and H.H. Hess. In this way also you can mention, there is no problem. But when I mention seafloor spreading, it is by default covering the concept of convectional current theory. Now see, driving force or the mechanism. Now the question comes, from where is this energy coming, which is basically moving these plates? So the plates are in constant motion, driven by internal heat generated by the radioactive decay in the Earth's mantle. Now, the radioactive decay in the mantle is basically a cause for this energy being generated, and that is resulting in convectional currents. Now, this convectional motion of the mantle convective cells sets the plate in motion. So again, convectional current. What is present in seafloor spreading also we had studied. So the radioactive decay is generating the energy. This convectional currents is basically leading to what? The convectional current cell being created. What is a cell? What is a cell? This is a cell. This is a cell, right? A closed packet over here being represented. So these are convectional cells that are generated. Now these motion of the convectional currents basically lead to what? The plates or plates moving on the surface, right, on the mantle. So this is the driving force. So you should remember two things. First is the radioactive decay. Second is the convectional currents that are leading or causing the plates to move, right? Let's move ahead. Tectonic plates classification. Here again, please understand, we will not go into the mechanisms because we've already studied the convectional current, seafloor spreading and continental drift. We know the exactly same based on the concept we have done, the movement of the plates are taking place. Now we will classify them because this is again important from the prelims as well as the mains perspective. If I classify based on the geometric aspect, I can classify the plates 7 major plates and 22 minor. We do not have to remember all minor plates, I mentioned few, but major you have to remember. Major plates are the North American plate, South American plate, African, Eurasian, Antarctican, Pacific and Indian Australian plate. minor, you have the Arabian plate, Nazca plate, Philippines plate, Scottish plate, Cocos plate, and so on and so forth. There are multiple plates, which you should have an idea. These are the important ones. Based on the kinematics, how the movement is taking place, there can be convergent boundaries, there can be divergent boundaries, and there can be transform boundaries. You have little bit knowledge based on what, while I was teaching you the convectional current concept, you have little bit knowledge about these things. But please remember one thing, we will be studying over here in detail, so it will become easy for you to comprehend. Clear? So these are the three concepts which we will be understanding. So let's first of all understand this thing. There are major plates also present over here. There are minor plates also, few of them present here. Unlike the continental drift theory, where they said that, let us say, the African continent is only moving, and only, let us say, the South American continent is only moving, that was wrong. What they basically said is, when the plate is moving, it is not only the continent. These are huge plates that are, let us say, present. These plate as a whole basically move. It is not only the continent. The only problem is, in continental drift theory, they assume that because this continental part is visible or above the water surface, so only this is moving. No, it is a complete part as a whole which is moving. So when the plates are moving, it is also the oceanic part also that is covered in them. Please understand that. So it is not only the continent part or the landmass which is visible above the earth that is moving. No, it is this complete plates that are moving. They might be subducting or whatever be the case, we will be seeing them. So this is African plate. This is what? The Eurasian plate. This is the Indian plate. This is Arabian plate. This is Australian plate. This is a Pacific plate, then minor plate of Philippines, then you have the Antarctican plate, you have the Scotia plate, you have South American plate, this is the Cocos plate, this is the Nazca, again these are the minor plates, you have another minor Caribbean plate, then you have Juan Foucault plate, this is again a minor plate, North American plate, again a major plate. So these are the plates that are present. So this is the difference from the continental drift theory, which says only continent moving. No, the plates are moving. Plates might cover the regions of the continent also and the ocean also. That was neglected by the theories of continental drift. They did not consider the oceanic part. Clear? So this is the first part which we have seen being presented here. Now comes the part of kinematic aspect. Let us see one by one. When I say about divergent boundaries, please understand, you mostly observe this in the mid-oceanic ridges. Why? Because in this particular region, due to the convectional currents, new crustal formation take place and the plates are moving apart. Divergent plane boundaries, that means plates are diverging. They are known as constructive. Please understand, divergent plane boundaries are constructive in nature. Why? Because when the plates are diverging, because of the pressure due to the convectional currents, there will be new material that will be coming out. It will be deposited and further new plates will be formed. Lithospheric plates will be formed. So that means construction is taking place. That is why divergent plane boundaries are known as constructive in nature. Now you know that this divergence is taking place because of why? The convectional current cells that were there. Because of the convectional currents cell that were there. So when a new crust is generated, as the plate moves away, new crust is generated here as the plates are moving away from each other, the site where the plates are moving away from each other are known as the spreading sites. This is what? The spreading site. Clear? Now this can happen in various dimensions, various places. We will see this. Divergence, that means there are plates, so there is convectional current taking place, so this will move apart. When it is moving apart, because the convectional currents are there, further magma in the form of lava will come out and it will be deposited. Now what will happen will lead to further crustal formation, a new lithospheric plate or a part of it being created. So there is construction taking place. That is why it is known as constructive in nature. Divergent is associated with construction. Clear? Similarly, if you see oceanic divergence, what do you mean by oceanic? If there are two plates which are inside the ocean or ocean plates, they are moving apart. What will it lead to? It will lead to mid-Atlantic ridge. This is an example in the Atlantic Ocean, or mid-oceanic ridge you can say. So oceanic divergence is taking place. That means within the ocean, if there is divergence taking place, there will be outpour, and it will lead to what? Mid-oceanic ridge, or one example is the mid-Atlantic ridge, which you see in the Atlantic Ocean. The ridges that are created is because of the oceanic divergence. See here, let us say this is the inside the Atlantic Ocean. Inside the Atlantic Ocean, if this convectional currents is there, these are what? Oceanic plates. Now it will move apart, ridge will be created. This is what is the scenario with the mid-Atlantic ridge formation. It is an oceanic divergence, and that is leading to the construction of what? Further lithospheric layers. That is why it is constructive in nature. Clear? Let's move ahead. Continental divergence. Now see here everybody, you would have seen the case of Africa, where this part of Africa is basically moving apart. So there is divergence taking place. So continent divergence over here is an example. Now this is example of East African Rift Valley. Again divergence is taking place. So this is basically separating, right? Divergence can be continent based also, and oceanic divergence also. Now comes the convergent boundaries. We have done with the divergence. Now comes the convergent boundaries. Convergent means basically two plates are colliding now. Now you have heard the collision taking place, but the very important thing will, which plate will move down? You see over here, we have shown that this plate is moving down and this is here. Why this is not moving down? One or rather 2 points you should always remember. The plate which is more dense in nature or more denser is the one which is going to move down. The one which is less dense will not move down. Obviously, you need more density because that is why you will move down. The less dense will be above. Now, another first point is this, the plate which is denser in nature will move down or subduct. You have studied in the previous lecture that oceanic plates are much more dense than the continental plates, right? So whenever there is a collision between an oceanic plate and a continental plate, you will see the oceanic plates are basically subducting. Why? Because they are more denser in nature. If supposingly continent are basically colliding, in that case also the one which is more dense will be one which will be subducting. So it is a density which basically decides which one is going to subduct beneath the another plate. This is a very important concept and you should always remember that, because many people just rote learn it and do not understand this concept. So density is the one which is deciding which plate will subduct. Subduct means which will move down. When two plates are colliding, so one will move down. So one which is going down, this is known as subduction. The region where it is going down is known as a subduction zone. Clear? Which one is going down or subducting? The English word is subducting. So that is basically the one which is more dense. Clear? Okay. So over here, let us say this plate is moving. This plate went, let us say, inside the mantle. Now it is subducting. This is known as a subduction zone because this is more dense. Now see, when two plates move towards each other, where one plate overrides the other and the other is overridden, that means that means one is moving down, other remains in this position. A little bit changes will be taking place on this also, but the one which is basically subducting, other will be the one which is in this position, right? So one overrides and the other is overridden. Similar language in a different form. Now this convergent or convergence can basically take place in various ways and various situations. First, ocean-continent convergence. Now there are plates, one is oceanic plate, another is, let us say, continent. If they basically collide, what is going to happen? It occurs between the oceanic and the continental plate. Now let us take few landforms. Let us say volcanic arcs being formed. What are volcanic arcs? One long chain of volcanoes that form on continental plates above the subducting oceanic plate. Now see over here. Everybody. See over here. Volcanic arcs basically form a long chain of volcanoes. Now let's see, in this particular case, when we see Andes, we see the Nazca plate is subducting under the South American plate. See here. This is the Nazca plate. Nazca plate, why it is called an oceanic crust? Because it is under the ocean, obviously. This is the South American plate. Now this Cocos is basically this, remember, this is complete Nazca plate. Now the Nazca plate, this is a boundary. It is subducting under the South American plate. Now this plate is again what? A continental crust, a plate. Now if Nazca plate is moving towards the South American plate, Nazca plate is an oceanic plate. It is more dense in nature. It will be subducting or moving beneath the what? Beneath the South American plate. Clear? Now what will lead to? It will lead to a long chain of volcanoes that form on the continental plate. Now see here. This is, let us say, the direction is, let us say the Nazca plate, this is South American plate, it is going on. Now over here, because this is a lot of pressure being exerted, it is moving down, it will slowly melt. It will slowly melt. It will lead to again a pressure being exerted as a counter force, and over here volcanic eruptions might take place. And chain of volcanoes will form, volcanic eruptions will take place. That is why if you see Andes is basically a volcanic arc. Volcanic arc, a long chain of volcanoes that form on the continental plate above the subducting oceanic plate. So over here, when a plate is subducting under this continental plate, this large part of the plate over here is getting destroyed. Please understand, convergent plate boundary is also known as destructive. Why? Because over here this part is moving or subducting under, this part will get destroyed. That is why it is known as destructive. Now when it is getting destroyed or destructed, this part is moving inside the mantle. So that means it is a pressure or a force being exerted inside the mantle. It will melt. It will melt. Now you know that law of nature, for every action there is equal and opposite reaction. So what happens? This, in order to compensate this, there will be again compensatory volcanic eruptions that might take place in this region, right? Because this part of the plate has gone inside the mantle and a lot of force and pressure is exerted. So this leads to the formation of volcanic arc. Example is the Andes. Now the Nazca plate subducting under the South American plate is an example of this. Second, folded mountain range, Rocky Mountains. North American plate and Juan de Fuca plate along with the Pacific plate basically can lead to folded mountains. There is a possibility when, let's see, there's a possibility what happens is sometimes it is not necessary that in every case similar things will happen. It will depend upon the nature, the density, the pace at which it is moving. So a lot of factors depend upon whether it will be a volcanic arc forming, whether it will be folded mountains forming. A lot of situations vary upon case to case basis. Now over here if you see, this is Juan de Fuca plate, a minor plate. This is the Pacific plate. Now these plates are subducting under the North American plate. Now what happens is, please see, sometimes when the subduction is taking place, it leads to some folded mountains because the pressure is exerting. So there will be crustal folding that takes place and that leads to the formation of folded mountains. So over here when you see the example, let's see, Rocky Mountains, these are fold mountains. Why? Because there's some folding taking place because of the pressure that is exerted. So North American plate and Juan de Fuca plate along with the Pacific plate boundary. Over here you see Rockies Mountains along the North American region. Why? Because the pressure that is exerted by the subducting plate that leads to the folding of the crustal material that leads to the formation of folded mountains in this particular region of the Rockies. Now this is again example. Third is foreland basin and back arc basin. Now please understand, this is something very important. Basically you should understand, supposingly this is third landform. Please understand, these three landforms which I have talked about are under the convergent boundaries, under ocean continent convergence, right? Under ocean continent convergence, I have done volcanic arcs, I have done folded mountain ranges, and I am doing foreland basin and back arc basin. What are these? Supposingly this continent, this oceanic plate is basically subducting. This leads to, let us say, these volcanic arcs being created. Let us say Andes. What you will see is this region, and there are two regions that are created. This region is known as the foreland basin, and this region is known as a back arc basin. Please understand this. This is a basic labeling. So this is again an outcome because this will be a little bit elevated because of the volcanic eruption taking place. These are two basins that are created. These are foreland and back arc basins. These are two things as landforms, you should remember them because this can be asked, because nowadays questions regard to landforms are being asked, so you should know these two statements. Okay, let's move ahead. Now we have done ocean continental convergence and the landforms. Let us see ocean convergence. Now see, it is a convergence of two oceanic plates converging. Trenches, example Marina Trench. Now if you see, if two oceanic plates are converging, now what happens? Let us assume, let's see this. Let's take an example for 2 minutes. Let's come here. Let's see. Supposingly, this is a plate. This is a plate. There is another, let us say, plate that is coming, and that is basically moving down. Now, if both are oceanic plates, the one which is more denser will move down. If you realize this, because of the subduction, there will be a lot of depth that is created in comparison to this level. See here. Because of this subduction, there's a lot of depth. This depth, or let us say that the structure of lot of depth that is created because of this at that subduction zone, this is known as a trench. These are the regions, basically regions where the subduction is taking place. So because of subduction, that leads to the folding of these plates. So that means the level in comparison to the other plates, this is much more down. It can be multiple kilometers down also. These are known as trenches. Now these trenches are why? Because inside the oceans only you will find them. So these are, example is Marina Trench. Second is volcanic island arcs. Now these are chain of volcanoes islands formed as a result of subduction of one oceanic plate beneath the another. If you see the Aleutian Islands, these are again because of Pacific plate subducting under the North American plate or North American part. Clear? Chaliye. Next is continent convergence. Now if you see the example over here, two continents converging. This is an example of Himalayas also. If you see, in case of the Himalayas, you see the Indian plate basically collided with the Eurasian plate. Yes. Now in this case, what happens is the one which is denser in nature will be subducting under the less dense one. So what happens is, one plate which is converging, let us say subducting, this subduction will lead to pressure being exerted and a lot of, let us say, mountain or folded mountains will rise. Because let us say one plate is subducting, obviously that will create a lot of pressure. It will lead to a lot of crustal folding on this or this plate that is under which the subduction is taking place. So what happens is the folded mountains are formed. This is an example of the Himalayas also. So the Himalayas, the Indian plate and the Eurasian plate collision that took place, it might lead to uplifted plateaus like in the Colorado Plateau. So this is an example of the folded mountains that are formed in the collision of Indian as well as the Eurasian plate, that is the Himalayas. So this is an example of this. Let's see. Transform boundaries. Now transform boundaries over here is basically the case where a lot of situations, two plates are neither subducting or now diverging. Or let us say there is no convergence or divergence taking place. But instead, two plates are basically, let us say, sliding along with each other. This is known as transformed boundaries. So characterized by horizontal movement of the tectonic plates sideways. So these are two plates which are basically sliding. So that is why it is conservative. Why conservative? Because neither destruction or construction is taking place. So that is why it is known as what? It is known as transform boundaries. Please note it down, all of you. It is very, very important. Next, transform faults can be formed when two tectonic plates slide past one another. It might lead to the creation of, let us say, some structures like San Andreas Fault in California. It might offset a drainage. Let us say a river is flowing. Now, a river was flowing. Two, let us say, plates slide. Possibly it will disrupt the drainage pattern or the way in which that rivers was flowing. So this is again an offset drainage. Example, the Owens River in California. So these are two most important things. Last is mantle plume. Mantle plumes. Please understand. Let me show you a diagram. These are basically the diagrams which you see. This is the core. From core, you will realize that these mantle plume rise. This is the tail. This is the head. This is the riding plume. Further, it might move up and lead to formation of, let's say, basaltic flood. And later on, because the plate is moving, this part will move further forward, and similarly other products, or let us say other eruptions that have taken place will lead to further, let us say, islands being created, and this is a basic concept. Let us see, understand this concept. Based on the diagram only, we'll explain you. See, what happens is, these are narrow vertical columns of hot buoyant rocks that rise from the Earth's mantle to the crust. So, because the from the energy that is generated because of the radioactive decay and all, you will realize that vertical columns of hot buoyant rocks, you know that basically we're talking about magma, will rise and that will move upwards. Though they are thought to originate deep within the Earth mantle, specifically from the boundary between the mantle and the outer core. Now, there are a lot of assumptions whether it is rising simply from the mantle or obviously it is going to cross mantle, but the assumption over here is that it is rising from the part of the core, and then this plume is rising, this vertical column is rising and reaching the surface. It consists of hot molten rocks, magma, and solid rocks that are partially melted. The radioactive elements and the reasons for this basically plume basically rising. Now what happens is, these plumes can lead to volcanic hotspots such as the ones which are responsible for the Hawaiian Islands. Now please understand this concept for 2 minutes. The actual reason why certain regions have plume and other regions do not have, there is no explanation for that right now. It is possibly because of the nature of the places where possibly these magmatic eruptions are taking place. There is no correct explanation for that. But what we see is certain observation where these hotspots are formed. From the core of the mantle boundary, this vertical column basically rises. This is again very hot magmatic substances that rise. They basically reach the surface. Now, what you have to understand is, this yellow part is a lithospheric plate. Now, this is continuously moving, but this position of the plume is fixed. Supposingly, what happens is, this plume rises because this plume, when it rises, it will try to lead to this magma basically coming out, and that will be spilled on the surface of the plate. Clear? Now, this plate will further move ahead. So that means, let us say this plate has moved ahead, this part of it has reached here. But again, the magmatic eruptions from this hotspot will keep on coming. So again, possibly over here, you will see certain islands being created. This will again move ahead. So that means plume's position is there. Any plate that comes on top of it, there will be volcanic eruptions, or let us say magmatic outpour, and that let's say a landform is formed, an island is formed, and then the plate further moves. That is why, if you realize, Hawaiian is basically an outcome of this particular hotspot. Similarly, if you see, you would have believed that, so how come there is so much basalt, or let us say the Deccan Trap that is formed, right? There's always a problem that question that how come this Deccan Trap is formed in the peninsular region. Please remember, when the peninsular part was moving and coming, or let us say coming close to the Eurasian plate, much before that, it basically crossed a reunion hotspot. So that means, supposingly, when this is, let us say, the peninsular part, when it came on top of the reunion hotspot, during the Cretaceous period, there was outpour of lot of magmatic or basalt that came out. Later on, this plate further moved ahead, right? It moved ahead and later on collided with the Eurasian plate. But during the Cretaceous period, when those basically magmatic outpour took place, that basically led to the formation of the Deccan Plateau or the Deccan Trap, right? So that means, when it was on top of the reunion hotspot, those volcanic basalt outcome took place, and later the plate moved ahead. Now see, let's see here. This is supposingly, let us see, let's take this. Supposingly, this is the mantle plume and this is the hotspot. When the Deccan Plateau was on top of it, while it was moving because of the tectonic movements, during the Cretaceous period, outpour took place in all these regions, and that means that led to the later on formation of the Deccan Trap. But this plate kept on moving, and later collided with the Eurasian plate. So that is why the answer is that the Deccan Plateau, though there is no volcano underneath it, but how come that igneous rocks are found here? The reason is because it crossed this particular hotspot, that is a reunion hotspot, and that led to this known as the igneous rocks being present in that region. So this is because of these plumes and the hotspot that we basically study here. Clear? Another last concept that we study is Pacific Ring of Fire. Pacific Ring of Fire, this is an representation. First of all, let's see. Pacific Ring of Fire is a tectonic belt of volcanoes and earthquakes. This is a region where, because of the continuous plate movement, there are a lot of volcanic eruptions and earthquakes that take place. Now, this is about 40,000 kilometers long and up to 500 kilometers wide, surrounding the Pacific Ocean. Now, if you see this belt that I have drawn is a region which is known as the Pacific Ring of Fire, which has massive earthquakes, which have massive volcanic eruption taking place because a lot of subductions and plate movements are taking place. So this is known as the Pacific Ring. Now, over here you will see convergent plate boundaries, where volcanic arcs like Andes of South America, subduction of the Nazca plate and the Antarctic plate under the South American plate. You will see the Himalayan subduction of the Indo-Australian plate under the Eurasian plate. Hotspot, you will see the Hawaiian Islanding found. Transform boundaries, obviously there are, along with the subduction and divergence spaces taking place, there is also transform boundaries that are there. So example is San Andreas Fault. So what we see is, in these particular regions which you see, a lot of tectonic activity is going on. Because of that, when there is tectonic activity, there will be by default outcome will be earthquakes and yes, volcanic eruption, because these are weaker zones. That's why it is known as Pacific Ring of Fire. Clear? So we have done with this important topic. This is quite a lengthy topic and quite an important topic also. We have covered almost every aspect over here. Certain things will be covered in the other topics also, because we are arranged in such a manner that there is coherence and proper understanding. So we'll be doing the volcanoes also in the landform chapter, not over here. This is a complete understanding of the distribution of ocean and continents, which you are required for your prelims and the mains. Now please understand, based on what I've taught you, you will see, if you see the PYQs, the question has come, Pacific Ring of Fire, why it is a zone where a lot of earthquakes and volcanoes are found. You know the plate tectonics theory and this diagram. Question has come, explain the continental drift theory with evidence. You know the Alfred Wegener's theory with evidence I've given. Also, you can mention in brief about the Tyler's theory. They've also asked you what is, let us say, plate tectonics theory in the previous year question. You can explain that also. You can use the plate tectonics theory to explain now how volcanic eruptions possibly taking place, how the Himalayan formation is taking place, and so forth, the volcanic arcs, how they are forming. All these things have been explained. So if you read and go through the content well, listen to the lecture well, you will be able to answer all of them.
Lecture 4 of the geography series from the physical geography section. Today, the topic is minerals and rock. Now, this topic does appear to be a relatively easier and relatively smaller topic. But remember, it is a very, very important topic. Repeatedly, the questions have been asked in the preliminary as well as the mains examination. So you should be very well versed with this particular topic. I presume that before we begin this particular topic, you would have revised or gone through the previous 3 lectures. Now, please remember the sequence and the manner in which I am proceeding. There are a lot of topics that you might not understand if you skip any lecture. So please follow the proper chronology. Go through topic 1, 2, and 3, and this is the 4th lecture, because this lecture will also form the base for the next 2 lectures, that are geomorphic processes as well as the landforms. So remember one thing, you again have to have your A4 sheet along with you, and please keep on noting down whatever I am telling you. There will be certain topics that are mentioned in the NCERT, but I might be covering them in the later chapters, because let us say when we talk about volcanoes, we will be covering the topic of landforms rather than in this particular chapter. So that is why I'm telling you, go through the chapters in a proper sequential manner and make the notes properly. These notes will be more than sufficient for you to appear in the examination with a lot of confidence for the preliminary as well as the mains examination. So let us begin with the topic minerals and rocks. Let's begin. Rocks. Now, the most important thing, whenever you go out on the field, let us say, or you are walking on the road nearby, you'll be seeing certain rocks being present. The moment you just pick up a rock, you know it is a rock, but what type of a rock it is? If you know that, that is even more helpful for your analysis. Now, the most common thing is you might be coming across rocks which are of different colors, different types, different sizes, obviously. Now, this topic, that is why, is not only simply important for your studies for civil services, but also as a person who is living in this particular world. So the topic of rocks is, that is why, very, very important. Now, let's see. When I talk about rock, a rock is a naturally occurring solid aggregate of minerals or mineral-like matter that forms the earth crust. Now, when I talk about the word, please understand one by one.
A rock is a naturally occurring. Now, this is something that is present in the nature. Now, this is, see, if we are producing it artificially, we are not considering those substances. We are considering from the aspect that it is present naturally, right? So, the word naturally has come. Solid aggregate. When I use the word aggregate, what do you mean by that? That means it is a combination of a lot of things. That means a lot of minerals might be present. So that means when I talk about aggregation or aggregate, that means a lot of things are present inside that. That is why if you see various minerals are present or mineral-like matter might form, that is why they are present in the Earth's crust, right? Because if you say, so why Earth crust, can't they be inside? Please remember, if you go inside the mantle, obviously, it is in a plastic state. For it to be a rock, obviously, there has to be some solidification that takes place in the crust. That is why we have mentioned forms the Earth crust. This is the breakup that you should all remember. Now, having understood what a rock is, the important thing is, what are the types of rocks that we're going to study here? Let us see. You might have studied this particular chapter in your school days also. You all have studied for that matter. But with respect to civil services again, you know that very well that the civil services paper generally pick up these basic things only, but we're not able to recall them in the examination, and that is why we get them wrong. So never ever consider any chapter to be lesser important. You never know, possibly that very question changes your destiny. Possibly you are, let us say, failing the preliminary examination by, let us say, few marks, and possibly had you studied this particular chapter, you would have gained certain marks and possibly qualified. So that is why never take any chapter for granted, never take civil services examination on its preparation for granted. Please remember that. Now, having done the rocks, you should also be knowing the rock types that we're going to study. Now, when I say rock types, please remember, there are three broad categories under which we study them. First, please see here. First, I will put it as igneous rocks. Second, sedimentary rocks. Third, metamorphic rocks. Now, these are the three broad categorization. Whatever rocks that you basically observe or come across while you are in any part of the country, in any part of the country or for that world, the world, you will come across certain rocks which will more or less come under one of these three categories, right? That is why analysis of these things become important. Again, every single thing that has been put over here is handmade, handwritten, hand-drawn. So this is very easy for you to comprehend also and make these diagrams which I'm going to show you in your notebooks and your notes also. Let's begin. So let's begin with the igneous rocks. The moment I use the word igneous, the thing will come into your mind, what does this word igneous basically mean? So here is the answer. When I talk about igneous, it is derived from a Latin word which means ignis. Now, do not confuse this word igneous with a Maruti Suzuki car. Yes, now you realize that whenever you see the labeling of the cars also, they generally tend to use those Latinish words to make it more attractive. So now you know when you buy that small little car of Maruti Suzuki, ignis, the meaning is fire, right? So the meaning is fire. Igneous rock is derived from a Latin word ignis, which means fire. Why? Please remember these. These rocks which we're going to deal with, igneous rock, is an outcome of what? When the magma comes out in the form of lava, it solidifies. Whether it is inside or outside the crust, that is a different scenario we'll study, but associated with fire. That is why it is basically called as igneous rocks. Fire, not in the direct sense that there is fire, but because when you talk about magma or lava, the temperature is so high, that is why you see what? It is basically a representation of fire in an indirect manner, right? So, Igneous rocks are formed due to, now the thing comes that when there is magmatic outpour, please remember you should also understand the difference between magma and lava. Let's see this for a minute. Supposingly this is this earth crust, right? And there is, let us say, some magmatic output that is going to come. That means lava, let us say, from the mantle is coming, mantle portion. Now you see, this is also that liquid magma. Now, till the time it is built inside the surface of the earth, it is known as magma. Now, supposingly, either it comes out in the form of a volcanic eruption, or let us say it is simply coming out in a slow manner, let us say like it comes in the mid-oceanic ridges, not in a very violent manner. So then also, if you realize, let us take this coming out and pouring out over here. When it is outside the Earth's surface, this is known as lava. Now, this thing should also be very clear to you, right? Many times you will be confusing. Many books generally use magma, lava. So you do not need to be confused in that manner. They are taking interchangeably, but you should, because you're studying the subject of geography, so you should be clear also what is the difference between magma and lava. Now, please understand, these igneous rocks, when you realize, they might be forming inside the surface of the crust. There also it can form, or when it comes out, then also it can form. We will be studying that. Now, the thing is that when the magma is at a very, very high temperature, thousands of degrees of temperature, when they basically cool, again, there will be certain other processes that will be involved. Cooling, obviously solidification, crystallization, when we talk about, it will lead to the formation of rocks which are known as igneous rocks. So that is why, please remember, I have highlighted 3 points. These are very, very important from the perspective of the civil services examination. Igneous rocks are formed due to cooling. The magmatic substance, that is whether it is inside the surface or outside in the form of lava, whatever be the case, it's cooling, solidify, and the crystal formation, that is crystallization, takes place of the hot and molten materials known as magmas and lavas. That is what we said. So that means when it is whether magma that is inside or lava outside, it's cooling, solidification, and crystallization, that is crystals formation, take place. Then the rocks or the substances that are formed opposite that is known as the igneous rock. All rocks are formed directly or indirectly from the igneous rocks, thus they are known as a parent rock. Please remember, whether we talk about sedimentary rocks or metamorphic rocks, you will realize when we talk about sedimentary rocks, these are basically the deposition of the sediments that take place, and that is why we realize later on, due to compaction, we realize sedimentary rocks are formed. Or let us say due to various temperature or pressure forces basically lead to formation of metamorphic rocks also. But in either of all these cases which you see, from every aspect, it is first stage would have been that the magmatic substances coming out and solidifying and that rock being formed. Later on, whatever modifications take place or whether igneous rock further are eroded and later on form sedimentary rocks and all, that is a different phase. All the rocks in a way in the later stage we can say are basically coming from the igneous rocks only. So that is why all rocks are formed directly or indirectly from the igneous rocks. You will see this in the rock cycle also, will explain you. So thus they are known as a parent rock. That is the main source through which the rocks are going to be formed. Once we have completed all the 3 types, this concept will be very clear to you. Clear? Right. Okay. Now, there are certain characteristics. I've written a lot of characteristics over here. I have gone a little bit beyond the NCERT over here because there have been questions that have been asked in UPSC CAPF also from these particular points. Also, obviously, UPSC civil services examinations, even CDS, even NDA, they have been repeatedly asking these questions. And the question asked in any of these examinations equally become important for your civil services examination. First, these are roughly hard rocks. Yes, absolutely, because when they come out, they solidify, they cool, and they crystallize. So they are very, very hard rocks. Exceptions are there, we'll see that. They are granular or crystalline rocks. They do not have strata. unlike the sedimentary rocks, where you realize after one deposition of sedimentary layer, then is another deposition. So there are stratas there, are they present there? Layers are present. Over here, you do not see such layers because it is basically a solidification of what? Of the magmatic substances or the lava or lava related materials. That is why these do not have stratas like we see in the sedimentary rocks. So they do not have strata like the sedimentary rocks. Water is not able to easily percolate and thus less affected by the chemical erosion. Please understand that. Let me give you an example also. If you have seen Lord Ram's statue that was put at the Ram Mandir, you will see it was made up of black granitic substance. Did you realize why it is made up of black granitic substance? Because these igneous rocks are less affected by any chemical substances, or let us say anything that you put or apply on them. Now you know that very well, because in the temples, whenever a deity's statue is there, people would be putting, or the pandits jis or the priest would be putting a lot of, let us say, ghee, or let us say oil, a lot of substances on that. Possibly had that been some other rock, what would have happened? It would have eroded or disintegrated. That is why one of the reasons for using or creating the sculptures for the temple is from the granitic rock. Those are igneous rocks because they are less affected by the chemical erosions. Right? Next. Igneous rocks do not contain fossils. Now just imagine one thing. Had there been some fossil lying also, the amount, when the magma comes out, it is in thousands of degrees of temperatures. It would disintegrate everything that would possibly exist. So the igneous rocks cannot have fossils because the temperature is so high, nothing can basically be preserved or remain in these rocks. That is why they do not have any fossils. They are mostly associated with volcanic activities and thus called volcanic rocks. Obviously, you will see that volcanic eruptions, whether they are violent or whether they are quiet, these are associated with the volcanoes or volcanic activities. That is why igneous rocks are also known as the volcanic rocks. So these are the 6. Let us move ahead. Classification. Now please remember, every single word that is important here has been put in the yellow color. Now remember one thing, when you are revising, you should remember what are the effective ways of revising. People, what they do is, they try to rote learn everything. That is not possible and that should not be done. First of all, you should understand the things. When you want to revise also, for me, something that is, I do not have to read everything. They are roughly hard rocks. No. I simply need to hard rocks, granular crystalline, do not have strata, less of chemical erosion, do not contain fossils. That is it. Why do I need to read something that is written in white over here? Why? Because these are not the keywords. The keywords are basically that I've highlighted here in the yellow color. Similarly, when you create your notes also, you should highlight the keywords. Once you remember the keywords, that is what the examiner is basically checking. They are not checking your vocabulary over here, this, that, were and was. They're basically checking whether you have written these keywords or not. So that is why please make sure that you revise. When you revise, you should be marking or highlighting your keywords properly so that you will be able to recall. Clear? Let's move ahead. Having done the definition, having done the word from which it's derived, having done the characteristics, now let's come to the classification. Now please remember, the NCERT limits you to a great extent in this particular case. That is why I have basically expanded this. I had told you in the first lecture itself that NCERT, yes, gives you everything that is required, but they give you in very short or brief description. That thing needs to be expanded so that it meets the requirement for your preliminary as well as the mains examination, which I have done here. Now, if I want to classify, now please remember, certain rocks, igneous rocks, can be classified as acidic in nature, or let us say basic in nature. Now, silica oxide, greater the amount of silica oxide present in the rock, igneous rock, greater will be their acidic nature. Lesser the percentage, lesser will be the acidic nature. So based on that, if I classify, this is a classification that has been given here. You won't believe that this particular question has been asked in the past 10 years, twice or thrice in the UPSC CAPF examination. It has also been asked in the CDS examination. It had been asked in the civil services examination also, and now they can ask you as one of the statements when they're asking a question on the rocks. So you should be very well aware of these things. So when I say type, acidic type of igneous rock, it means that the percentage of silica dioxide is going to be greater than 66%. Example, granite, pegmatite. Now these are examples. Intermediate, If the percentage is from 52 to 66%, the example is diorite and andesite. Basic or mafic, please remember mafic itself means basic, right? Basic or mafic, that means lesser percentage of silica dioxide. So what do you see? 44% to 52%, that means basalt and gabbro. Basalt, you should remember, that is present in the Deccan Plateau region also. Ultra mafic, that is less than 44%, in that case pediorite and dunite. So this is basically the classification based on the SiO2, silica dioxide. So that means, in a way, some people mention silica only simply. Please remember, some books might simply mention silica. Based on silica, we are basically categorizing. That is also not wrong, but we have very specifically mentioned this. So this is also completely correct. Please remember that these standard classification, please remember, many might be thinking that their books are mentioning something else or some other things. These have been taken from the standard books because, please remember, there are a lot of old NCERTs also that have been referred, and other very standard books have also been referred along with your NCERT. So please follow this very carefully and with proper focus, and please note it down while you are listening to the lecture, right? So you have done with the classification based on silica dioxide. Now let's move ahead. Based on the texture, sometimes you will see the grains. See, let us say a rock is made up of grains which are very fine or which are very coarse in nature. Now that means that is basically referring to the texture. Now based on the texture, we are basically over here giving you the examples over here, right? Now see here. Based on texture, pegmatitic. Pegmatitic means extremely coarse grained. Example is pegmatite. Pheneritic, that means coarse grained, lesser than the pegmatic. Granite and gabbro. Porphyritic, that means mix. That means mixture of some fine grains as well as coarse grains. Over here, porphyritic basalt and porphyritic granite. Granular, that means medium grained is the texture. Cinerite and granulite. You might remember one of them because, please remember, many will say, sir, how should we remember? This question has again been asked in the civil services examination, various examinations in fact, in CAPF also, NDA, CDS also, and in civil services also as one of the statements. Aphanetic, fine grain, that means a grain to which the rock is basically made. Those are very fine in nature. Basalt and andesite. Felsitic, very fine. This example is felsite. Glassy, finest, obsidian. So this is again a classification. You can be asked that, let us say one of the statements in the civil services, that obsidian basically refers to the finest among the igneous rocks based on texture. Now you will say obsidian, what it is igneous rock or what? Many will be getting confused on that also. So you might it wrong. You know that I mentioned here obsidian. Glassy, it is the finest based on the texture. So this is, again, you should be very, very well aware. If you have done this, it will be no problem for you. But if you avoid this, again, there will be a lot of issues. So please make sure that you do this properly and in a very systematic manner. Okay, let's move ahead. Third is the mode of origin. Now, please remember, mode of origin, there are two categorizations. One is the intrusive landforms, other are the extrusive landforms. Please remember, though the topic of various types of volcanoes can also come under this category when we talk about the extrusive landforms, but we will not be covering here because we will be covering the topic of landforms. That is after geomorphic, next chapter is geomorphic, and then we have the landforms we will be covering there. So I will be mentioning here, but please remember, that is why I'm telling you, go in a very sequential manner as I'm teaching you. Only then you will be able to understand a lot of concepts. If you miss any lecture in between, you will have certain problems in understanding. So mode of origin is intrusive and extrusive. Now let us say, what do you mean by intrusive or intrusive igneous rocks or landforms? Now see here, we know that very well. When the rising magmas during the volcanic activity does not reach the Earth's surface, rather they are cooled and solidified below the surface of the Earth, the resultant igneous rocks are intrusive igneous rocks. Now you'll say, so what do you mean does not reach the surface? And let us take the example, go back again to this particular topic which we had done. Here, come here. Let us assume this is the surface. What did I mention over here? This is the surface, right? Now suppose you will be realizing that you see that this magma basically coming out. Now the lava is there. It might come out in a very, let us say, explosion manner. That is why you might have a lot of different categorization of material that are coming out, or they might be coming in a quiet manner, right? Now this is a surface. Leave that. Within, under the surface, you can realize that there can be a lot of igneous rock depositions that can take place. Now let us say over here, let us say this, there's a crack over here within the crust, and this magma has gone inside this, right? There can be a possibility of, let us say, some body, there was a crack here, the magma basically went and deposited and cooled here. There might be a possibility that, let us say, a saucer-shaped substances, let us say, bodies from. Now the cooling has taken place. It has cooled and deposited in that manner. Now, do you realize in all these cases which I'm talking about, let us say magma pours out and it is solidifying over here because there were certain cracks that were present. Now, all these bodies or igneous deposition that are taking place within the surface of the earth, not outside. That is what is known as intrusive. Inside. Now, within the intrusive also, you will be seeing that some can be inside but close to the surface. Some can be very deep. There is also further classification which we are going to do. Within the intrusive also, there can be categorization where the deposition, though taking place within the surface, is close to the surface. Other can be very deep. But overall, when I talk about intrusive, it basically means that depositions of those magmatic substances and their solidification is basically taking place within the surface of the earth, or inside. Let us say inside the surface of the earth. Now see, let us come to this particular point. That is what he's saying. Intrusive rock basically means that the rising magma does not reach the earth's surface. It is not reaching the earth's surface. Rather, it is cooling and solidifying, and obviously crystallization, which I've told you, solidifying, crystallizing below the surface of the earth, and the resultant igneous rock is the intrusive igneous rocks, which we have just now explained you. I'll be giving you even a finer, further, better diagram also. Don't worry about that. This is again a handmade diagram. Coming back, these intrusive igneous rocks are further divided into two categories. First, plutonic. Now, plutonic basically refers to formed due to the cooling of the magma very deep inside the earth. Now, let us see, come back to this particular diagram. If there is a, let us say, solidification taking place very deep, that means the gap between the surface and where this particular body is very, very high. This will be known as plutonic. This will be known as plutonic. On the other hand, hyperbasal, this means formed due to the cooling and solidifying just beneath the earth's surface. That means that the deposition or solidification, better would be solidification, crystallization, cooling that is taking place again beneath the earth's surface, but not very deep. That is hyperbasal. If it is taking, the depth is very high, that means that is plutonic within the intrusive. So these are two categorization under the intrusive. Now let us see a combined diagram over here, and you will understand the aspects. See here. See, this is the surface. Now please understand. Let me mark it so that you do not get confused over here. Let's see. Please remember, this boundary which I have made over here, this is what is a surface. Please understand this very, 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 very well. This is basically, this part is the surface, and below this is the internal part, something taking place inside the crust, right? So this is what? The surface. Leaving everything part over here, leave that. That is a concern that we'll do afterwards. Now let us see over here. There are a lot of labelings that I've done here, right? Explanation of every labeling is also done here. One by one, let us see each one of them. There's a word batholith that I've mentioned here, right? Now see, a large body of magmatic material that cools in deeper depth, and they are granitic bodies. Come here. This complete part, see here, this complete part Let us say there's a solidification that has taken place. Now, this is a complete part that is known as a batholith. Deep inside, this from, if you go down, it is very deep in nature, right? So, can I put it in the category of plutonic? Yes, I can. So, these are the batholiths that are deep inside. These are very large bodies. These are granitic in nature. That is what has been mentioned here. A large magmatic material that cools in deeper depth, and these are granitic bodies. First, done. Next point. Laccolith. Please remember, I've covered all of these, whatever is mentioned in your NCERT, even beyond that. So please note this very carefully, because this is one topic where repeatedly people get confused between topics like what is laccolith, what is lapolith. They have been asked repeatedly in the civil services and other examinations, particularly the PCS. Whatever I'm doing here, PCS, so they will not even twist the question. Also, they'll straight away ask you what I'm teaching here. In UPSC, obviously, all of these things are used, but along with it, your analytical skills also become important, how you analyze, because multiple statements are there. Now, laccoliths over here, please see, laccoliths. Now, these are large dome-shaped intrusive bodies with a level base and are connected by a pipe like a conduit from below. See here. Can you see this particular body? See here, this is, let us say, earlier on, let us say when this magmatic substances were coming up, this is a pipe through which it was connected, and this is particular body that is formed here, that is laccolith, right? Now see here, it is a large dome. The important thing over here is the dome shaped. If you miss this, that will be a problematic thing. See, the largest body over here which you can find is batholith. Nothing over here can you see can be as large as batholith. So if you are asked also, the largest intrusive body in a way over here is batholith. After batholith, obviously the shapes can be small or large, but among them also, if you see, laccoliths are generally large in size. Obviously nothing in comparison to the batholith. So these are dome shaped, right? This is a dome. When you see something, when you go to some places where domes, monuments, when you visit there, these are the domes that are present here. So this is a dome shaped. This is the most important characteristic. Clear? Right? Okay. So laccoliths are dome shaped and they're connected by a pipe, which you have seen here. Now comes another thing that students get confused. Lopolith. These are saucer shaped. Now please tell me, if you see a saucer, obviously it is going to be an inverse of a dome. Let us say if you're having food or a khichdi, can I represent it in this way? This is a, let us say, a saucer where food will be poured. So can I say it is the inverse of dome? Yes, it is. So it is a saucer shaped. Now concave igneous body. Now most important word is saucer. Now see here. Can you see this is a saucer shaped body here? This is lopolith. So laccolith and lopolith are very confusing in nature, but how you're going to remember it, please remember. Can you remember the fact that lopolith has a P for plate? Remember that? Lopolith has a P means plate means saucer. For in case something that is remaining, that is locolith, that means you can put it as a dome shaped. P for plate means saucer, and saucer, this is a shape. So this is the way you can basically remember it. This is how I remembered it. This is how you can remember it. Clear? Okay. Next comes sill or sheet. Now see here, these are near horizontal bodies. Again, the important word is horizontal bodies. Now see, what happens is, when the magmatic substances are coming out, there might be a lot of cracks that are going to be present in the crust. So magmatic substances might basically go inside and they might be in a horizontal shape, because when they move inside, after some time, they're going to cool down, solidify and crystallize. So over here, there are two words that are used, sill and sheet. Now in the examination, you can be asked what is the difference. There's a very minor difference, because in the preliminary examination, they can particularly ask you. Firstly, let us see the diagram and then I'll tell you. Can you see that this is, let us say, a magmatic substance that is coming out, but over here, this particular substance, when, let us say, there was a crack here. Just a minute. There was a crack here, and that is why, let us say, magmatic substances entered there and over here, and later they solidified. Can I say these are horizontal bodies? These horizontal bodies can be referred to as sills. Now the question comes, sir, why have you mentioned sill or sheet? See, both of them are exactly same. There is one difference. Thinner ones are called sheets, thicker ones are called sills. If these bodies that are present are very thick in nature, you will call them as sills. If they are very thinner, then you will call them as sheets, right? How will you remember that? Again, a mnemonic, not a mnemonic, but a trivia. Do you realize you have a paper where you have a lot of sheets? Let us say if you have a file, you have a sheet. Now, sheet is generally very thin in nature. So when I call the word sheet, it means thin. Clear? Now, this is how you will remember it. Clear? Now, next, dikes. When lava makes its way through the cracks, a wall-like formation solidify, and these are known as dikes. These are mostly perpendicular to the beds of the sedimentary rocks. Let us see here, very important. Now, if you realize when those magmatic substances are coming out, when you see sills and sheets in a horizontal manner, you will see dikes almost in a perpendicular manner. It does not mean that they're completely at 90 degree. They can be at 80 degree, 70 degree also, that doesn't matter. But they're somewhat perpendicular. So when you see these shapes that have solidified almost like a perpendicular body to the base, then you will basically call them as dikes. Sometimes what happens, let us say this body, this is also a very large dike where a lot of erosion took place. So you see volcanic aspects that are now visible over here. So this was previously a huge dike that was present, right? Okay, leaving that apart, let's come back. Facoliths. Now these are facoliths, please understand. There is a concept that is associated, very important here, we'll see them. They are formed due to the injection of magma along anticlines and synclines. Please remember, whenever you, in the next chapter, in the geomorphic processes, I'll be talking about folds and faults, right? Folded mountains you have heard. Why? Because there's some form of folding that has taken place because of the compressional forces, right? Now, supposingly, let us assume this particular thing that I've drawn, these are supposingly normal sedimentary rocks, but let us say forces have been applied from either sides. So this has basically resulted in the creation of these, let us say, folded like structure, a fold like structure within the surface, beneath the surface. Now, something that is basically pointing upwards, these are known as anticlines. Something that has bended down are known as synclines. Something very simple. We'll be going into detail in the next topic. When these bendings take place due to the compressional forces, the part that has basically buckled up. I'm not using these words. Why? Because we have not done this topic. But simple word, buckling up or something that has moved up. This part is known as syncline. One that has gone down is known as, this is known as anti-syncline. This is known as syncline. Now, when the deposition of the magmatic substances take place on the, let us say, anticlines and synclines, then these are known as facoliths. Now here, do you realize this is what? Facolith. This is what? Facolith. This is what? Facolith. Clear? Please remember this. So when the deposition is formed or injected in the anticlines and synclines, it is known as facoliths. Clear? So these are basically, again, what do we see as intrusive igneous rocks? We have done plutonic and hyperbasal also. Now coming to the extrusive igneous forms. We'll be going to a lot of detail in the next two chapters because they will be studying volcanoes also. So what are these? These are igneous rocks which are cooled and solidified outside the Earth's surface. So that means are at the Earth's surface. These are extrusive igneous rocks. Now what happens is, please understand, these can be of two categorizations. One is explosive, one is quiet. Explosive are generally, let us say, when volcanic eruptions take place in a very explosive manner. So a lot of substances come out. Now these can be, let us say, bombs. Please do not confuse them with actual bombs. These are bombs because these are big fragments of rocks that come out. It can be lapilli because these are pea-size fragments. Then it can be breccia. Breccia, it means basically combination of large and small pieces of igneous rocks that come out. Then quiet type can be lava plateau. If you see the Deccan Plateau, you will be seeing that there is no massive volcanic eruptions of that extent taking place. It basically came out and basically spread. So those are basaltic plateaus. Now these are quiet types. We'll be going to detail when we'll be doing the volcanoes. But this is, again, the landforms that are formed are known as igneous landforms. Now just a representation. If you see, this is what? a lava plateau. Do you see the volcano? This is again a landform that is created. This is what, again, though this is a dike, due to erosion it is visible. So we will be categorizing these things when we will be doing the chapter of volcanoes. So these are the extrusive landforms. So we have done with the igneous rocks. Let us move on to the next, that is basically the sedimentary rocks. Let's see. The moment I talk about sedimentary rocks, the basic thing that will come to in your minds will be sediment, right? But the thing, please remember, when I talk about sedimentary, it is derived from a Latin word which means sedimentum. Sedimentum means settling down. Let me make it very clear. Whatever be the origination of these sediments, they can be due to the erosional activities taking place with respect to the igneous rocks or other sedimentary rocks, or for that matter, metamorphic rocks. So those due to various factors or forces of erosion, that can be due to running water, that can be due to winds, that can be due to avalanches, whatever be the case. Whatever be the case. What I'm trying to tell you is when the sediments basically due to the erosional activities come and they're deposited. So layer after layer, layer after layer, layer after layer, those stratas are created, and in a way they are basically settling down. And obviously there will be a lot of compressional forces and pressure that will be exerted. So what is being said over here? Settling down. Second thing, I said layer after layer, that means there are what? Stratas or layers of sediments that are present. Next important thing is, as sediments are being deposited, there is quite a possibility, let us say, there was certain civilization or certain animals, let us say, leave civilization, certain animals were living. But there were certain erosional activities that took place and a lot of sediments were deposited. So you can see that over here, fossils can be found here, right? That is why, remember, sedimentary rocks have fossils. Not every, but most of them, if you can say, there's a great possibility of having fossils here. That is why if you see sedimentary basins, when we talk about, we are generally associated with regions where you can find oil also, natural gases also, a lot of substances, right? Why? Because let us say thousands and thousands of millions of years, let us say a lot of organic matter was deposited that was later due to pressure and all converted into those oil substances which are being used in today's time. So sedimentary rocks are those rocks which are an outcome of the deposition of the different layers or strata of different types of sediments. Because see, erosion activities are happening at a continuous pace of what? The various other rocks that are present where the erosion is taking place. Now, where the erosion is taking place, that rock might be igneous, that might be sedimentary, that might be metamorphic. The sediments are coming that are being deposited. That is why you realize these sediments are made up of so many minerals. So many minerals are present, right? So these are sedimentary rocks. Now let us see the characteristics. Now see, sedimentary rocks are formed of sediments derived from older rocks, plants, animal remains. So again, formed of sediments is a key word here. They have fossil remains. It does not mean that if there is a sedimentary rock, there has to be a fossil. It does not mean that. That means the sedimentary rock can have fossils, unlike the igneous rocks, where the fossils are not present. Why? Because it is an outcome of the magma that has come out. Even if certain fossil remains were present outside on the surface also, because of the magmatic, the temperature, everything will be destroyed. Nothing will remain. Nothing will remain. That is why we say that the igneous rocks are not associated with any fossil, but sedimentary rocks are associated with fossils. Sedimentary rocks are formed over the largest area of the globe. If you see the total area with respect to the coverage with which type of rock, sedimentary rocks occupy 75% of it. That is a maximum. Next, layers of sediments rock are seldom found in the original or horizontal manner. So that means where, please understand, the sediments which might be derived from substances of rocks that might be placed thousands of kilometers away. So that is why where you find the sedimentary rocks, the sediments which have been inside that rock are not necessarily from the same place. Supposingly, if you see that there are certain sediments being deposited, let us say thousands of kilometers away due to, let us say, running water. But the erosion where it is taking place might be thousands of kilometers away. So the deposition where the sedimentary rocks are forming does not mean that the sediments were found close by. So there are very less chance of that, right? And the deposition that takes place is not necessarily in a horizontal manner. It might be in inclined manners also. Later on, you realize there are a lot of folding and faulting activities that take place, which we will be seeing in the next chapter. Because of that also, you will realize that it is not necessary that they are present in a horizontal manner. They might be present, those stratas or layers might be present in various directions also. This way, this way, this way, a lot of ways. Most of the sedimentary rocks are permeable and porous because again they are made up of sediments which have been, let us say, packed together. So there are pores, so that means water and various chemicals can even percolate inside it. That is why erosional activities are relatively easier when you compare it with the igneous rocks. Next, connecting planes between the two consecutive beds of layer of sedimentary rock is known as a bedding plane. Now please remember this very, very carefully. Let us assume this. This is, let us say, a layer of sediments. This is what? A layer of sediments. Let us assume this. This was deposited due to the erosion that took place. Later on you realize then there were different types of further sediments because of the different nature of the rocks or the sediments that were created from the source or present at the source. That is why new or different type of, let us say, material or minerals that are present are now being deposited. Now let us see. You can take it from example. Let us say when the erosion was taking place earlier on, this was a substance that was being eroded by a river. So the sediments that came here were deposited. Now let us say below that was different kind of rock. Let us say igneous rock. So by the time this upper part is eroded, then what will happen? The river will start eroding this particular rock. So the substances or the minerals that will be coming from this particular rock, so this will be deposited over this. So in a way, let us assume these are in simple way two layers of sediments or this is what strata, two layers, strata or layers. Now do you realize these are two different types due to the substances might be different, the mineral composition might be completely different. It is quite possible. There can another scenario be there. Let us assume there is stratification which is of the similar substance. Now over here you realize these are almost same. So there is no variation that is present in a way. But over here between both of them you realize there is a lot of variation that is present because the nature of the minerals being different. Now what can I say over here? The connecting plane between the two consecutive beds or layers is known as a bedding plane. Can I say this is a bedding plane between two layers? Right? Can these two layers, can I call this as a bedding plane? Yes, I can. Though they are a similar type, but this can be a bedding plane. So what is bedding plane? The connecting plane. This is a connecting plane between two consecutive beds or layer of sedimentary rocks. This is known as a bedding plane. First. Second, uniformity of two beds along a bedding plane is known as a conformity. Do you realize there is uniformity across this bedding plane? Both of them are of a similar sediment, similar type. So there is a uniformity that is existing. So can I say these, because there is uniformity between these two bedding plane, can I call this as conformity? See, uniformity of the two beds along the bedding plane is known as a conformity. It can be because of various arrangement, minerals, whatever be the case. Over here, let us say the similar type of material or minerals are present. That is why you can say there is conformity or uniformity. Now, when you compare it with these two, do you realize that these two are different because the mineral composition is completely different? There can be various other reasons also, but it can also be one of the reasons. So can I call there is lack of conformity, or can I say unconformity? Yes, we will be doing these things in detail also when we will be doing the topic of folds and faults. So this is what is being mentioned: conformity, unconformity, bedding plane. These are the things that you should be aware of, right? Okay, let's move ahead. Classification. Now, there are a lot of classifications which I have mentioned over here. I have mentioned even the process also in detail. See, over here, you do not have to go into a lot of detail over here. The questions are generally asked that whether these are mechanically formed, these are chemically formed, or whether it is organically formed. These can be the questions, and these have been asked in the civil services also. So you should know under which category these things basically come. Classification of sedimentary rocks based on the nature of sediments. Now, these nature of sediments means that they are formed because of the mechanically formed. That means there is mechanical erosion, physical erosion that is taking place. Sandstone, conglomerates, clay rock, shales, and loess. Loess again are because of the fine sediments that are formed due to what? The wind erosion. We'll be doing in the next chapter regarding all these things. So mechanically formed or clastic rocks due to mechanical forces. That means sandstone, conglomerates, clay, rock, shales and loess come under the mechanically formed. Chemically formed, that means certain sedimentary rocks where chemical reactions basically are involved. So that is where gypsum and salt rock become important as an example. Organically formed, over here limestone, dolomite, coal and peat becomes important. So you should be please noting in them as examples of these further categories. When we come to the next classification on the basis of the transporting agents, that means what has been the transporting agent. So based on that, I am classifying. Let us assume aqueous rock or argillaceous. That means these aqueous means something related to water, right? So marine rocks, lacustrine rock and riverine rocks. That means marine rocks that are found close to the oceans and seas, lacustrine rock around lakes, and the other being riverine rocks means around the river regions. Aeolian, basically due to the wind erosion. So over here loess is example. Glacial sedimentary, trills and moraines, which we'll be doing in the next chapter with respect to deposition also, where these are basically associated with the depositions associated with glaciers. So these are tills and morainic deposits. Tills, you will remember that we had already done when we were doing the continental drift theory. We briefly mentioned about it. So these are the two classifications. Let's move ahead. Now this particular 4 terms that I have used are very important with respect to the sedimentary rock formation. These have not been used in a detailed manner in your NCERT, but these are the standard format which you should know. These words which I have used are very, very important, so please note them down, because again in the NCERT there has been a brief explanation of some of the words. They have not explained in proper detail what is diagenesis, they have not explained what is lithification. So over here you should be knowing them very well. First, please remember, whenever a sedimentary rock formation is visible, it has undergone a lot of processes, right? It has undergone a lot of processes. First being weathering, second being sedimentation, third being diagenesis, and fourth being lithification. We'll be covering what all these things basically are. Weathering topic, please remember, we will be going in the next chapter. In fact, in a lot of details. Over here, it is not required because we are doing the topic of rocks. Weathering basically means, what does it mean? Basically, it means a breakdown of the rocks or at or near the Earth's surface into smaller particles. That is what weathering is. It means breaking down into further substance or simpler substances due to physical, chemical and biological processes or weathering that is taking place. So these weathering can be physical, biological or chemical, and it produces what? Sediments. So because when whatever rocks are present, due to the erosional activities or weathering activities due to the physical forces, chemical forces or biological forces, what does it lead to? It leads to formation of finer particles, that means sediments. So weathering is this first process for the formation of finally the sedimentary rocks. We have done weathering in brief. Now comes sedimentation. Now please remember, when I talk about sedimentation, the processes where the weathered material are transported and deposited, please remember, first step was production of sediments. Sedimentation involves transportation and deposition of those sediments. It leads to the formation of layers of sediments or stratas. Why? Because in the weathering processes, sediments are being produced, they are being transported and deposited layer after layer, layer after layer. So this is basically sedimentation. Sedimentation is the sediments that were created by the process of weathering are transported through, let us say, wind, river, whatever be the case, and deposited. Now the deposition leads to strata-like structure. Now this is not complete. See, a lot of processes. This is basically leads to the formation of layers. That is it. This is sedimentation. Next come diagenesis. Now when the deposition is taking place layer by layer, there will be a lot of processes that these layers will undergo. In this stage, sediments undergo physical and chemical changes. Physical and chemical changes that they undergo. This is very important. First, compaction. To compact, so what does it mean? The weight of overlying layers squeezes the sediments. Let us assume that certain sediments are being deposited on this layer. As more and more layers will be deposited, they will exert a pressure and will lead to compression of the layer that are below. So that means compaction process will be there. The weight of the overlying layers squeeze the layers that are below them, right? Second is cementation begins. Please remember, this is very, very important. The process of cementation, which I'm going to explain you, is beginning here. It is not completing here. Please remember that. It will complete in the lithification stage. compaction process is going on, it will continue. Cementation begins here. So what is cementation? Mineral like calcite, silica, iron oxide precipitate and bind the grain. So these substances basically act as binding agents which basically bind each other and the other minerals that are present within the stratas. So cement, like the work, what is the work of a cement? When you mix it with, let us say, sand and all in the normal process of construction, it is acting like a binding agent. Similarly, calcite, silica, iron oxide basically act like a binding agents which bind the other minerals that are associated or present in the layer. This process begins here. Recrystallization. Minerals reorganize into stabler form. So that means they further stabilize and crystallize also. A little bit of crystallization processes take place over here. Diagenesis occurs at shallow depth and relatively low temperature, less than 200 degrees Celsius. Now you'll say 200 degrees Celsius is very hot. No, when you compare it with the temperature of the complete earth or the core, it is very less, it is nothing. So this basically takes place at shallow depth. Obviously it is taking place within the earth and also in the upper part of, in the crust part, that also in the upper crust region. So that is why obviously it is going to be at a shallow depth and the temperature obviously is going to be relatively less. Yes, you will say then how come 200 degrees Celsius come? Please remember, due to the compaction forces, due to the squeezing forces also, it is quite possible that heat might be generated. It does not metamorphize, no, but yes, certain temperature is there. For metamorphization to take place, temperature is relatively very higher. So this is diagenesis, which compaction, cementation and recrystallization process take place. Now last is lithification. The formula for lithification is, please, compaction which started here is continuing. This also continues here, further compaction, but cementation over here again completes its process. So compaction plus cementation in a complete process is known as lithification. Lithification is a final stage where loose sediments become solid sedimentary rocks. So that means the cementation process also completes and the compaction process also complete. So this is known as lithification. Various books do not mention, let us say, lithification separately, or they do not mention diagenesis separately. They can take it as one word and mention it, but there are minute differences which I have already told you. Diagenesis, over there compaction process is taking place, it is also completed over here, but cementation begins in diagenesis but it completes completely in lithification. So that is why this is a stage where the solid sedimentary rock is created. This is the whole process of the sedimentary rock formation, not mentioned in the NCERT clearly. I mentioned it very well, so please note it down properly. Last rocks are the category of metamorphic rocks. Now metamorphic is derived from the word metamorphism, that means change in form. Now you realize very well, please understand, metamorphic rocks are basically those rocks which are formed because certain pressure or temperature, certain changes take place of a greater degree, where the previous rock might be an igneous rock, sedimentary rock, or even a metamorphic rock, because of which a temperature or pressure is exerted, it might change its form, its nature. So that is why it is known as metamorphism. That is why change in form. So please remember, metamorphic rocks are those rocks which are formed under the action of pressure, massive pressure, we'll be seeing them, volume and temperature changes, due to which consolidated rocks undergo recrystallization. So whatever the crystallized structure were there, they were recrystallized because of the extreme temperature and pressure that is exerted, and reorganization of the material within the original rock. When there is reorganization, definitely newer types of rocks will be formed because there is again rearrangement, changes that are taking place due to all these factors. So there is going to be new rocks that will be created, which you will be seeing them. So these are what? Metamorphic rocks, change in form. Now let's see characteristics. Now please understand, metamorphic rocks start from the other rocks. Start from the other rock means the rock which is undergoing metamorphism might be igneous, sedimentary, or even metamorphic itself that has undergone changes because of the pressure or the temperature that is exerted. First point. Secondly, minerals inside metamorphic rock change during the metamorphic process. Yes, minerals will change because obviously you will see so much pressure and temperature is being exerted. Metamorphic rocks are generally more resistant to weathering because it has already undergone a lot of temperature and pressure. So these are basically, let us say, lesser prone to weathering, or let us say erosional activities also. The process of metamorphism, grains and minerals in some rocks are arranged in layers, and this arrangement is known as foliation or lineation. Please remember, When I talk about stratification or strata, that word is associated with sedimentary rocks. But when I talk about the fact that there is arrangement in the layers due to, let us say, the pressure being exerted or a temperature, which you will be seeing in the diagrams, because of that, if say there is certain layer-like formation, that is known as foliation or lineation, which is associated with metamorphic rocks. These words are not associated with sedimentary rocks per se, because we use the words over there stratification. So the process of metamorphism, the grains and minerals in some rocks can get arranged in layers or lines. These are known as foliation or lineation. That means arrangement in lines. Again, a very important feature, foliation, lineation of metamorphic rocks. This can be asked. Then minerals or materials of different groups are arranged into altering thin to thick layers. This is known as banding. Let us say there is an arrangement that takes place. Let us say due to the pressure, whatever be the forces, where the arrangement takes place where some dark bands are there, then certain light bands are there. So this structure will be known as banding. Banding, right? Because recrystallization is taking place, pressure is being exerted, temperature might be getting exerted. So mineral or materials of different groups or different nature are basically being arranged into thin and thick layers. This is known as banding. This is the diagram which you can basically make also. Okay, let's move ahead. Factors of metamorphism, please understand there can be a lot of factors due to which metamorphism or the process of metamorphism basically happen. First is heat. We'll be seeing basically the types under which you will understand it. But here, let us see the factors. Heat. Increased heat causes the minerals in the rocks to recrystallize and rearrange. This is a very important factor because of which metamorphism might take place. First, heat. Second, pressure. It causes the minerals to compact and align in specific orientation, changing it in its nature. Second point is pressure. Third, chemically activated fluid. Now let us say their presence can facilitate the exchange of elements between the minerals in a rock. Because if let us say chemically active substances are present, the minerals in various parts might be let us say getting dissolved or moving because of the chemically active fluid that is present, and they might be interacting with each other. So it can lead to growth of new minerals because of the chemically active fluid that is present. So the present can facilitate the exchange of the elements between the minerals that are present in a rock. So this is what is the role of chemically active fluid that can also cause, but these are, let us say, relatively less. Majorly heat and pressure are the ones which are majorly responsible. Last is time. Obviously, if let us say some heat is being exerted, greater is the time, greater will be the impact of the metamorphic processes that are taking place. Lesser is the time, lesser will be the chances of it being metamorphized. So that is why greater the time, greater the duration, greater will be the outcomes. That is why metamorphism is gradual process that takes place over millions of years. It is not something that takes place in 1 hour or 2 hours. It takes millions of years. So these 4 factors are the ones which are responsible for the metamorphism process to take place, right? Last over here, types of metamorphism. When I talk about types of metamorphism, first is contact metamorphism. Second is regional metamorphism. Now please see, when I talk about contact metamorphism, it is basically localized in nature, present in a small area, small region. When I talk about regional metamorphism, it basically refers to a very large region being impacted. Regional metamorphism further has 2 categorization. First is dynamic regional metamorphism and second is static regional metamorphism. Let us see each one of them in detail. When I talk about contact metamorphism, it is also known as thermal metamorphism because it is the impact of the high temperature which is causing the particular set of rocks to metamorphize, or let us say be transformed into metamorphic rocks. Let us assume that there are layer of sedimentary rocks, and let us say magma in a form of, let us say, dike basically comes out. Let us say this is the dike, and let us say magma basically came up from the mantle through certain cracks that were present in the sedimentary rocks. Now, because of this high temperature, these are basically what? Layers. Can you see this layer, this layer, this layer, this layer, this layer, this layer, this layer? All these layers were there. But because of certain crack being present, magma came out. What happened? All the adjoining regions over here, because of this extreme temperature, it transformed itself into metamorphic rocks. Again, this is a time-taking process. I'm explaining you in form that it took place in few hours. No, it took a lot of time. But this is how it has happened. Because of the high temperature, that is why it is known as thermal metamorphism. Now see, this metamorphism involves changes in the forms due to the high temperature of the intruding magmas. That is why if you see these rocks are what? Limestone I have represented here. Now, this limestone, this region is what? Limestone. This part over here, what does it mention? It represent marble. M-A-R-B-L-E. So that means limestone has been converted to marble over here because of what? The intruding magma, and that causing let us say a very high temperature to be present over here. So this sedimentary rocks, that is limestone, converted into marble. So that is why when extractions these take place, you realize that wherever marbles are found, you will realize certain temperature, or let us say some sort of high temperature in the previous, let us say thousands of millions of years would have taken place, that has converted limestone into basically marble. So this is one of the important reasons. There can be other means also, but this is the most important thing. So contact metamorphism is a thermal metamorphism, basically where the, let us say any type of a rock which is present, which is being transformed into metamorphic rock, changing in nature is taking place because of the high temperature. Over here we are seeing the intruding magma, which is causing, let us say the example over here is limestone, that is sedimentary rock, which is being transformed. This part is being transformed into what? Marble. That is what? Metamorphic in nature because of this intruding what? Magma, that is now being represented in the form of a dike. This is contact metamorphism. Now comes regional metamorphism. I had mentioned you regional metamorphism basically covers a larger area. When I talk about contact, it is limited to a very small area, localized area. So that is why please you can mention localized. Localized. Over here, the rocks were altered in their forms in an extensive area. That is why please remember the extensive area becomes very, very important. Large area. Over here, the role of pressure becomes important. There can be role of temperature. Yes, it is. We are not denying that. But the role of pressure is most important in the regional metamorphism. Regional metamorphism is a characteristic feature of the mountainous areas. Why? When you see, let us say, plate tectonic movements taking place and all, a lot of pressure is being exerted. Let us assume that there is a plate which is more denser, it is subducting beneath a lesser denser plate. So there will be a lot of pressure that will be exerted, right? So you will be realizing that pressure over here in regional metamorphism takes place as a dominating role. And that is why these formation of these structures where pressure is involved, you will say larger extensive areas are involved rather than simply the case of a contact metamorphism where the surrounding region is converted into another form because of the intruding magma or a higher temperature. So that is why regional metamorphism is a larger scale event. Now this can be of two types we had already studied in the diagram, dynamic or static. When I talk about a dynamic, please see I'm given an example also over here. Supposingly there are certain forces being exerted from the direction. Let us say mountain building process is going on. Well, let us say one plate is coming, another plate is joining. Let us say whatever be the case. Because of those, let us say this sedimentary rock basically buckles down, buckles in this manner. So what do you see? The rock are metamorphized due to the compressive forces. Compression is taking place. That is where this is transforming into this manner. And the resultant high pressure caused by the convergent horizontal movement. So that means there's a lot of pressure being exerted. So what is here? Can I say compressional forces? Here also compressional forces. Now this compressional force is exerting a lot of pressure on this particular part. Due to this extreme pressure, this is not normal pressure, this is extreme pressure. This extreme pressure basically transforms this particular part which I have marked in red into a metamorphic rock. Example, now you'll say, sir, okay, give us example of this. Yes, there are a lot of examples. See here. Granite because of this dynamic metamorphism can transform into mylonite. Shale due to metamorphism can convert to pyelonite. Basalt on metamorphism can convert to mylonitic basalt. These are three examples that I mentioned here because of the dynamic regional metamorphism. Second part, static regional metamorphism. Static over here is, let us say, certain depositions are taking place, and over there repeated deposition is taking place. So a lot of layers are formed. Those above layers will exert so much pressure on the low layer that is beneath it that it can lead to metamorphism. Now please remember, As we said, you will say, sir, similar things are also happening in sedimentary rocks layer after layer. Please remember, yes, but remember this pressure should be exerted for possibly millions of years. Only then those sedimentary rocks might be converted into what? Metamorphic rocks. These all things, sedimentary, metamorphic and all, these are related to each other. We'll be seeing in the rock cycle. What we had done in the stratification with respect to the sedimentary rocks, similar thing is happening here. This is the same process. But the thing is what? The pressure being exerted is so high because of the larger number of layers. Second, the process should have taken place for a lot of millions of years, and then possibly the lowest or the lower layer would have been converted into a metamorphic rock. Static means the rock are metamorphized at a greater depth due to the intense pressure and weight of the overlying rock. So these are what? Overlying rocks or layers, pressure being exerted and this layer being converted into a metamorphic rock. You'll say, what are the examples possibly of this? Yes, there are a lot of examples here, right? Over here also, if you see example, now please see, there is quite a possibility, let us say a granitic substance is present. When you see over here, similarly over here also, please remember, if let us say a granitic layer is here, it can also, due to lot of pressure being exerted, can convert into malonite. It can convert. So please remember this. Again, it becomes very important that due to extreme pressure, now this pressure, please remember, is not less. Over here, as you saw, the pressure is very high. Similarly, over here also, the pressure is extremely high. So granitic to malonitic conversion can also take place. So in this particular case also. Let's see the rock cycle. Rock cycle basically tells you the process in which one rock form is converting or type is converting into another. Now, if you see, let us assume the surface of the earth, let us say complete earth, in everywhere volcanic eruptions take place. Obviously, what will happen? There you will see whatever the sedimentary rocks are present, that will also be covered with magmatic rocks mixture. They will be mixed within the magma and all these things will take place. So it is quite possible that the conversions between the various rock forms will take place. Now, let us say igneous rock is depositing. Igneous rocks might be, let us say, eroded by the forces of weathering and erosion, and they will, let us say, eroded and they will form into sediments and form sedimentary rocks. Now, sedimentary rocks can later on, what will happen? Convert into metamorphic rocks due to pressure and the heat. Similarly, igneous rocks that are present, when we saw the example of granite, they can also, because of the pressure, be converted into metamorphic rocks. So you can say in a way that various rocks or types which are present here can convert to each other through various processes. So here, the rock cycle is a continuous process through which the old rocks are transformed into the new ones. It is a dynamic system where the rocks constantly change, shifting their types between a sedimentary, igneous, and metamorphic. Let us see through a diagram over here. Let us see, this is igneous rock, this is sedimentary, this is sediment, this is sedimentary rock, this is metamorphic rock, this is magma. Now, if you see, let us say there is magmatic eruption taking place and magma is coming out. Now, magma on cooling will form igneous rocks. Clear? This igneous rock, if melts, will again form magma. Clear? Now, let us see. These igneous rocks, if undergo weathering and lithification, will form again sediments, and later on this on compaction, cementation will form sedimentary rocks. That means igneous rocks through weathering, lithification, and that lithification will involve obviously compaction, cementation will form what? Sedimentary rocks. Now see, these sedimentary rocks, because of heat and pressure, can form metamorphic rocks. Now these metamorphic rocks can be formed from the igneous rocks also because of heat and pressure. Now these metamorphic rocks can further, because of weathering and lithification, form sediments, and these can again form sedimentary rocks. Similarly, sedimentary rocks can further themselves undergo weathering and lithification and form sediments. So are you seeing this whole cycle is related to each other? Sedimentary rock, metamorphic rock, igneous rock, melting of any of them will lead to formation of again magmatic substances and their mixture. So all these things are representing the rock cycle and how basically one form is converting into another based on the conditions that are present there. Clear? So this was basically the topic from the chapter of rocks. very important chapter. We'll be coming with the next chapter, that is Geomorphic Processes, and then after that we'll be coming with the topic of landforms. Again, the two very important topics for this particular week, and by that time you will be completing with your geomorphological part of the UPSC syllabus. As we had promised you, what PW stands for, what Alak sir's vision stand for, he had guaranteed all of you that along with the various batches that are going on, you will be taught free of cost on the YouTube channel, and that is what we are doing right now. Why are we putting so much effort? This is a cause for which we are doing this. This is a mission of Physics Fella where along with the batches, we had guaranteed you, Alak sir had guaranteed you that you will be taught free of cost also on the YouTube channels. And that is why we are doing. If somebody who is serious enough to listen to these lectures, who's serious enough to basically note them, revise them, I'm telling you, you will be able to do very good in your examinations, prelims and mains, provided you are there to study. This is what Alak sir's vision has been. This is what we are carrying for that vision in every lecture that we teach. Not only me, also the other teachers and faculties. So make the best use of these lectures. We are there for you to answer your queries. In my every lecture, whatever queries you basically put in the comment section, whatever things you like, whether you like the lecture, you want something new, whatever comment that you mention in the comment section, I answer each and every comment. You would have seen in the previous lectures also. So please, we are there to talk to you in this particular manner, answer your queries also. If you like the lecture, tell us. Obviously, we are always there to help you in every manner. Make sure that you study really hard. Make sure that you use these lectures very properly. And these lectures can be itself the cause for you being successful and being a civil servant. So please make the best use of it. Another lecture from the NCERT series of physical geography. Today is the lecture number 5, that is Geomorphic Processes. Please understand this is a very critical and an important topic for your preliminary as well as your mains examinations. Whatever you have done or learned till now, like topics like continental drift, plate tectonics and its types and everything related to that will be utilized over here, because this is a very critical topic with respect to the applications of the topic that you have done previously. So I would request you to please go through the previous videos in order to better understand this topic. Now, please have your A4 sheets along with you. While I'm teaching you, please note down whatever is being taught here. I have used extensively a lot of flowcharts, handmade diagrams, and a lot of figures that will be very useful for your understanding. Now, while I'm explaining to you, please focus, note down, pause the video wherever it is required. If required, you can again replay the video to understand it better. Sometimes you might miss certain things that leads to misunderstanding of certain topics. So you can go through the video and again if you do not understand. Otherwise, most of the topics will be clear while you are going through this video. Now let's begin with the lecture number 5, that is Geomorphic Processes. Now, when I talk about geomorphic processes, this is something very commonly used and a chapter in your NCERT. Now the question arises, what is this basic term? So please understand this thing. This question has been asked multiple times in various civil services examination, whether it is by UPSC or by the state services, in the preliminary examinations also and in the mains examination. Its application also becomes really very important here. Now see, when I say geomorphic processes, we will be understanding this and then we will be classifying also. So please, while I'm explaining you, be on your toes and keep on noting it down also and understanding it. These are natural physical processes that create, very important thing, that create, modify and destroy landforms on the Earth's surface through the action of weathering, erosion, transportation and deposition. There are so many terms here. Every single term is important here and every single term is going to be taught to you. Please remember, the topic of transportation, topic of erosion, transportation and deposition will be done in the next chapter, that is erosion. We'll be having a brief understanding in this topic. Our focus majorly will be weathering and mass wasting here, right, as given in the NCERT also. So overall, but what you need to understand is, let us say there is a landform, any landform, any part on the surface of the, let us say the crust. You will be seeing that it is going to undergo various erosional processes. Right? Erosion by possibly river, erosion by glaciers, erosion by wind. Now, do you realize that these are processes that are eroding those landforms that are present on the surface of the earth, right?
Now, these processes are in a way destroying the landform. Yes, they are destroying. But there is another process or another processes that are going on, like volcanic eruptions. Now, these volcanic eruptions are creating new land masses also, landforms also. So, do you realize there is a competition going on between the processes that are creating the landforms and the ones that are destroying? And this is a balance that is maintained by the Earth. You have done in the plate tectonics also, when there are, let us say, divergence of the plates that are taking place, again, new, according to the phenomenon of seafloor spreading, new crusts are being formed. On the other hand, the other crust on the other side is basically subducting inside the mantle and getting destroyed. So over there also you see construction and destruction processes taking place. Similarly, if you see on the Earth also, there are a lot of processes which are destroying the landforms, and there are others that are creating the landforms. So these processes combined in a way come under the category of the geomorphic processes. That is why you see geomorphic processes are natural physical processes that create, let us say, all those phenomena and processes that are taking place that are creating a landform, or let us say modifying. Now you see there are processes which are eroding, that means they are modifying possibly the shape also, size also, and in a way in a later stage can destroy it also. So destroy the landforms also. And what are the processes that are going on associated with them? Weathering, erosion, transportation, deposition, and all these things are going on. So these are, or this word or this definition basically refers to the what? Geomorphic processes. Now, geomorphic process, if I want to understand better, we can classify two major terminologies under this. Two major terminologies. First, the geomorphic processes encompasses both the endogenic processes. What do you mean by endogenic? We'll be doing everything. Don't need to worry about that. Right now, just understand, I have all the charts in front of me. We'll be understanding all of these. Geomorphic process basically includes or encompasses two broad processes. First, the endogenic. What do you mean by endo? That is inside. So what does it mean? Operate inside the earth. Now, for example, the earthquake is taking place. You have already done earthquake in a lot of detail when we were doing the concept of P waves, S waves. I've explained you. Now, this is a phenomenon that is taking place inside the earth. Similarly, volcanic eruptions also, the magma is coming from inside the earth. So, you see there are several processes that operate inside the earth. Those are basically referred to as endogenic processes. On the other hand, there are other processes like erosion by, let us assume, erosion taking place by river water, erosion taking place by glaciers, erosion taking place by wind, and so on and so forth. Now, these are taking place on the surface of the earth. That is why these exogenic, exo means outside. So, exo means outside. Endo means inside. Operate on the surface of the earth. So endogenic and exogenic process. These processes, they maintain a balance, and these processes together combine to form a whole process that is a major process, that is geomorphic processes. Clear? Now, having understood a little bit about geomorphic processes, having understood what is a little bit endogenic and exogenic, now let us go a little bit into detail. Now, please understand, every time, or even I have also come across students who say, sir, when we talk about endogenic, is that the only word that is basically used for that? No. Now, please understand this very well. Various standard books, various thinkers have used different terminologies. Endogenic is one term. It can also be called by endogenetic. Some thinkers have used this also. It can also be known as hypogenic. So in the examination, possibly if they use some other word, you might get confused at possibly how this word has come. Many people think, no, it is not endogenic, it is endogenic. Please understand, these are standard terminologies. You might have read one or the other word, but these are ones which are present in various standard books, and the foreign authors have also mentioned. So I mention it here so that you should be aware of it, because UPSC might test you on them. If they mention hypogenic, possibly you will get confused. So endogenic, or hypogenic means one and the same thing over here, broadly, when you understand them. Similarly, exogenic, or epigenic over here will mean the same thing. We'll be considering this later on. Let's see the classification first of all here. Now, if you see endogenic, or hypogenic, we have classified them into two broad categories. First,
diastrophic, second, sudden. Let us see this chart and then we'll analyze it. Diastrophic and sudden. Under sudden, you have the volcanic eruptions and the earthquakes. So these are all taking place inside the earth, right? Not on the surface, inside. Some processes that are going on inside the earth. That is why we have said the processes that operate inside the earth, right? Under the diastrophic, you have two major phenomena of processes, epirogenetic. Under epirogenetic, you have emergence and submergence. Other is orogenetic, under which you have tensional forces and compressional forces. Now, you would be asking me, sir, you have given us so many terminologies. These terminologies themselves are so difficult to comprehend and understand. So, what are they? Absolutely, you don't need to worry about them. We are there to explain you these things. Important is you note this chart first of all, and then possibly you will be in a better condition to understand it also. Please note this down. Pause the video and note it down, right? Now, let us move further to understand each and every terminology that is present here. When I talk about sudden, first of all, if we are talking about the phenomena, endogenic, and hypogenic, it basically means processes taking place inside the earth. This is the first thing that you should be aware of. Now, when I talk about sudden, please understand one thing very clearly. The classification, this diastrophic and sudden, is based on the fact that sudden phenomena, that means those processes which take place at a very fast pace or a rapid pace or take place suddenly. Diastrophic forces are those forces or processes that are basically taking place inside, but they are basically very time consuming processes or take a lot of time. So, under sudden, you can say these processes or phenomena, these processes take place at a very rapid pace. You yourself know that the moment earthquake comes, you are not even able to detect it, let us say 1 hour prior to that the earthquake is going to happen. It's very difficult. So these are very sudden. Similar volcanic eruptions also, these are very sudden processes. These are very processes that happen very quickly. On the other hand, if you see other processes like, let us say, mountain building processes or rise of the continents because of the internal forces, these are time-taking processes. These will take a lot of time. So that is why sudden are these processes that take place at a very rapid pace. Under them, we have done earthquakes and the volcanic eruptions. Volcanic landforms will be done in the chapter of landforms. Otherwise, you have done the volcanic bodies also, right? What are present inside the earth crust. We have done lapolith, locolith, batholith, all those things have already been done. Types of volcanoes will be done in the landform chapter next. So we have already majorly done these. Earthquakes we have already done in a lot of detail when we were doing or studying the interior of the earth. Now, when I come to the diastrophic forces, diastrophic processes, please understand. First thing is important is these are time consuming processes. They take a relatively much longer time. So what is more important here? Time taking, take a lot of time. It is not like in few seconds you have new mountain building. It doesn't work like that because you have seen the plate tectonics movement also. When the plates are moving, they are moving at a very slow pace, very minimalistic pace, few millimeters in a year. Now in that processes, you cannot have a mountain building taking place in few seconds. It will take a lot of time. Similarly, continents emerging or submerging is also a time-taking process. That is why diastrophics are those processes which take a lot of time. Both vertical and horizontal movement are caused due to the forces deep within the earth. So it involves forces which might be horizontal, which might be vertical also. So we'll be seeing that. We'll be seeing the aspects associated with the faults, folds. I'll be considering those things also. Please note this very well. Your NCERT does not cover in detail about what are the folds, what are the types, what are the faults, what are the types. Those are not covered. And I'm covering those
concepts in this particular chapter itself. Why? Because UPSC can very well ask you this because it is an integral part of your chapter, but NCERT does not cover it. So all the diagrams, all the definitions are going to be mentioned here. I'm just going to show you an example here. These folds I've already drawn. These are not mentioned in your NCERTs. All the types of folds, all the types of faults, I've already done this. So you should take it as a resource where you can rely on. You can copy the content also while listening to the lecture, and with respect to fold and folds and other parts, it will be more than sufficient. Okay. So it involves basically both the vertical and the horizontal movement. More importantly, it is a relatively time-taking process, unlike the sudden. Now, under the diastrophic, you have two categorizations. First is eperogenetic and other is orogenetic. Now, eperogenetic has two processes, that is emergence or submergence. Let us see one by one. When I talk about eperogenetic movements of forces, please understand the word epero means continent. Genetic means origin. That means they are talking about the concept of the origin of continents. Now, the origin of continents through various processes which we study is a very long or a time-taking process. Now, there are two phenomena that can happen. Supposingly, there is emergence of land because of the internal forces. That is known as emergence or upward movement. So, emergence of large continental masses, that is the upward movement that takes place. We will be seeing these phenomena when we will be going further in the chapter, so don't need to worry them. Other is submergence. Submergence, that means the continental mass basically submerged. So, that means there is downward movement that is taking place. So, over here, whenever we talk about the eperogenetic movement of forces, we are talking about very huge land masses, continental size. That is why this is again a very time-taking process. Now, this is eperogenetic movement. If we move on to the other part, orogenetic movement. Now, please understand, the moment I talked about orogenetic, orogen basically means mountain, genetic means origin. Now, these processes, please understand, basically talk about mountain building processes. Now, you have already dealt with these chapter or little bit about these details when we were doing plate tectonics. You would have remembered that when we are talking about various types of mountains also, you had understood about the young fold mountains, fault mountains also. We have studied a lot about them. So, let's take an example here. Let's see, this is a Eurasian plate. This is the Indian plate. Now, this is one of the methodologies through which mountain building processes basically happen. I'm giving you this example because various processes through which mountain can be built, some of them have been studied in plate tectonics, other will be studied through the concept of folding and faulting, which you're going to do after this, right? Now, do you realize this is the Indian plate which is moving towards the Eurasian plate? You know that very well, right? So we had the Tethys Sea also. We'll be seeing that also, don't worry. Now, slowly what happens later on, this plate basically subducts. Subducts under the Eurasian plate. Obviously, you realize that there is going to be a lot of force that is exerted that will lead to this part rising. Why? Because force is being exerted here. Now, the question will come, sir, has volcanic eruptions or evidences of volcanic eruption present here? You will see minimalistic. There's a reason behind it, because sometimes when the crust is very deep, in that case, you do not very frequently see volcanic eruptions when there is subduction taking place. Please understand this very well.
That is why you do not see as such volcanic eruptions over here, because the crustal part over here itself is very deep, right? So what has happened is, because of the compressional forces that is being exerted, it leads to this folds or bending of this particular plate. Now you see, this phenomena that has taken place does not or has not taken place in few minutes or few seconds. It has taken millions of years. There have been a lot of stages. That is why you see the Great Himalayas, the Middle Himalayas, and the Shivaliks. So these origination of these have been basically taking place because of the various subductional phases that has taken place. That is why this is a way which you see a possible phenomena through which mountains can originate. Yes or no, right? So again, similarly, there are a lot of mountains that basically originate because of the faults also, right? Now the important question will come, sir, what are faults? Now, please, that is why I'm telling you, you will have to wait for another 15-20 minutes. When we go to the topic of fold and faults, then you will be better able to understand what is the concept of mountain building also. Because if I explain you through the fault mechanism, you should know what is fault, which we will be doing in the coming few minutes. So when we will be doing faults, I will tell you, see, this is an example which you can see in various mountains like Vindhyan range and all, how they are formed. What is the example? So we'll be doing that. You need to wait for a few minutes, right? So what I'm trying to say is, various phenomena, either through faulting, either through folding, a lot of mechanisms through which mountains are being originated. These are not processes that are taking place or happening in few seconds or minutes. This is taking a lot of time. That is why when we are talking about orogenetic, you see these are time-taking processes. Now the question comes, you have written, sir, tensional forces and compressional forces. Now see, what do you mean by tensional forces? When I talk about tensional forces and compressional forces, these are two phenomena. Now see, over here, when let us say two plates are moving towards each other, or even one plate is moving, do you realize this movement is basically leading to compression. Compressional forces means that the distance between two bodies is decreasing. If one is stagnant and the other is moving, other is moving, then also you realize the distance between those entities in a way is decreasing. So it will lead to compression. Yes or no? Or if both the bodies of plates are moving towards each other, then also compression is taking place. So this moving towards each other is basically referred to as a compressional force. Now there can be an instance where, let us assume, there is, let us say, tensional or diverging forces. Let us assume this. Let us assume this. Supposingly, for just a minute to understand the fault, let us assume there are certain cracks present here, right? Cracks. This is diverging, this is diverging. Now, do you realize, due to this, it is possible that this might move down? Yes or no? Yes or no? These are the phenomena through which rift valleys are also formed. There are a lot of processes through which even faulting also, through which mountain building can take place. Those are known as, again, fault mountains. So that is why, please understand, this is a reason which has arisen. Similarly, let us say there is a rift valley over here also. So now this is a risen part. That is why, due to faulting also, you can possibly assume or see that phenomena of mountain building can be observed. Obviously, you will see those are not very tall because there is divergence taking place. But in a also way, we should understand that compressional forces obviously are creating the huge mountains that are present here, because obviously it is decreasing the distance and more energy is basically being thrusted over here. So that is why the compressional forces lead to creation of very tall mountains also, right? Okay, so we'll be doing these things later on, don't need to worry. We'll be understanding when we'll be faulting. Just a basic understanding of the orogenetic movement. Orogenetic movement, what do you mean by now? These are basically forces of movements which deal with the origin of the mountains. Clear? Now let's come back here. Before we begin the explanation of what is folds and faults under the compressional forces and the tensional forces dimension, we should have a basic instance and representation what is coming under the exogenic processes. We have done till now endogenic and endogenetic processes under this diagram. See here, we have done all these things under the endogenetic and exogenetic processes over here. We'll be doing the folds and faults. Just before we go to those topics, let us understand what comes under this topic also. Under the exogenetic processes comes the weathering, which is physical, chemical, and biological. We'll be doing them. Mass movement, that is basically taking place under the force of gravity. We'll be understanding those concepts like slow movement, rapid movement, very rapid movement. Then comes erosion. Erosion can take place due to running water, groundwater, glaciers, waves, currents, and winds. Similarly, these geomorphic agents also deposit the things that they have eroded. So they are also they have the depositional aspects also. For example, the running water if depositing, that leads to the formation of a delta. So please understand this very well, that over here, these are erosional agents also, geomorphic agents also, and depositional features also, which are depositing a lot of things, which we will be studying in the next chapter. Please understand this. These two things, as given in the NCERT, will be covered in the next chapter of landforms. Because every geomorphic agent over here is creating certain landform. So that has to be studied very well. Erosional landforms, depositional landforms. So that will be considered separately in the chapter of landform as per the NCERT, right? Okay. Now focus will be here when we will be doing endogenetic. Let's come back. Now let us understand the concept of folds and faults, which is not mentioned in your NCERT. Let me take an example over here. See, supposingly this is a plate, right? This is a plate. Another plate has come from here and a pressure has been exerted. So do you realize this pressure will exert and lead to this structure? Do you realize this is a fold that has been created? This is a fold. Why? Because of the compressional forces taking place. Now, this is a simple phenomena. If you understand, this takes place with these crustal layers also. So if this plate or crustal part, the force is exerted from one side, and this is, let us say, stagnant. Let us assume this. So it will lead to creation of this fold, this fold that is formed. So this is what? A fold, as you have already known. Now see here, waves like bends. What are folds? Folds are basically wave-like bends in the crustal rocks due to the compressional forces. Compression is taking place, as I mentioned, resulting in horizontal movement caused by endogenetic forces originating from deep within the earth. See, you know that you've already done the plate tectonics also. You have done the continental drift theory concept also. You have done the convectional current theory concept also, convectional current through Arthur Holmes, where we have already mentioned that a lot of phenomena are taking place inside the earth, which is leading to the movement of the plates. These are what? Endogenic processes. And these endogenic processes are then leading to formation of these what? Bending of these or crustal, bending of these crustal layers, as I've shown you using the paper also. So these are bend or wave-like bends that are formed in the crustal rocks due to what? The compressional forces. I've already highlighted the keywords over here. Please remember. Resulting from the horizontal movement caused by the endogenic processes that are taking place inside the earth, deep within the earth, and such bends are known as faults. So what are these bends? These bends are folds. Now, please copy this statement. This is a basic and the most easiest definition that you can come across with respect to folds. Let us analyze certain things regarding this. Whenever a fold is present, there will always be a, see, these are the limbs. If you see this, let me take an example. If I divide this into this form, this is one limb. Let us say this is a fold. This is one limb. This is another limb. First thing, you should understand the limb. So this part is one limb of a fold. This is another limb, right? Okay. Now, if you see the structure, you will see certain parts have risen, right? And other part is again bending or downfolded. This part which is upfolded or arch-like is known as anticline. This part which is what? Let me take another color so that you will be able to understand it better. This. Okay. This part is what? Upfolded rock strata in an arch-like form. This part is known as anticline. The one which is downfolded, this part, downfolded part like a trough is known as syncline. Always remember this because this is very, very important. This has been asked in your preliminary examination multiple times and in the PCS examination almost after 1 year, after every alternative year, they'll ask this question. In every PCS almost, because this is one of the basic concepts of the geomorphic processes associated with folding. Now, when you see the arch-like structure, how will you remember it? A for arch, A for anticline. The moment you remember this, you will never forget it. Arch means something that is upfolded like this. A for arch, A for anticline. Obviously, the other one will be syncline, which is downfolded. Clear? Now, let's move ahead. What are the types of folds that are present? Now, with every fold, I have drawn a diagram because, again, the NCERT does not mention it. And that is what is a missing part in your NCERT also, but it is something very important for you to understand. Now, these bendings can take place in various ways, depending upon what is the nature of the rocks, what are the, let us say, what are the forces or to what extent the forces are being exerted. A lot of things basically matter here. So, symmetric folds. Now, symmetric fold, let us see first of all, both limbs, you know what are the limbs? These are the limbs. So, over here you see this is one limb, this is another limb. Both limbs bend equally and dip at the same angle away from the center. So, in a way, can I say, let us say this is a line, this angle and this angle is same. So, that means this is known as a symmetric fold. So, this is symmetric. If this angle is not same, it will be asymmetric. Let us see over here, this angle is different from this angle. So, when both limbs are not bent equally, then it is asymmetrical. If they are bent equally with a similar angle, then it is known as what? A symmetric fold. Next, monoclinal fold. Monoclinal fold. Now see, it is a bend in the otherwise horizontal rock layer where the layer tilt in one direction like a step. Now, it was otherwise horizontal, but the force it is exerted that it is formed like a step. So, this is known as a monoclinal fold. Now, this is almost like 90 degree. This is what? Almost like, this is what? 90 degree. Almost. I won't say completely, but NCERT also mentions that this is almost like close to 90 degree. This is known as monoclinal fold. So, a step-like structure is formed. Otherwise, what was straight? A simple, let us say, layer of horizontal rock. Due to the pressure being exerted, it has modified and bended in such a way that it has formed like a step-like structure, which this angle is also almost approximately 90 degrees. So, that is why this is known as a monoclinal fold. Very important. This has been asked multiple times in your PCS examinations also and becomes important because this is something that many people don't understand. That is why I have drawn the diagrams. So, this is for the symmetric, this is for the asymmetric, this is for the monoclinal diagram. Okay, let's move ahead. Isoclinal, the most important thing, very easy. Here the limbs of the folds become parallel but not horizontal. These two limbs are almost parallel, but they are not horizontal. That means they are not lying down on the plane surface, right? They are parallel. This is known as isoclinal fold. If I turn this fold horizontally, that means the two arms are parallel as well as horizontal with the surface, then it will be known as a recumbent fold. Where limbs of the folds become parallel as well as horizontal, then it is known as a recumbent fold. Next comes overturned fold. Now, because of the compressional forces that are being exerted, what happens is sometimes one limb of the fold is thrust upon. One limb of the fold will be thrust upon along this plane on the other limb. Due to the intense compressional forces, this is known as overthrusting or overturn. So what happens is, this was otherwise like this, let us assume. Further pressure is being exerted and this part is thrust on the lower, let us the other arm. So this is known as the overturned fold. Now next move ahead. Open fold. See, here the angle between two limbs is basically what? An obtuse angle. Closed fold is one where the angle is acute, that is less than 90 degree. Simple. Nappy. Now nappy, please remember what is there. You have just now studied the overturned fold. What happens if after the overturn and the thrusting that has taken place, let us say this upper part limb is further exerted a lot of pressure and this part moves, let us say, a lot of kilometers away from the other limb. This upper part will be known as a nappy. See here. Due to the continued horizontal and compressional forces, this broken limb is thrown several kilometers away. This was the original place. It has moved several kilometers away from the original place. This broken limb is known as nappy, not the complete structure. Remember that very well. This is known as nappy. Clear? These are what? Folds. Now you can yourself understand when there is collision of the various plates that are taking place. That is why you see various shapes, various types of mountain ranges being formed, because it depends upon the nature, the forces, the extent to which the forces are being exerted. So this becomes again very, very important over here, right? Okay. Now comes crustal fracture. We have done with the folding. Now let us come to crustal fracture, under which we are going to study the faults, right? See. Now see, let us take, it refers to the displacement of rocks along the plane due to tensional and compressional forces, either horizontally or vertically. Now, when I talk about fracture, the moment I talk about fracture, what do you see? Let us assume this. Let us see this. Supposingly this is a block. This is a block of mountain, right? There are certain compressional and tensional forces being exerted. You know what are compressional? That means compression is taking place. Tensional, that means divergence forcing taking place. Now, because of this, you can realize that there might be a case where, let us assume, there is certain crack that has possibly formed. Can you see this crack? This is shown from the paper, from the aspect of paper, that is 2D, though 3D processes are taking place. So what is happening? Let us say certain cracks develop. Right? Now, see here. In order to understand this, you need to understand two phenomena. So, joint fractures in the crustal rocks wherein no appreciable movement take place. Now, let us assume these cracks that have formed are like joints, because right now there is no movement taking place. Again, see, let us take a little more. Cracks are formed within this layer. There is no movement. It is like this only. Now, what happens is, if supposingly, let us assume this further, let us say, cracks widens. This crack further widens. And supposingly there is, let us say, bending of this particular part. Right? Because it started from a joint or a fracture, and now what is happening? There is some movement that has taken place. Now, when the movement takes place, then it is known as a fault. When the fractures in the crustal rocks wherein no appreciable movement take place. There are cracks that have developed, but no specific appreciable noticeable movement has taken place, because these are merely joints. But when you see that there is further aggravation or intensification of this process, when there is an appreciable displacement of rocks on both sides of the fracture parallel to each other, in that particular case, you will see it is known as a fault. This is again a very, very important phenomena which you will be studying now. Now, before you go ahead, there are certain things that you need to analyze with respect to fault. These concepts will be clear. Now, let us assume, let's see this. Supposingly, this particular block was earlier over here. Let us assume this. Let's see this. Earlier, this block was at this level. Right? Let us assume this. It was at this level. Now, due to the various forces, it has moved down. Clear? This block has moved down. This is the fixed part. This is, let us say, this part is fixed. Now, the block which has moved down, that means this is known as a down thrown block, represents the lowermost block in a fault. First thing. This part is known as the upthrown block, represents the uppermost block of the uppermost part of the block of the fault, of the fault. So now the one which has gone down, which is the, let us say, which is representing the lowermost part, will be known as a down thrown, which is the uppermost will be known as the up thrown block. Now see here, the line, this line do you represent? This is a line through which basically this movement is taking place. This is known as the fault plane. Along the fault plane, this particular part, which is associated with the movement of the block that is taking place, this wall will be known as what? The hanging wall. Why hanging wall? Because this is a block which is moving down actually. So this is known as the hanging wall. Now this, which is stagnant over here, this is known as the foot wall. This part. This is what? The hanging wall. And this is taking place along the fault plane. Right? Block below the fault plane is known as a foot wall, and this is basically the hanging wall, block above the fault plane, right? Now see, this part where it was originally located, this has moved down. So this is the part which has now been empty because the block has moved down. This is known as a steep wall, like slope caused by the faulting. So this slope that is formed because of the faulting processes and the block that has gone down, this is known as fault scrap. So this is a steep wall that is formed because of faulting phenomena. These are those concepts which you should understand very well, because this basically helps you to analyze the various types of faults that are present. Clear? Now these are, again, one more thing, this angle, the horizontal, the angle between this, the horizontal plane and the fault plane. This is what? The fault plane where the faulting is taking place. This is what? The horizontal. The angle between them is known as a dip angle. This has also been asked in civil services, in PCS, so every time they ask this phenomena, particularly these things. You should be well aware of this. Okay, let's move ahead. Let us see the types of faults. There are various types of fault: normal fault, reverse fault, lateral fault, step fault. Graben or rift valley are sometimes considered as an outcome, but some books put it as a type, so that is why I mentioned here. That is why you will see a lot of rift valleys that are present, Narmada, Rift Valley and all. They are basically formed because of these phenomena only, right? Let's see. Normal fault. These are caused by the tensional forces. What do you mean by the tensional forces? That means forces or diverging forces are being exerted. Now these diverging forces tends to pull the crust apart. Obviously, it is going to pull the crust apart. And also by the forces that tend to expand are pushing. So by that means what happens that this tensional forces create a fault, and this part might move down. Now this is known as a normal fault. On the other hand, if there is compressional forces, let us assume, if there is compressional forces taking place, because of this compressional forces, this front fault plane that is created, it leads to this part going down along this along this fault plane. This is known as a reverse fault, formed due to the movement of both sides of the fracture towards each other. So normal plane is associated with tensional forces. Reverse fault is associated with the compressional forces, and this is how and what the phenomena basically take place. Lateral fault, in which you realize that these two blocks are sliding along with each other. So these are formed because the rock blocks are displaced horizontally along the fault due to horizontal movement. So they are basically sliding along each other. Clear? Step fault. Now step fault is very interesting, where you see a step-like structure is formed because of the various faulting activities. Certain books only mention these three types of faults, and they represent the step fault and rift valley as the outcome. Please understand them. Certain books mention rift valleys and step fault as an outcome of these faulting activities, but certain books mention as a type of form only of fault. So we have mentioned it here. There is no problem in that. A series of fault occur in any area in such a way that a step-like structure is formed. So this is known as what? Step fault. Along these lines, see, these are the fault planes through which these step-like structure is formed. Graben or rift valleys, these are the major relief features resulting in the faulting activity. It represents a trough depression on the basis of the crustal path. So what happens is, let us say between these two parts, let us say this part has gone down. So this is representing a depression and this is representing like a risen part. So these are known as rift valley structures. Clear? That is why you see Narmada Rift Valley. Yes, and the river is basically flowing through these graben regions. These are also formed due to the faulting activities. Clear? Okay. Now coming back to the, we have done with the faulting, we have done with the endogenetic aspects. Now let us come to exogenetic. Now see, as I've already mentioned, we'll be covering weathering and mass wasting over in this chapter. We'll be covering a few definitions over here because this has to be covered in the next chapter. Let's start with the weathering aspect. Now before we start, let us understand these are processes: weathering, mass wasting and erosion. Before I begin, you should be very clear about this. When I talk about weathering, weathering processes basically tend to loosen the fragments of the rocks. Now, they are done by physical processes, biological processes, chemical processes, and obviously gravity also plays a role, which we'll be analyzing. Mass wasting or mass movement is only associated with a gravitational force. Sometimes people say, sir, if something is moving down because of running water, when I talk about running water, then I will not cover it under mass wasting. Anything over here, and the only force that is associated with mass wasting is gravitational force. Anything moving under the force of gravity, that is mass wasting. Erosional obviously is associated with kinetic energy because you realize that river water, let us say, eroding certain things, waves eroding certain things, glaciers, avalanches eroding certain things, those have kinetic energy. And that is where the erosion is taking place or removal of fragments are taking place. That is associated with erosion. Mass movement or mass wasting will only be associated with a gravitational force. Please mark this and keep it in your head before we move ahead. Clear? Okay. When I talk about weathering, let us start with the process of weathering. Weathering is a process of disintegration and decomposition of the rock in situ. In situ means at the place where the weathering is taking place, over there only this decomposition is taking place. Right? So disintegration, a rock fragment is there, it is broken down, decomposing, broken down into further fragments. Whatever be the process of disintegration and decomposition of the rocks in situ. In situ means at the place where it is situated, it is taking place over there. That is why in situ. It is through the mechanical and chemical changes in the rocks. Yes, though whatever be the processes that are acting on it, physical, chemical, biological, but it is basically leading to some mechanical or chemical changes. That is why weathering will take place. Right? Even if, let us say, biological action by some animal or someone is scratching a rock and there is some breaking of the fragments, though done by a, let us say, an animal, still a mechanical force is being exerted. So that is why we are talking about mechanical and chemical phenomena. So let us say chemical because let us say some chemical reaction taking place. That is also possible, which we will be seeing. There is no movement of weathered material unless under the influence of gravity. That is why we have said if any movement is taking place, it might be due to gravity, but we will, under weathering, we do not consider any movement of the substances taking place because that will come under when we will be studying the topic of erosion and transportation and all. Under weathering, always remember that there is decomposition and disintegration taking place at the place where it is. And if certain appreciable movement is there, that will be because of gravity, not because of any other geomorphic agent like running water or wind or anything else. No. If there is some movement because of gravity, otherwise no. That is the core concept that you should remember. There is no movement of weathered material unless under the influence of gravity. So these are statements which are asked in the civil services also. These are very important. Now you will say why they have considered this, not other processes. Please understand these are standard phenomena through which they have differentiated what processes will come under what category. Otherwise, everything will overlap with each other, then you will not be able to differentiate between them. That is why they have made these rules with respect to the definition and the concepts. The movement of weathered material under the influence of gravity is called mass movement. Now, please understand how weathering and mass wasting are association over here. Weathering is the decomposition and disintegration of the rocks or the minerals in the rocks over here. Now, this decomposition is what? Weathering. When I talk about over here, the movement of these weathered material under the influence of gravity is mass wasting or mass movement. Can you understand this? So that means under the weathering concept, they said you can include the concept of movement under gravity. So mass movement is in a way part of it, where you are basically talking about the movement of the weathered material, if taking place under gravity, would be mass movement or mass wasting, which is already a part of weathering. So this is very, very important. We will be doing mass wasting and weathering. Again repeating, let us assume there is, let us assume this. This is possibly what? A huge rock that is present in a desert region. Let us say the regions of Persia, Iran. Iranian deserts are little rocky deserts also, you know that. Now, because of this, lot of, let us say, winds are moving around. And because of that, let us say, outer layers would be, let us say, little bit eroded. Again, there is high temperature during the daytime, cool during the night time. So obviously those factors are taking place. Let us assume now certain erosions are taking place. Certain weathering is taking place, not erosion, weathering. Now what is taking place? You see this? This is disintegration of this particular aspects. Now you will say, sir, the finest sediments that are basically being weathered are falling down. Now those falling down is basically under the influence of gravity. Clear? So when I'm talking about weathering, I'm talking about the decomposition and disintegration that is taking place of the rocks. Any movement that is associated of the weathered rock under the influence of gravity is mass movement or mass wasting. This should be very clear. Because when I will talk about the transportation and all those phenomena taking place due to running water, waves, currents, winds, that will come under erosion, not under these phenomena. Weathering basically loosens up or disintegrates, decomposes. Clear? Okay. Now let's move ahead. Movement of weathered material under the influence of gravity is known as mass movement or mass wasting. Weathering aids mass movement as well as erosion. Obviously, erosion later on will take place, will be held because it is weathering processes are loosening what? The fragments of the rocks. Weathered rock matter is known as regolith. Now, the weathered rock material is known as regolith, that basically forms a basis for the soil. Obviously, later on you form the soil. So, we will be seeing these aspects also later on. So, what is this weathering? Process of disintegration or decomposition taking place of the rocks in situ, that means at the place where it is. Secondly, this is because of the mechanical and the chemical forces or phenomena that are happening or changes taking place in the rock. One, you should also remember, there is no movement of the weathered material unless it is, and we are talking about the force of gravity. And the movement of the weathered material under the force of gravity is known as mass wasting or mass movement. Clear? Let's move ahead. Types of weathering, it is mechanical or physical, it can be chemical, it can be biological. These are the three major types, and these are the broad phenomena under which we are going to study. So let's see the first category, which is basically what? Physical. Now what I mentioned over here, these things are mentioned in our NCERT in one line, and they're not been explained properly also. So what I have done over here, I have mentioned that I made the diagrams, mention them in detail so that you understand them properly. You will not require anything else beyond this. Mechanical weathering or physical weathering. These involves mechanical lock disintegration caused by temperature and pressure fluctuations, and because of that, weathering is taking place. There are a lot of types, ways through which this physical or mechanical weathering can take place. Let's see one by one. Block disintegration due to temperature change. Now see, let us assume this is the original rock that is present, right? The block disintegration refers to the effect of temperature on different rock types like expansion and contraction in granite due to temperature variation. Now let us say this is a granitic rock, and lot of outside temperature variations are taking place, because of which a major part of block basically falls down under the influence of gravity over here. Because why? There is, during the daytime, let us say temperature is high. Then there might be cooling effect during the night time. So there will be, let us say, a disintegration or cracks might develop on these rocks, and a huge, large broken block will fall down. Now, you see these lines that I have made, these are because of the cracks that are made due to contraction and expansion. During the daytime, when there is a lot of heat, temperature is high, expansion of rock will take place. During the night, when there is cooling, so that means due to repeated expansion and cooling, there will be cracks that will develop. And a large, huge piece of rock will break from this major peer-edged rock, and this is known as block disintegration due to temperature change. Clear? Block disintegration due to temperature change. This is first type. Second, granular disintegration due to temperature change. Now see, both these phenomena is basically majorly varying because of the different in the type of rock. Because over here also, if you see, there is going to be temperature changes, let us say heating during the daytime, cooling during the night time. That phenomena will take place here. But why certain block is being broken down here from the parent rock, and over here granular disintegration means small finer particles falling down? It is because of the variation in the type of composition of this particular rock. Now see, that is why coarse grained rock are more affected by shattering processes in the hot desert, which are characterized by high range of temperature. So those rocks which are very highly, let us say, coarse grained, there is greater probability of them undergoing the phenomena of granular disintegration. Now we'll see what it is. If rocks are coarse grained and are of different colors, because it is coarse grained, possibly there are a lot of different colors or subparticles that are present, they will be absorbing light also to a different degree because of the color, and that will basically lead to the absorption of light in a differential rate, and that will lead to a lot of particles basically separating or falling from the parent rock. Now if you see this particular yellow line, this represents the original or the former rock substance that was present here. Now because of the heating during the daytime and cooling during the night time, unlike the previous one where the block fell, over here because this is coarse grained, small particles of these rock will basically fall down. That is why rock disintegrates into small granule sized particles, often resembling a coarse sand. So that is why this is known as granular disintegration. Again, the conditions might be very similar in case of the block disintegration and granular disintegration. The only difference majorly will be because of the type of rock, the composition of the rock, and the texture of the rock. That is what is making the difference here. Okay, let's move ahead. Block disintegration due to frost. Now see, disintegration of rock into large sized blocks due to freeze and thaw of water, common in the temperate and the cold climatic regions. Let us assume this is a original piece of rock. Now there is a crack that is present here. Let us say during the daytime when temperature is relatively little warmer, water might enter this. Now during the night time, the water might freeze, because when the water, you know that very well, when water converts to ice, it expands. This expansion will lead to the pressure being exerted on these, the rock substance. The crack will further widen. During the daytime, the ice will melt again, and this water will again move even deeper. The same process will repeat day, night. What will happen ultimately is, it will lead to these two, this whole mass basically being split into two or more parts. That is why it is also block disintegration, because big, huge particles are being separated rather than small granules. So that is why block disintegration due to frost is taking place. These take place in the temperate or the cold climatic regions where water can freeze naturally also in those regions. So that is why this is one of the major forms of erosions physically when you see in the cold or the temperate regions, right? Let's move ahead. Exfoliation due to temperature and wind. Now over here, temperature and wind are playing a very important role. Now see here, exfoliation weathering is also known as onion weathering. Very important concept. This has been asked in your preliminary examination and repeatedly in the PCS examinations. Please remember this. It refers to the peeling off of concentric shells of rocks. What do you mean by peeling? Like onion has so many layers, you keep on peeling one or the other layer. Similarly, over here, the similar phenomena is happening. So the peeling off of concentric shells of rocks due to the combined action of heat and wind in hot, arid and semi-arid regions and monsoon land. So what is there? Let us see. Let us say this is a granitic rock where during the daytime a very high amount of intensity of, let us say, heat is being generated. Over here, it will lead to what? Expansion of the granitic rock. Now what will happen is, now these over here, the role of wind is also very important. During the night time, the contraction will take place. This will lead to development of cracks. Then again, what will happen? Next day, again during the daytime, it will lead to, let us say, certain parts again expanding, because of which, let us say, a layer of this layer of the outer layer will basically remove because of the wind also, because the wind will also act on it, and along with the temperature variation and development of cracks. And what will happen is wind will further remove all these small fragments that are outside. It is like peeling of the layers. Now this remaining part is known as the exfoliation dome. This is known as onion weathering, because with time after time you will realize the outer layer being subjected to the temperature variations during the day and the night, and the wind is exerting an important influence where those layers where the cracks are developing, it acts as a force for further disintegration, and that leads to slowly the outer layers being removed, and the size keeps on decreasing, and finally it will be non-existing. This is known as exfoliation due to temperature and wind. This was the physical weathering. Now let us come to the chemical weathering. Now please understand. Note this heading quickly that is associated with chemical weathering. Please note it down. Now see, decomposition or disintegration of rocks due to chemical reactions is known as chemical weathering. Now this is because of the chemical reactions. Now please understand, over here you do not have to go into a lot of detail. I'll be covering in them what is required over here. Various books mention various types. So I've covered comprehensively over here what is required by you. So stick to this. Solution. Now, what do you mean by solution? See, it refers to the dissolution of soluble particles and minerals from the rock with the help of water and acid. Now, there are a lot of minerals that are present in the rocks which are soluble in nature. Some directly in water, some let us say some in acidic form, let us say water reacting with carbon dioxide, creating an acidic nature, and that might lead to certain minerals dissolving in it. So what is that? That is basically known as solution. That refers to the dissolution of soluble particles and minerals with the help of water or acids. Now, on coming in contact with water, many solids disintegrate and mix up in the suspension in water, right? Soluble rock forming minerals like nitrates, sulfates, potassium, etc. are affected because they are soluble in nature. They were the ones going to be impacted by this. So what happens is when these rocks basically come in contact with water which are soluble in nature, they will dissolve. Yes or no? They will dissolve, and obviously they will be then washed away. That is why if you see examples, minerals like calcium carbonate and calcium magnesium bicarbonate present in limestone are soluble in carbonic acid. Carbonic acid is basically formed by the reaction of water with carbon dioxide. It leads to the formation of this mild carbonic acid, which basically dissolves what? Calcium carbonate and calcium magnesium bicarbonate. Now please remember this. This particular case is basically representing carbonation. Carbonation over here is not a separate phenomena. It is basically an example of solution. Certain books do not even mention carbonation. Why they do not mention? Because they consider because it is already a part of solution, but some mention, that is why I mentioned here. So it is a reaction of carbonates and bicarbonates with minerals in a common process in breaking down of the feldspar and carbonate minerals. So what is going on is this particular example which I mentioned here is itself a representation of carbonation phenomena. So this is an example for solution, but this is itself a process of carbonation. So that is why carbonation is also a type of solution. If you want, you can mention it. You do not want to mention it separately, there is no problem. You will not be marked wrong. So over here, carbonates and bicarbonates with the minerals over here basically react with carbonic acid and then dissolve. And now this phenomena is known as carbonation. Now it is a form of an example of solution or type of solution. So you can mention it separately also or part of solution also. There is no problem. Next, hydration. Hydration is a chemical addition of water. Now what happens is, let us say, let's take an example also here. Minerals take up water and expand. This expansion causes an increase in the volume material itself on the rocks. Let's see, calcium sulfate reacts with water to form gypsum. Calcium sulfate .2H2. This is gypsum. So what is this? It is a chemical addition of water to calcium sulfate. Now I'm using the chemical reaction. Many will say that we do not know. Please remember this. This is a the basic science which even a class 10th level should know, because this is part of your general science also. So this is what? CaSO4. What is this? calcium sulfate reacting with water to form CaSO4.2H2O. Yes? So this is known as gypsum. So this is chemical addition to what? Chemical addition of water to basically calcium sulfate. Please note it down. Clear? Okay. Oxidation refers to the reaction of atmospheric oxygen to form oxides. Now, addition of oxygen to, let us say, to form oxides, what will happen? Let us say iron is reacting with water and oxygen. It forms Fe2O3 plus 3H2O. This is basically rust. This you have done in class 9th and 10th also. So what is happening over here? It is basically forming oxides of certain elements or minerals. So this is resulting in what? The process of oxidation, where addition of atmospheric oxygen is taking place, resulting in formation of oxides. Clear? Like ferric oxide. Similarly, other oxides are also formed. This is oxidation. Now, these basically lead to what? Breaking down of various rocks, and that is why it is also a form of weathering. Now, come to biotic weathering or biological weathering. Now, biological weathering is geological processes in which organisms like plants, animals, and humans or microorganisms basically contribute towards disintegration or decomposition. Now, under the category of animals, we include humans also for that matter, right? So, all the processes of disintegration taking place due to plants, animals, other microorganisms, humans comes under biotic weathering. Let us say burrowing organisms. Animals like burrowing organisms like rodents, insects, earthworms can create tunnels and burrows in the soil, rock. Their activities result in physical disruption of the rocks and sediments. So obviously these burrows basically lead to disintegration of various rocks. So that is also caused by what? Burrowing organisms or animals. Microorganisms like fungi, bacteria, lichens are microorganisms. They produce organic acids. Now, these acids are chemically they might dissolve certain minerals. That also leads to what? Disintegration of the rocks. Next, plant roots. As the roots grow further, they exert a lot of pressure. So now they exert pressure on the surrounding rock, causing it to crack and break apart. Now, these are also what? Types of biological weathering. Now, let's come to another topic, that is mass movement and mass wasting. I had told you something. When I talk about mass movement, that means there is some movement of what? The weathered material, but only under the influence of gravity, not because of any other force. Remember that very, very well. See here. Mass movement transfers the mass of rock debris down the slope under the direct influence of gravity. So there is some downward movement. So that means there has to be certain influence of gravity, only then this will take place. So weathering is not a prerequisite for mass movement, though it aids the mass movement. This is again a very, very important dimension. Weathering is, what does weathering do? Weathering basically disintegrates the rock. It is not necessary that disintegration has to always take place. If supposingly there is a rock that is present on a slope, now there is no disintegration taken place, still it can move down because under the influence of gravity. Yes? So that is mass movement or mass wasting. Yes, if the rock is present there and it has undergone certain disintegration, that can basically be aided, that will basically be helpful. It can move down because of that also, but it is not necessary that weathering always has to take place. So weathering is not a prerequisite. Mass movement is aided by gravity, and no geomorphic agent like running water, glacier, wind, waves, currents participate in this process of mass movement. Remember that mass movement is only the movement taking place because of gravity. No other phenomena like running water and all those things will come under this category. Because that is why can I say mass movement does not come under erosion, because under erosion we include all these factors of winds, glaciers, currents, winds and all those things. So mass movement does not come under erosion. That is clear cut. These are statements which will come as statements in your preliminary examination also. So if I see the major classes of these mass movement, please understand, some of them are very rapid movement. That means no water is required here. Let us say landslides, under which you have slump, debris slide, rockfall, rock slide. We'll be doing them, don't worry. Rapid movement, that means slower than these phenomena. Though over here you require enough water is required. Earth flow, mud flow, sheet flow, avalanche. Slow movement, little water is required, creep and solidification. Now you will be seeing, sir, ki over here the movement is under gravity. Movement is under gravity, please remember that. This should be very clear. Whether certain agents are aiding or not aiding a different phenomena, please understand. Geomorphic agents might be helping. but the movement will take place under gravity. That is a major phenomena. Please understand this very well. This is somewhat confusing when you read the books. Geomorphic agents might aid, but the movement will take place under gravity only. That is why it will be considered under mass movement. Very rapid movement over here. These are relatively rapid and perceptible movements. The material involved are relatively dry. Under them, very rapid movement, you have slump, debris slide, rock slide and rock fall. These are the four. Let us see one by one. See here, slipping of one or several units of rock debris with a backward, this is important, backward rotation with respect to the slope is known as slump. Do you realize something? Over here, this is moving down, but there is a backward rotation. It is rotating. This backward rotation is basically referring to the slump. If there is no backward rotation and simply, let us say, the rolling and sliding movement is taking place without any backward rotation, it is known as debris slide. Again, slipping of one or more several units of the rock debris or debris with a backward rotation, it is backwardly rotating, then it is known as a slump. If all the phenomena are same but no backward rotation is taking place, then it is known as a debris slide. So rapid rolling or sliding without any backward rotation is known as a debris slide. Over here, simply moving down without any backward rotation. Next, rock slide. Sliding of individual rock masses down the bedding joints is known as rock slide. So let us say there is rocks were here under the impact of gravity. They are basically moving down. This is known as rock slide. Supposingly a rock is over here. It has fallen down. This is known as rock fall. Rock fall is free falling of rock blocks over any slope, keeping itself away from the slope. So obviously, in a way, sliding is again moving down the slope. Over here it is falling because of possibly the inclination that is there. And obviously, please remember, it is a free fall, free falling of the rock blocks over any steep slope, keeping itself away from the slope. Right? Let's move ahead. Rapid movement, earth flow. Now these are relatively present in the humid climatic conditions. The movement over here, whether there is, let us say, saturation of water or not, movement is because of gravity. Remember that very well, right? Geomorphic agents might aid, but the movement is going to be under gravity. Earth flow, the movement of water saturated clayey or silty earth material down the terrace or hillside is known as earth flow. If you see here, water saturated clay and silty soil moving down the slope is basically known as earth flow. What is mud flow? Absence of vegetation and heavy rainfall, thick layers of weathered material get saturated with water and flow rapidly. Now, because again mud will have a large amount of weathered material also. So this is basically moving down the slope. Debris avalanche, again it is similarly, please remember, it is a larger form of a mud flow. The reason behind it is, you can say, when we talk about avalanches with respect to glacier, those are very large scale, very relatively faster moving. Similarly, you can say it is a larger version and a faster version of a mud flow. That is why it is more characteristic of humid region with or without vegetation cover, occur in narrow tracks on steep slopes much faster than the mud flow. Clear? Slow movement. Now, creep over here and solidification I mentioned. These are again slow movement processes that take place. Creep is again occurs in moderately steep, soil covered slopes. Movement of the material is so slow that it is not even perceptible normally. You will see, let us say, the movement of the soil is basically moving down. So this is known as soil creep. Example is soil creeping. Over here, you will not be able to observe through your naked eye. It is so slow. But obviously, if you observe it over a very long time, you will see that this particular slope or this soil is basically moving down. Let us say the tree is here, possibly after a long time, it might be here. So now is solidification. Solidification, what happens is a slow downward flowing mass of fine grained rock debris, which is saturated with water. So this is saturated with water, the underlying, and because of that, this particular fine grained soil, or let us say, is moving downward. So this is known as solifluction, because solifluction is associated with saturation of what? Water, which acts as a lubricant for it to basically move down. Clear? Please note it down. Erosion and deposition, please understand, we'll be covering this in the next chapter. It basically involves the acquisition and transportation of the weathered material or the rock debris, and it is basically the application of kinetic energy associated with the agent. Now, please understand, whenever we talk about erosion, we'll be considering the aspect of kinetic energy being associated where geomorphic agents like running water, waves, currents, winds and all are acting on the substances which are either weathered, because weathering helps or aids in erosion. So, and what are the processes that are associated with them? So, we'll be considering them in erosion, because erosion has to be studied comprehensively from the erosional aspects and the depositional aspects. So, if a wind is eroding certain thing, it is going to deposit also. So, those deposits that take place are known as the depositions. It is a consequence of erosion. So, these are two phenomena which will be studied in the next chapter in the topic of landforms. So, I've just mentioned it here just for your knowledge. So, this was the topic of geomorphic processes. Hopefully you enjoyed it. Hopefully you studied and understood it. Please go through the notes and content repeatedly. You will be able to understand it better, because this topic is a little complicated also. This requires revision. So God bless you. Take care. Happy Diwali to all of you. We'll be coming with the next lecture after Diwali. Lots of love from my side. Keep on listening to these lectures, understanding them, and note it down and understand and memorize them after understanding.
Another lecture from the physical geography series. This is lecture number 6, that is landforms and their evolution. Now, please understand, students, whatever we had studied in the previous chapters, particularly the geomorphic processes, becomes very, very important in the understanding of the chapter of landforms, how the landforms are formed. But before that, we need to understand what landforms are. Along with it, there are a lot of geomorphic processes and agents which are shaping these landforms, like wind, like running water, glaciers, groundwater, and so on and so forth. And we're going to study them each one by one, and I'm going to tell you what are the erosional features, what are the depositional features with diagrams. Now, this is something very important. Unlike the NCERTs, where they have mentioned a lot of things, but they haven't drawn a lot of diagrams, but you are asked these features repeatedly in your prelims as well as your mains examination. That is why I'm telling you again, even this time, there was one feature that was asked with respect to the glacial features, and many were not able to attempt. So that is why I'm telling you, whatever is being done in this chapter is a very comprehensively, it has been covered, and whatever diagrams have been made, those have been made by hand. So it is easier for you also to make them and replicate in your examination. So let us begin with today's chapter, that is landform and their evolution, that is lecture number 6, topic that is landforms. Now, when we talk about landforms and their evolution, it is also important for us to understand what landform basically means. Landform. Let's leave the definition right now for 2 minutes. When I say land, you by default means we are talking something related to the surface of the earth where land is present. Then form. Can I say a shape that is being taken by that land? Now, that shape might be a little bit uplifted, that might be flat, that might be in, let us say, coarse or a crude form. So, can I say that shape that is formed or present when I see a certain part of land might be because of certain processes that it might have undergone, and because of that, that particular shape of the land is present. So, landform is basically that particular shape which we are analyzing, but it is caused by certain agents and processes that we have to study here. So, in simple words, I have told you what landform is, landform, but let's see what is the geographical proper definition when we talk about the concept of landform. Let's see. When we study over here, you'll see landform are natural physical features. Now, many will say, sir, there are artificial features also included. Over here, we are not talking about them. Yes, they can be created. There can be amusement parks also where artificial landforms are created. But over here, when we're talking from the perspective of geography over here, we are talking from the perspective that we are taking natural features right now, right? So these are natural physical features on the Earth's surface, such as mountain, plateaus, plains. Now you see, when I talk about mountains, when I talk about plateaus, when I talk about plains, we have done these concepts also in the previous lectures. They have been formed because of certain processes that have taken place. You have studied the fold mountains concept, which I told you. You have seen a lot of processes, erosional aspects also we have done in brief in the previous chapter also. So there are, when we talk about plains, you know it is formed because of the deposition that has taken place, right? So we, in a way,
understand that whenever I see or whenever you see a part of the land, there will be certain structure that might be formed. Let us say features that might be formed, to be more precise. That might be like of a mountain, plateau, or plains. Now, these are the natural physical features that are present on the Earth's surface, and these are referred to as landforms. Now, please understand, they are created or modified over a long period of time by weathering, erosion, and deposition. Now, see, when we were doing the topic of plate tectonics, you know that very, very well, that on one hand, there were certain processes that were creating new landforms. There were other processes that were eroding them. You have seen them. Now, similarly, that means a landform that is created is an outcome of these processes that are going on. Some processes might be eroding them. Some processes might be creating them. Similarly, if you see, whether it is a mountain, whether it is a plateau, you see very often you hear about the word like eroded plateaus. How come? Supposingly the plateaus have been formed due to some, let us say, granitic rocks. Those are due to volcanic eruptions. Let us assume that, right? There can be multiple other reasons also. But those plateaus, let us say, are slowly being eroded by, let us say, wind, let us say, running water. So their shape is being modified. They were created by some forces and agents. They're being destroyed by some of the other forces of agents. So that means what the present landform is an outcome of the balance between those processes which are creating them and the ones which are destroying them. Similarly, see here, because any landform is created or modified. Modified means because the shape might change, the way it is looking, the way it is being depicted might change because of the processes which include weathering, erosion, and deposition, right? Now see, evolution of landform implies a transformation. Transformation means change, either in the part of the Earth's surface from one landform to another, or transformation of individual landforms after they have once formed. So in both ways, see, first, there are two things that have been mentioned here. Now, this is important from the NCERT's perspective also, right? That has been mentioned here. Evolution of landform implies transformation. Transformation basically means change. Now, the change can take place and a part of the Earth's surface from one landform into another. Now, supposingly, there is a region where, let us say, a plain region is present, right? Now, due to some tectonic movement, there is upliftment. Now, there is a transformation that has taken place in that region. So, there can be transformation on the part of the Earth's surface. Another, transformation of individual landforms after they have once formed. Now, individual landforms changing. Let us assume there is a rock, huge boulder or rock that is present. Due to wind erosion, its shape is changing continuously. Or after that, you will see a mushroom rock being created. So, those cases can also happen. So, multiple aspects. In simple words, the thing that lies is the landscape, which are natural physical features present on the Earth's surface, and these are subject to changes, modification, and again, new landscape might be coming because of the processes that take place, which include weathering, which includes erosion, which includes deposition. So this is what landforms basically refer to. Now, when we have discussed about this, you know that in the previous chapter, we had discussed about two aspects along with the weathering and mass wasting, which I had mentioned that erosion and deposition. Now see, let's see here. Something very interesting to note here. Let me tell you something. Please understand this. I'm writing certain words over here, and because this chapter is going to deal with this, that is why it becomes very important. Let's see. I'm writing few words. Let us say wind, right? Let us say running water or surface water, right? Let us say groundwater. Groundwater is very intricately linked to the concept of karst topography, that is lies in the region of limestone regions, which we'll be studying, right? You can even have glaciers, etc., right? Now, do you realize that when I talk about, let us say, wind or running water, let us take for the timing these. Do you realize wind in a way is basically eroding certain things also. What do you mean by erosion? Erosion basically means, again, certain rocks, certain landforms might be weathered. That helps in erosion, obviously, but individually also it can happen. What we try to say is acquiring and transportation of the various material basically covers the aspect of erosion, and that being deposited is known as deposition. Now, over here, all these things that are present here have a dual nature, that these include a lot of processes also, geomorphic processes as well as agents also. Because see, wind is going to erode also, wind is also going to deposit also. Running water is going to erode also, running water is going to deposit also. Groundwater is going to erode also, groundwater is going to deposit also. Glacier is going to erode also, glacier is going to deposit also. We have done erosion and deposition briefly in the previous chapter also. That is why these are themselves as processes also and agents also. So they are, that is why are studied under geomorphic processes and also as agents, as geomorphic agents. This was a chart also that I had made in the previous lecture also, because it will include a lot of processes also, and there are agents also which are again eroding also and depositing also. So that is why in this particular chapter we will be picking up these things one by one, and we will be discussing what are the erosional features, what are the depositional features or landforms that they basically form. This is the whole chapter which in the NCERT deals with. Along with it, obviously, I have added a lot of other words, other explanation, other features which are possibly not mentioned in the NCERT. Why? Because again, NCERT might have just simply mentioned or not explained, so I have explained them. Certain other features have been added from some other books also, just to make it more comprehensive. Clear? Now let's begin with all of these one by one. First is wind. Now everybody knows what wind is. We are not going to see that what wind is, but see, from the perspective of landform formation, this is a very, very important agent, as well as includes a lot of processes. Now, the way I have mentioned, now these are certain things which are mentioned in NCERT also, but they are not explained very well. So what I have done is I've explained them also in form in such a way that you will be able to comprehend and remember them, right? Now, wind. Now, you know that very well, wind is a very dominant agent when it comes to hot desert. Now question will arise in hot desert. Obviously, temperature variations are there, winds are blowing, they might be eroding certain rocks that are present there. But how, sir? So there are multiple processes through which they do. That is why I have mentioned all these three processes or ways. So first of all, wind is a dominant agent in the hot desert. This has been asked in the PCS examinations repeatedly, in almost all PCS, and in UPSC also it has been repeatedly asked. Wind is a very dominant agent of erosion in the hot desert region. Now, wind erosion generally takes place above the ground, and the wind velocity plays a very major role. Now, please understand, when the wind is blowing, it is not only simply blowing. Yes, there can be normal processes also where wind is blowing, but in most of the cases, you will realize that they pick up small sediments also. And those sediments, again, when they are blowing, those sediments actually in a way attack the landforms also, and that is also like helping in erosion of those landforms and reshaping them, which we will understand over here. Obviously, you see that it is generally taking above the land, above the surface, above the ground, as we said. Now, what are the processes that are involved becomes very important. The wind erosion basically happens or takes place through three ways. First is deflation. Second is abrasion or sand blasting, as it is called. Both words have been used, can be used. Third is attrition. Now, these words have been asked in the civil services also, in the prelims, as well as PCS, so multiple times are asked. Now, how these processes take place and what they are, this should be understood very well, because in the civil services, they can possibly give you match the following, and possibly if you do not know these processes well, you will not be able to even answer them. And in mains also, very easily they can ask you. Now see here, let us see deflation. What do you mean by deflation? It is a process of removing, lifting, or blowing away dry and loose particles of sand and dust. So that means when the wind is basically removing, lifting, or let us say blowing away the loose material that are present because of the velocity of the wind, it is known as deflation, right? Now, this is the concept of deflation. We will be studying them in the application perspective also, then you will be better able to understand. Right now, just understand the definition. Supposingly, there's a certain, let us say, rock that is present. It has certain loose particles that are present. Or for that matter, let us say normal surface is also present in a, let us sandy surface is also present on the desert region. The wind is coming at a very fast pace. From, let us say, certain particles that are present on the rock surface also, which are loose, it might be blown away from, in a way, detaching also, removing from the surface also, from the rock surface. Or they might be lying, if the sand particles might be present in the desert, then also they are picked up. Either case, the concept is basically they are removed, lifted, or then taken away by the velocity of the wind. That is known as deflation. Next comes abrasion or sandblasting. Now see, this is a very interesting concept. Abrasion means that the wind-driven sand particles strike against the rock surface and wearing them down. You will be seeing, sir, aren't we going to see the diagrams of this? Beta, please understand, when I will be going here, we will be seeing a lot of processes. So everything is covered here. All the dimensions which I have made here with respect to all the features will be present here. So don't need to worry. Right now, just understand the concept. I'll be explaining you again. Don't worry. Abrasion basically means that the wind-driven sand particles strike against the rock surface and wearing them down. It involves rubbing, grinding, and polishing. Now let us assume this. Let's take an example. Supposing this is a small rock structure that is present in a desert, right? Supposing this is a wind that is coming, right? Now this wind has, now see, supposingly this wind is coming here. Now see like this. Now over here, wind has picked up certain what sand particles. Now this wind carrying sand particles are coming and striking here. Now when they strike this down, it is going to wear this down also. It is going to, in a way, erode also. So remember this abrasion. Why it is known as abrasion or sand blasting? This is the reason. That means that the sand particles or the sediments that are being carried by the wind are striking because the wind is blowing them. They're going to strike the another surface or another landform, and which is going to wear it down. Now this repeated rubbing, in a way, that is why it is known as rubbing, or in a way polishing, might giving a little bit shine also. Why? Because see, you would have seen when you are rubbing certain thing down, if you're reducing the friction, it will lead to certain shine also. That is why they have mentioned the rubbing, grinding, and polishing the surface. I'll be showing you a diagram also, so don't need to worry about that. Attrition. Attrition is a process by which rock fragments and sand particles carried by the wind collide with each other and form further finer particles. Now, what does it mean? Supposingly, wind is blowing. Within the wind, there are a lot of sand particles that are present. They are colliding with each other. Now, collision with each other leads to formation of further finer particles. This is known as attrition. Let us see it in certain, let us see, make certain diagrams of this. I've already, you have this, I've made a copy of this. Let's see this. Okay, now let's see. When I'm talking about deflation, let's see deflation. Supposingly, this is a surface. You know that during the time when you're talking about hot desert region, there's continuous temperature variations during the daytime. It's very hot. During the time of night, it is cold. So obviously, there are a lot of cracks that might develop in the landform. So you might assume that there are certain cracks might be developing and certain particles might have broken down here, like this. Now, in this process, we realize that wind blows. Wind is blowing. What it will do is, Do you see the particles which were present here? The particles which were present here in a way, see here. I'm putting small particles over here which are reflecting that they have taken, these particles have been taken by the wind. So the particles have been picked up and taken by the wind. So that means process of removing, lifting, blowing away of the dry and loose particles of sand by wind. So it has been taken away. So what does this mean basically? So what does this mean? This basically refers to the aspect where the wind, due to its velocity, blows away, picks other, let us say, sand particles or dust particles away because of the velocity. This is known as what? Deflation. Now comes abrasion and sandblasting. Now let us see here. Supposingly this is a surface of a, supposing this is a rock that is present. Let us say, right, let us say landform that is present, a large landform that is present, a large rock structure is present in the desert region. Now, what happens is, wind is blowing. Now, people will say, sir, you had mentioned that erosion takes place above the ground surface, not very high also. The reason being because when they are carrying the sand particles, they also have a weight. So there is a restriction to which level or a height the wind can take or carry. That is why generally they are close to the ground surface. Now let us assume they are basically carrying these particles which they had picked up from here. Slowly what will happen? There is a possibility that depending upon the rock structure also, please remember this rock structure also. Now this is the eroded surface. I think on the color might not be visible, so let me change it. Eroded surface. Why? Because over here there is wearing down that is taking place because of the particles which were being carried by the sand. When I'm talking about attrition, now please understand this is again a very interesting process. Supposingly the wind is moving. Supposingly the wind is moving here. Now what happens is there are particles. These particles are present here, right? Now what we are trying to tell you is these particles are colliding with themselves, with each other, sorry. They're colliding with each other, and that is why the sediments which are present become further more fine because of the collision that is taking place. This is known as attrition. So now what is clear to you? See here, we have done with the three processes: deflation, abrasion, and attrition, and I've drawn little bit of rough diagrams which you can draw in your examinations also. Clear? Okay, let's move ahead. Though the rains is scarce in desert, but it comes down torrentially in a period of time, and the weather debris in desert is moved not only by wind but also by rain and rain also. What happens is sometimes you know that obviously the frequency of rain in the desert is again very low, very rare. But when it happens, obviously it might also be contributing towards the erosion in the desert. So that is what is being said. Why I have mentioned this statement? Because it is very, very important, present in the NCERT. And over there, questions might be asked, which will mix the question that rains can also play a role of erosion with respect to the desert. And that time you might say there is no rain in the desert. So that will be a wrong statement. The right thing is, yes, the rain can play a role whenever it happens. So this is something that is why I mentioned. That is how the UPSC basically picks up certain statements from your NCERTs. Now, we have studied a little bit about the wind, the concepts. Now comes the aspect of erosional features, and then I will be dealing with the depositional features. With every geomorphic agent or process I will be taking up, like wind, running water and all, we will be describing a little bit, and then we will be describing what are the erosional landforms or the, let us say, depositional landforms that are created by them. This is what we are going to study. Clear? So first, erosional work of wind and the landform. So first erosional landform that is formed by wind I've mentioned is deflation hollows. You know the process of deflation. Deflation basically means picking up or lifting up of the particles that are present on the surface and taking them away because of the velocity. Now let us assume let's see, supposingly this what is marked in red, marked in yellow, basically is relatively harder rock. Let us assume this part is what? Harder rock. This is supposingly, this part is, let us say, softer. This whole part is softer in nature. Obviously, you know that because of the extremes of temperatures that happens in the desert, there will be cracks that will develop. Now, what happens is when the wind is flowing earlier, when there are no cracks, there might be little erosion on the surface, but insignificant from the perspective. But as certain, let us say, cracks develop because of the variation in the temperature, certain particles might be present here. So what will the wind do? It will further help it. It might pick them up, and slowly picking up will lead to the softer part being eroded. Slowly what will happen, as further this process continues, further erosion will take place. Now, that is why it will get deeper and deeper and deeper. That means depression formed in the desert due to the removal of sand by deflation. And you know what deflation is. So this is a absolute or a very important diagram that I mentioned that is handmade. You can just take the screenshot or pause the video and copy the content, right? Okay. Hopefully you have done that. Now, this is the deflation hollows. First, let's possibly have studied also. You studied deflation. Deflation hollows is an outcome of that. Second is mushroom rocks. Now, this is something very important you need to understand. Over here, the concept of sand blasting becomes very, very important. You have studied the process, sand blasting. Now, see, rocks having broad upper part and narrow loose resembling an umbrella or a mushroom. These are mushroom rocks. Firstly, you should understand why they're named mushroom rocks. It is because of the shape. This upper part is broader and the lower part is narrower. That is why it is known as mushroom rock. That is first as an understanding perspective why it is known as mushroom rock. But the important thing is how it is formed. See, most of the cases when this part, let us say, is harder rocks. If it is harder rock, it is difficult for the wind also to erode it. Now, supposingly, please understand, as I have taught you over here, this was supposingly the initial surface of the, before it was formed as a mushroom rock. Now, this part supposingly is hard rock. This part supposingly is what? Hard. The other parts are softer. So, when the wind carrying certain sand particles basically move, when they will encounter a harder rock, it will be difficult to erode it. But those which are softer in nature will be easier for the wind also to erode them. That is why what will happen is, when the wind supposingly is blowing from this direction with certain sand particles which they are carrying, this part is again what? Softer in nature. They will be eroding it at a greater pace, right? A greater pace. This part also, but this part is harder, that is why they're not able to erode. Further over here, this is also hard, they find it difficult to erode. What the outcome basically is that a shape of this sort is formed. This is because of, again, sand blasting processes that are taking place. And this shape, again, if the hard rock is not present here, then obviously the shape of this sort will not be formed. It depends also not only on the processes that they are undergoing, but also the nature of the rock. Over here, had the soft rock been present here, this would have not been broader in nature. That is why mushroom rocks are again ones which are broader on the upper part and narrow in the lower part. Slowly, what will happen if the erosion process goes on? This will further become thinner, and finally it will not bear the burden or the weight and will fall down. That is why when you see few boulders of a rounded shape that are present in the desert, you can imagine it that they used to be mushroom rocks probably few decades ago. So this is again an important thing. I have mentioned two more words. Now, this is not mentioned categorically in the NCERTs also, but I have mentioned because this has been asked in the PCS papers and long time ago in the UPSC Civil Services Prelims also. There is an alternative word. These are also known as pedestal rocks and these are also known as pilsfen. So now, this is again very, very important. These two words are very important. Now, another word is inselbergs. Now, inselbergs is a residual hill or mounds, relatively resistant rocks in the arid region. You would have seen very often in certain arid region, these are small mounds that are present. Now, other parts, let us say the erosion process is taking place. Other regions, other parts within that particular region, which was softer rock, relatively got eroded at a quicker pace, and they lost their existence because again the sandblasting processes that were going on that basically led to the erosional activities of the softer rocks. But there will be certain parts which are relatively of resistant or harder rock. They were not eroded properly. So now what it remains, let us say this is again a desert region. These are small mounds that are present. These are because of the harder nature of the rock, and they were more resistant to the wind erosion that was taking place. That is why it appears like these small mounds that are present here. This is an outcome of the erosional activities that have been taking place in the arid region. So you can mention here or draw this also. Take a screenshot, or obviously you can note it down, pause the video also. Okay, let's move ahead. Demoiselles. Demoiselles. Now, demoiselles again are very interesting features. Whenever you go to certain arid regions, you will come across these features, not necessarily in all parts of the country, depending upon what type of desert it is. Right, now see, represents rock pillars having relatively resistant rocks at the top and softer below. Now, these are the types of structures that are basically formed. Again, relatively eroding more of the softer rock and harder to erode the one which is resistant or harder in nature. So that is why sometimes what happens, these types of structures are formed where these are the softer rocks and there are pillar-like, and some hard rock structures are present on the top. Later on, you will realize that these pillars will also erode and they will fall down, right? But these have been formed which are very unique in nature because there are like a pillars that are there, and on the top there are hard rock surfaces that are present. So these are known as demoiselles. That means rock pillars having relatively resistant top as well as softer bottoms that are present, and which themselves being pillar in nature, right? Okay. Please copy it down. Please copy it down. Now, next is Zeugin. Zeugin. Now see, a rock mass of tabular form resembling a capped inkpot having horizontal stratus of hard and soft rock. What happens is, bache, see, sometimes what happens, this is due to the relative erosion because of the hard and soft nature of the rocks. Sometimes what happens is these ink-like pot-like structures are formed. Some rocks are more resistant, some are less resistant. Which are less resistant, they will be eroding faster. So due to this relative erosion processes that take place, there might be an instance where such structures are formed which represent like a ink pot like. So these structures, when you see, these are known as Zeugin. Zeugin. So you can just copy it down. Okay, let's move ahead. Yadangs. Now see, yadangs. Over here, these are generally formed over here where you would see that alternative bands of hard and soft rock are present. Let us assume these yellow part are hard rocks and the white, this part is a softer rock. Obviously, when the wind is going to erode, it will be eroding this softer rock faster than the harder rock. So that is why a depression like structure will be formed because of the softer rock structure being eroded by the winds. So see here, steep sided, deeply undercut, formed by alternative bands of hard and soft rock. So this is an outcome. This was the initial surface that was there. This was basically eroded. This erosion took place and resulted in this structure. Clear? Copy it down. Okay. Now this is again two very important words, pediments and palayas. Now, supposingly, this is a rock structure, a mountainous structure where erosion is taking place and certain fine particles are falling down, right? Right? Now, see, erosional plains formed at the base of the surrounding mountain area. So, those erosional plains that are formed, which are surrounding the mountainous region, those are known as pediments. So, this is a mountainous region. Due to the erosion, there are a lot of sediment-like structure that are present here. These are known as pediments, right? So, I've drawn them also. This green color structure is pediment. Next come the word palayas. Now see here. First understand this, then I'll tell you. It is a flat bottom, low-lying desert basin. So this part is a low-lying desert basin. This is the mountainous region. Along with them, you have the pediments. You go further. Then you have a basin-like structure. Again, this basin means somewhat like a saucer shape, where this structure is present, which is known as palayas. Now what happens here is that temporarily holds water after rainfall, but usually remains dry for the most of the year. What happens is, see, pediments are present here. Obviously, sometimes when it rains, because it is a basin-like structure, so over here, palaya or some water will be present here. Later on, it will dry, or automatically later on it will form like a salt pan-like structure, right? Salt pan. But when water is present over here, this is the region where water will be present. Now, this is again that is why we have said it is a flat bottom, low-lying basin that temporarily holds water when there is rain. Otherwise, it is dry, acting like a salt pan. Now, between both of them, the region that is present is known as bajada. Between the palayas and the pediment region, the region which is mentioned is known as bajada. So, bajada is a region between the palayas and the pediment. This is something that you should be aware of because it can be asked in your preliminary examination in particular. Clear? Okay. Let's move ahead. See, when this is from the perspective of NCERT, that is why I am limiting here. This is basically formed by wind as well as fluvial erosional processes. Fluvial, that means water is also playing an important role. When we do the advanced concepts, possibly I can tell you the processes also and go through that. We are not going to the advanced processes with respect to the formation because that is not required, first of all, because you're not doing geography optional. You're doing for general studies. So that is why you just need to be aware what these are and what are the name and what are the definition, what is the concept. That is what you should be aware of. I can very well go into the explanations of how they are formed, but that is for geography optional students, not for general study students. Clear? Okay. Depositional work of winds and landforms. Now, over here till now, you have done all the erosional aspects. Now comes the depositional, right? See here. Quickly. Let's see the depositional aspect. Now, depositional aspects basically involve the sand dunes, the loess. These are the two major things. But within the sand dunes also, you have various types of sand dunes. Now, these questions have been asked in the prelims also. And in previous examinations, repeatedly these questions are asked. Particularly what the shape is. Now, sand dunes, when I talk about it, basically refers to heaps or mounds of sand. And those mounds and heaps of sand are arranged in various ways. And because of that, they are given various names. Now, within the sand dunes, there are a lot of names which are used. This is mentioned in the NCERT also, and I have drawn the diagrams over here, hand-drawn diagrams, so that you understand it. Barricans are basically what? They are crescent-shaped dunes. Now, the important thing is, in the barricans, this pointed edges that are present are away from the direction of wind. Now, you need to understand it is not flat. This is an elevated structure. What does this mean? This means that there is an elevation and there is a decline in the elevation like this, right? Right? So it is in this way, it is declining. If you see from the sideways, there will be a decline in the elevation. Now, wind is moving in direction and these two limbs are formed, which are again opposite to the direction from which it is coming. Clear? Now see this. Because this is the direction, so these limbs are not facing the wind. It is in this direction, right? So next thing is parabolic dunes. Parabolic dunes are reverse of barricans. That means these two limbs are going to face the wind directly. This is also in an elevated structure in this way. So parabolic dunes are reverse of the barricans, right? Next comes Seaf. Now, Seaf is again, please understand, it is absolutely similar to barricans, but the only thing is that in a way, its one limb is missing or very small. See here, if I complete this part, another limb of this, then it will be a barrican. But over here, do you see another limb? No. It is similar to barricans with a small difference that the Seaf has only one wing. That is the important thing. Barricans, these are barricans, these have two living wings. This is what is a limb? This is a limb. This is a limb, right? Over here, do you see another limb? No. So, Seaf are barricans with only one limb. Otherwise, everything is same. Over there, the direction of wind is in this way and the limb is in this direction. Everything is same. The sieve is like a barracan with only one wing or limb, right? So these are three types. Let's move to the further. Longitudinal dunes. Longitudinal dunes. Now this is what? The sand dune that is present, right? And this is the direction of wind. Now see here. These are formed when the supply of sand is poor. That means the sand that is present is of lesser quantity, right? Supply of sand means lesser amount of sand is present. And the wind direction is constant. Second, see, these are two conditions. That is why UPSC can ask you these things with respect to longitudinal dunes. Answer the following questions. They will pick up directly from the NCERT, and that particular time you'll say from where the questions have been asked. Firstly, please understand, where the supply of sand is poor, that means lesser amount of sand is present, and the wind direction is constant, that is moving in one direction only for a very long time. They appear as long and of considerable length, but not in great height. Please understand why they are in one constant long length, because if the wind is in a continuously same direction, so there's a greater possibility of them being in long length, because otherwise if the direction keeps on changing, that length will not be long, right? So this is what is the structure. Please understand this. Okay, next, transverse dunes. Now the transverse dunes are aligned perpendicular to the wind direction. The wind direction is constant. Now wind direction is flowing in this way. Now these are perpendicular. These are elevated from this side and these are not elevated from this side. In a way, if this is a structure, if I turn this, it is going to be like this. This part is an elevated part. This is where the wind is coming. So wind is coming, so this will make this particular part what? Flatter or gentler in slope, right? Okay. Next, these are the 5 types of dunes that you should be aware of. They have been asked repeatedly. They will be asked in your prelims as well as in your mains. Loess. Loess represents a thick deposit of unstratified, well-sorted, fine-grained sediments. These are again very simple concepts. This have been asked in prelims as one of the questions. That's loess is associated with which of the following processes? There was glacier, there was wind. So it was a very simple question. It was asked in the prelims also, right? So these are the factors which are associated with the depositional and erosional features of the wind, and the wind as a whole we have studied. Now comes the concept second, geomorphic agent, as well as the processes, because these involve a lot of process also. They are themselves agents also, because they are involved in erosion also and deposition also. And obviously they're transporting also. A glacier. What is glacier? Moving ice mass downslope under the impact of gravity is a glacier. This is something very important. Under the impact of gravity, right? So the moving ice moves downslope under the impact of gravity. It is glacier. Now please understand, 10% of the Earth's surface is now covered by glacier. This is also something that you should be aware of, because these are small tidbits which are asked in your papers also. Now we had studied the aspect of erosion by wind. Now let us see the erosion of the glacial erosion that takes place is basically from the 2 processes which are associated with it. Now these 2 processes you should be aware of. Why? Because these can be asked themselves also in the preliminary examination. First is abrasion. Second is plucking. See here. Let's see. Abrasion means it is a process by which rock fragments and debris in the base of the moving glacier scrape and grind and polish the underlying beneath surface. It is something very interesting. Now see here. Supposingly this my left hand is a glacier. This is the underlying surface, right? Now the glacier slowly, because this is sloping downward, it is slowly going to move on this surface, right? And on the surface will be present a lot of rocks and other types of fragments, right? So that is why if you see, process by which rock fragments and debris in the base. Now in this process, basically it is going to grind them, it is going to polish them. Polish, why? Because it will make them more smoother. It might plug them also, and it is going to move further down. So abrasion is a process by which rock fragments and debris in the base of the moving glacier scraps, grinds and polishes the rocks or the debris that is present in the surface or the ground surface, on top of which the glacier is moving. Clear? Now see, plucking. Now plucking is a process whereby the moving glacier pulls away the churns of blocks and fragments from the bedrock. See, abrasion is associated more with polishing and grinding. Obviously, there are certain elements of removal also, but they majorly focus on the concept of grinding and polishing. Plucking as a process is a one, which means while the glacier is moving down slope, it is going to pick up a lot of materials from the rock surfaces or debris from the underlying ground surface. This is known as plucking. Now, when the glacier is moving, both the processes are taking place together. Plucking also is taking place and abrasion is also taking place. So, you should please note these two things down. Please pause the video and you can note it down. Okay. Let's move ahead. Erosional work of glacier. Now see, if I see the erosional work or the erosional landforms that are formed, over here is U-shaped valley and the hanging valley. Now please understand this. This is a valley which you see, let us say, the glacial has, let us say, receded, right? And you see this valley that is present in very colder regions when you go, and you see how come these valleys are formed. These are valleys basically formed because of the movement of the major glaciers. Glaciers are moving down and they've eroded the underlying surfaces and all. You have seen the processes, majorly plucking also. So the cross section of the glacial valleys or glacial troughs of the mountain glaciers. So this is where the glaciers are moving. It had basically eroded this particular fragment of rocks or the ground surface, and it has created this particular structure. And this is known as what? U-shaped valley. Second thing comes, like you see a tributary joining a main river. Similarly, there might be other small glaciers will be joining the main glacier. Now, because there are smaller extent, so what happens is sometimes they are moving like this, but there's a height difference. See, this is the height difference. Because right now the extent of erosion of this particular glacier earlier on, now the glaciers have receded. Please understand. Now the glaciers are receded. Though you see the hanging valleys now, na? They have receded now. But the thing is that over here also, let us say a smaller glacier would have eroded this. And why it is called hanging? Because the U-shaped valley is at this level. The U-shaped valley is at this level. And this is approximately at this level. The base of this. So it is looking like a hanging valley above the U-shaped valley. That is why it is known as hanging valley. And this is done by what? The smaller glaciers which was trying to join the major glacier. So a valley of tributary glaciers which join the main glacier at much greater depth. So this U-shaped valley is of a greater depth. This is of a lesser depth. Slowly, what would have happened? If erosion would have continued, possibly the depth would have increased, but by that time, the depth of this would have also increased because this is a major glacier. So when you see this, you see a hanging structure that is formed. Clear? Okay. Next, circuits. Now please understand this. This is something very important. You should understand also. Supposingly this was a mountainous structure earlier on. Let us see this. Initial, this sort of structure was present and the glacier was moving on top of it. But you will realize that the glaciers, when they are moving down the mountain slopes also, they are eroding the mountain slopes to a very great extent. Because of these erosions, it might result in a scenario where such depressions or hollows are formed because of the glacial erosions. As I've said, this was the initial surface. The glaciers were moving on top of it. Slowly, the erosion took place. Slowly, this depression actually became larger, and slowly it reached this stage. So, this particular structure which you are seeing right now with this depression is known as a cirque. A bowl-shaped hollow formed at the head or the source of the glacial valley. It is formed by the glacial erosion where the glacial originates and accumulates. So this structure is known as what? A cirque. This is formed due to the glacial erosions, right? So this is something very important. This has been asked in the civil services multiple times. Now see, there is another very important word, erete. Erete. Now supposingly, as one glacier is moving down here, another glacier is moving down here. Supposingly, one glacier is moving down in this direction, other glacier is moving down in this direction. Both will be creating their own erosional features. So what happens when two circuits cut down backward in the opposite direction? A knife edge like range is created. Now the circuits are moving down. See, two glaciers are moving down. They are eroding the structure beneath them. This is eroding the structure beneath them. So between them is a region which is basically sharpened. This is a ridge-like structure which is known as errate. It is an outcome of the erosional activities of the two glaciers that were moving down. So two glaciers are moving down here. In that process, erosion is taking place, and the part is sharpened, and this is known as an errate. Next, horn. Now please understand, supposingly this is a mountain, and here also there's a glacier, and here also there's a glacier. Let us see this. Let's assume initially supposingly this was a mountain. One glacier is present here moving down, another glacier is moving down. Slowly, again the similar thing will happen. Cirque formation will take place. And because of this horn-like structure is formed. This is known as horn. A pyramidal or triangular faceted peak formed due to the recession and intersection of three or more glacier circuits will lead to the formation of what? A horn. So it is not necessary 2, it might be 3, 4 also, but depending upon the scenario. So this is a pyramidal like structure which is formed at the top. This is known as horn. Clear? Okay, write it down quickly. Quickly write it down. Okay, let's move ahead. Crag and tail. Now this is again very important. This is again not these types of some of the features are not present in your NCERT, but they are important. They have been asked in a lot of examinations also. Please imagine that this particular thing is what? A volcanic plug. You have already studied a lot of landform features. You have studied the internal intrusive features and all with respect to the volcanoes, where we had told you that there are a lot of volcanic plug-like structures can be formed because of the deposition and cooling down of the volcanic magma, right? So this is like a volcanic structure found out of solidification and crystallization of, let us say, the magmatic material. Now what happens is the glacier is moving in this direction. Now for the glacier also to erode a hard rock is difficult. You know that very well. It might have eroded a lot of substances which it would have come across. Other rocks also, sedimentary rocks and other metamorphic rocks which are weaker in nature, they might have eroded it very easily. But when it comes to some of the hard rocks, particularly the granitic rocks, then it becomes difficult to erode. That is why what happens, this particular volcanic plug, now see, when the volcanic plug offers resistance in the flow of the direction which has steep side formed due to erosion is due to crag. Now, if you see over here, this particular thing is, let us say, the deposition. The glacier is moving and whatever material was present here is eroded because that was of softer nature. And what is seen or visible is this particular part, which is of a steeper nature. This is known as the crag. On the other hand, because when the glacier moves down this side, it is going to deposit the substances which had picked up earlier on. So over here you will see a tail that is formed because of the deposits that are created. This is of gentle slope. Now this is known as a tail. On the other side, being sheltered by the glacial ice becomes elongated, having gentle slope because of the deposits that have been made. Or, please understand, there is another scenario. Or, because this is basically sliding down, so that is why it is shaped in this way. On the other hand, the glacier directly encounters it, so it is in steeper form. Both the reasons can be there. Either due to deposits or because the glacier is moving down, so it will lead to a gentler slope. But over here, because it is directly encountering the volcanic plug, which it cannot directly erode because it is of harder nature, so it is somewhat a steeper nature. So this is known as the crag and the tail, formed due to the erosional features or erosional outcome of the glaciers. Clear? Okay. Ford or chford, as you can see or mention. Now this question has been asked in your mains examination also. A very simple thing. let us see this. I made the diagram also. These are glacial troughs which have been occupied by sea. In fact, fjords are the arms of the sea which have occupied the U-shaped glaciated valleys, common in Norway, Alaska, and New Zealand. Now, please understand. Can I assume these are the, let us say, these are erites that have been formed, the glaciers are coming. Can I call this as a U-shaped valley? Or later on, this is right now U-shaped valley. Later on, when the glacier is going to recede, we can see them as a U-shaped valley, right? These are going to form later on, let us say, like hanging valleys, right? Now, see over here very categorically, when the glacier is present, this is possibly the shape or something that will be visible. Later on, when the glaciers have receded, you will see somewhat of a river might be flowing. Now, what happens is when the U-shaped valley has an ingress of the sea or the ocean, remember, this was a glaciated valley or the troughs, a glaciated valley that was present. Now the glaciers have receded and it leads to entry of sea. It might happen due to various reasons. Let us assume that there is, let us say, little bit rise in the sea level. It might not happen automatically. Supposingly, this is a structure that is present and there is a rise in the sea level. So possibly the nearby sea or ocean water might enter this and it will lead to this formation. Or due to some tectonic movements, there is little bit submergence of the continental mass or the land mass. Then also the decrease in the land mass level is taking place. So relatively the sea level in a way appears to be higher, so it will enter. This is because of the tectonic activities that take place. Because of the tectonic activities, the U-shaped valley have an ingress of the sea or the oceanic water, and this is known as the fjord, or fjord, whatever you want to call it. This was asked in the examination also, and if you had little bit detail, you could have answered it. This is mentioned in the NCERT. Now, people ignore it, and that is why they were not able to answer those 10, 15 marker questions of geography, because they ignored those minute details. Had you studied that, you would have attempted those questions also very well. Okay. Now, the depositional features or work of glacier. Now, please understand, when I talk about depositional aspects of the glaciers, there are a lot of features that are present here, which I'll show you via the diagram. Now, tills are again till is a very generic word. It is basically unstratified, unsorted debris dropped more or less randomly by glacier. So any unstratified, unsorted glacier that unsortified, or let us say unstratified, unsorted, any type of deposit by the glacier is known as till. Now, this is a very generic term. Now, moraines over here are ridge-like depositional features of the glacier, and they are long and narrow. So, this is more specific because these are ridge-like structures of the deposits that were done by the glacier. Now, these are of three kinds. That is why they have been asked also. Terminal moraine, which are at the snout or the beginning of the mouth of the glacier, this region. Let us say this is the glacier present at the mouth of the glacier or snout, or the nose of the glacier is known as the terminal moraine. Lateral moraine, parallel ridges of tills either side of the glacier. This is the glacier. Now, on this side also there are certain morainic deposits, and this side also there are morainic deposits. These are known as lateral. Medial moraine, interglacial margin of two glaciers. Now, supposingly the two glaciers are moving between them. Let us see this black pen. Can you see? Now, black pen is like a deposition between the two glaciers that are moving down, right? Can you see the pen? Now, this is known as a medial moraine because it is between two glaciers that are moving down. Now, let us see these things in the diagrammatic form. Supposing this is one glacier moving down, this is another glacier moving down. One that is present in this snout, this region, terminal moraine. One on the lateral side is known as a lateral moraine on the sides. Third is your one that is present between the two glaciers is known as a medial moraine. Clear? So these are depositional features that you should be aware of. Okay, let's move ahead. Other are drum lines. Now, you see these are the topics that which can be asked in the paper also now. Now see, drum lines are again very interesting features. Many geographers have also not been able to answer the exact reasons behind it. There are a lot of books that give a different reason, so we'll not go into them. We just have to understand the features of what this basically thing is. See, when you go to certain regions of the colder regions and the glaciers are present, you will be seeing certain structures of this sort are present here. These are oval shaped, elongated, whale back made up of boulder and clay. So you will see one side, this is known as a stoss. This is again a steeper side, and then you have another one that is very long elongated structure. So you have small, you can say it as like a mound like structure, which is from the top. If you see from the top, this is what the top view, side view. From the top, if you see, this is like an oval structure, elongated. From one side, this is the steep side, and this is again the tail. Now, this is basically because of the depositional features that have taken place by the glaciers. So, when you see in the region, you will see it is not alone present. It is present in a group of a lot of such drum lines that are present there. Today also, I'm telling you, there is no exact precise reason that has been found for their how they're exactly formed, but their depositional features, that is clear. How they're formed, that is not clear. So, there might be a lot of such drum lines that are present. If you see it, it will appear like a basket of eggs. That is why it is known as basket of egg topography, especially when they are arranged diagonally. Because when you see in a crate of eggs also, it is appearing like that if you see it from the top or even from the side. So these are basically what? Drum lines. Write it down. Drum lines. Okay, let's move ahead. Eskers. Now please understand what happens is, within the glacier also, when they are picking up a lot of, when the glaciers are moving, they might be picking up a lot of debris and all. So within the glacier also, there will be certain debris or particles that are present within the glacier, that is, it is moving. When the glacier recedes, this part basically what settles down, and this a ridge-like structure is created. A small ridge-like structure is created within this valley. So a long, narrow, sinuous ridge of sand and gravel are generally situated in the middle of the ground moraine. So in the middle of the ground, the valley that is created with the glacial or the hanging valley even, or even the U-shaped valley, you will see a small ridge-like structure. It is known as the eskers. It is because when the glaciers are moving, they had picked up a lot of particles, sand, debris, and this is in this form. Please understand. The glacier is moving down. Within the glacier inside, they have this debris, and when the glaciers recede, those particles basically settle down, and they are in a shape of a ridge. Not very tall, they might be very long, not very tall, but ridge-like structure that is formed. And this ridge-like structure is known as eskers. Clear? Okay. Waves, currents, and coastal lands. Now see, these are again very, very important aspects. When I talk about, we'll primarily be focusing on some of these currents, and because when we do the oceanography chapters, we will be covering them in a lot of detail. Please understand. We will not go into a lot of detail here because you need to understand certain concepts also, which we will be doing in the topic of oceanography. So over here, whatever is mentioned in the NCERT, that we are going to mention. See, waves. Now waves, you know that sea waves you've already heard. Many of you assume that how possibly the waves are created, on the intricacies of how the waves are, what the waves are, how they are created, and all those processes will be done in the oceanography chapter. Here we are dealing with only the landforms. So we will not go into the technicalities of those things, whether some waves are breaker waves, how they are formed, what are the processes, that is in the chapter of oceanography. Over here, we'll just study about the definitions. Oscillations of the surface water. The oscillation travel through the water, little or no transfer of water to the molecules. Now please understand, waves are basically an outcome of the disturbances that take place on the surface of the water or in the water body. If there is a small bowl of water, if you touch the water, you will see certain miniature waves will be created and move outward. Right? Now please understand, those are basically the oscillations that are moving. Water molecules are not moving, the disturbances are moving. So you see that oscillation travels through the water, oscillation motion travels through the water, little or no transfer of water molecules take place because the disturbance that is created, it is being settled down through that. On the other hand, currents are like rivers that are moving in the oceans or the seas. So a continued and progressive forward movement of water, fairly defined direction. Please understand, we cannot go in a lot of detail over in this chapter because we have to study in oceanography. We will just focus on the features over here, right? Okay. Erosional work. Now see, supposingly this is this region, over here is the sea. And obviously the waves are going to come and they're going to crash against the coastal region. Let us say this is a rocky coastal region. Now what happens is, this is supposedly the initial surface. When the waves crash, obviously it will be, a lot of force will come, it is going to erode it. So there will be certain structures will be created. Now if you see, this particular part has flattened because the waves keep on coming, and this smoothing of the surface takes place. This is known as a wave cut platform. The region where this is a lagbag almost a parallel surface that is created, a tall elongated parallel straight surface that is created adjoining the coast. This is known as the cliff, and below the cliff you realize there is an undercut that is here. This is known as a notch. So if we see a very steep rocky face adjoining the coast, this is the cliff. Undercut at the base of the sea cliff, this is a notch, and rock cut surfaces in front of the cliff, this is a wave platform. This is done by the erosional work of the waves. So this is a small diagram that you should be very well aware of. Okay, let's move ahead. Let's move ahead. Sea caves. Now let us assume this. See this very well. This is basically again this is all water here. Here, sorry. Sometimes you will see in the oceans that this structure will be coming out and protruding out. Earlier on, this was actually one part. Slowly as the erosion takes place, this will basically form such structures. How it is formed, please understand. Let us see this. Supposing that this is a part of land on the part of the coastal region which is rocky in nature, certain waves will be splashing around the sides, from this side also and from that side also. So a hole might be created. Now this hole or a hole like structure that is created is known as a cave. Now such hole is being created from the other side also by the waves. What happens is, let us assume this is a structure. From this side also wave is crashing, from this side also wave is crashing. Hole will be created here, hole will be created here. After some time what will happen? Both will basically merge with each other. So what will happen? This is a point where now water can basically come and go from this side. So first process is creation of the cave. The process of creation of cave, the erosion continues. So this part will be continuously eroded. This part will be continuously eroded from that side also, this side also. So in a way, this arch-like structure will later on form. Now, please understand, supposingly the erosion continues even now. The size will possibly increase, and possibly this particular part will fall down. So what will remain is this part. Later on, from erosion continues, it will create smaller part and this thing will be created. So what I'm trying to say is, this was earlier the same structure. Due to erosional activities, this landform is basically moving back. So when I'm talking about sea caves, these are prolonged wave attack on the base of the cliff, creates holes in the regions of local weakness. So because of the waves, these holes are created. These are known as the caves. From both the sides when the holes basically meet each other, it creates a arch-like structure which is known as a sea arch or arch. When the two caves approach one each other and unite to form an arch. So this is an arch. Later on, when this arch falls, this will become an individual structure, and we will study this. These are known as stacks. Clear? Okay. Let's move ahead. Depositional features. Now please understand, these are small features that you should be knowing. See, beach, you should know, temporary or short-lived deposit that of marine sediments is known as a beach. Let us say this is a small beach over here. This is a landform, this is a beach. So basically beach is an outcome of the deposition that takes place, that is brought by the obviously the waves, obviously the currents that come. So these are deposits by them. So these deposition on this side of the coast is basically known as a beach. So these are short-lived because modification continuously takes place. Now, the small deposit of the sediments, this is known as a sand split. If it is in a form of a hook, it is known as a hook split. If there is a small island and this is the main, let us say land, and this is the island. If that island or a land mass is connected with the main land through a depositional feature, this is known as a tombolo. This is known as a tombolo. And obviously, if this internal water land is separated, or let us say a depositional feature is there, this is known as a barrier island, which is separating this particular piece of water body, or a lagoon also. So this is known as a barrier island. So these are the depositional features associated with the waves, and which we are going to study in detail in the oceanography chapter also. Next comes karst topography. Now this is something very, very important and very interesting also. This is generally not taught to the students. Students do not study them, but this is very important from the civil services examination also. Now, when I talk about karst topography, this basically refers to the chemical weathering processes that take place in the region where limestones are present again, right? So these are landforms produced by chemical weathering or chemical erosion of carbonate rocks, mainly calcium carbonate and magnesium carbonate. Or calcium carbonate is CaCO3. Calcium carbonate is CaCO3. And magnesium carbonate, which is known as dolomite, by surface and subsurface water. Now over here, the role of the surface water as well as the groundwater plays a very important role in creation of such structures which we are going to see. So these are landform structures that are formed by the chemical weathering processes when the chemical erosion of the carbonate rocks takes place, particularly the calcium carbonate and the magnesium carbonate, because of the surface and the subsurface water. This is known as a karst topography. Now see here, there are certain essential conditions that are important. Now this can be asked in your examination directly, in your mains examination and in your prelims examination also. Now please, just before I explain them, see this very well. These are the structures which we're going to see also. Supposing that this is a huge landmass, before anything was created, these are beds of limestones that were present here, right? Calcium deposits that were here. So these are, if there are a lot of joints that are present, water can seep through them. So a lot of things you need to understand. When I'll explain them, I'll come back to this again, a hand-drawn diagram. Because certain essential conditions are important. If they're not fulfilled, you will not see such structures being present everywhere in the world. Why did this karst structures, you are very commonly seen in former Yugoslavia, because from there the word karst has come up, because all the conditions are being met there. So if you want to see such structures, which is a representation of karst, and over here depositional features also you'll see. This is within, inside, and this is again outside. So what are the essential features for that? The thing is, limestone must be massive, large. That is why you can see large structures. Thickly bedded, that means a lot of stratas are there, and well joined. So these all features are very important. Position of limestone should be above the groundwater. If it is below the groundwater, obviously everything can be dissolved and such structures might not be formed. Limestone is widely distributed both in the aerial and vertical. That means it is great size or a larger size. Carbonate rock should be present very close to the ground surface so that rainwater may quickly infiltrate into the beds. This is an automatic obvious reason. Limestone should be highly folded, fractured. So when it is folded and fractured, it basically leads to a lot of formation of infiltration, and where the water is infiltrating, along with a lot of new landforms which we see over here, can be very easily created also. So these structures can be formed because they're folded and fractured also. So ingress of water through the rainwater becomes relatively easy also, because to the joints certain fracturing is done, so that is aiding the process of creation of the karst topographic structures. there should be enough rain. If there is not enough rain, so from where will you get the water? Again, subsurface water will be impacting to a certain extent, but rainwater is again a very, very important feature. So these all features which I mentioned here, 6, are essential features for the karst topographic structures to be formed. If these features are not present in regions, in spite of the fact that limestone is present, you will not see such structures. That is why you see that in spite of the presence of limestone in various countries, such features are not present everywhere because of the non-presence of the following or the above mentioned features. Let's move ahead. Erosional features. If you see such structures over here, you will be seeing in this structure, you will be seeing something known as Laplace. Highly corrugated rough surface of limestone lithology characterized by low ridges and pinnacles. In these karst topographical regions, you will be going through regions where a lot of pointed things are present of limestone. These are known as pinnacles, which are top. So this structure which we see over here is known as Laplace. If you see, this is a surface. This pointed things are pinnacles, and this rough surface which we see over here is basically referred to as Laplace. Sinkholes, swallow holes, dolines, collapsing, ovalas, and pulges. Now, this is something very important because these are more to do with, let us say, the size also, relative sizes. Sinkholes, chemically active water dissolves limestone carbonate and forming small holes. Now, what happens is, because water dissolves in the limestone over here, and small holes are created, and these small holes are like these sinkholes. This is a small sinkhole that is created here, right? Now, after the sinkhole, you say there's a concept of swallow holes. Closely spaced sinkhole combine to form a larger hole. Now, if few sinkholes are together, they together combine to form a larger hole. So that means it a outcome of the combination of a lot of sinkholes that leads to a larger hole, which is known as a swallow hole. So can we say this is a larger swallow hole? Possibly what would have been here? There would have been one sinkhole here, one sinkhole here, one sinkhole here, and together they just combined, and a larger hole was created, which is known as a swallow hole. Clear? So this is another statement. Next, dolines. Swallow holes may further enlarge into large depressions form dolines. Now, dolines are larger depressions when you compare it with what? The swallow holes. So can we see here? So where are the swallow holes? Dolines. Dolines are here. Dolines are much larger than the swallow holes. So you can say very large size swallow holes can be known as a dolines. Now, when we move further, collapse sinks. Solution holes formed to collapse of the upper surface because of the formation of cavities. Sometimes what happens is the fall of the upper surface because of the dissolution process is known as a collapsing. So solution holes formed due to the collapse of the upper surface because of the formation of cavities below the ground surface. Now, this is again we will be seeing in the internal processes also. Over here, please understand, every word that is present over here becomes important because this has been asked. These 2 points have repeatedly been asked in the mains exam, prelims examination also. Now, when we talk about ovalas, ovalas basically refers to extensive depressions up to 1 kilometer across. So that means a huge area, very large area, much more larger to an extent that it might vary to 1 kilometer in, let us say, length. So those are known as ovalas, and much larger than ovalas are the pulges that are even larger than them. So when we see over here, see, ovalas are much larger, and beyond them below are the pulges. Clear? Pulges. This is being represented over here. Clear, everybody? Done? Okay. Now comes the caves. If you will see, there will be again certain structure that are present. Because of the limestone structure, there will be certain holes or cave-like structures that are present there. You will see they are void of large dimensions below the ground surface. So these are large structures that are present below the ground surface. These are known as the caves. These are known as the caves. Now, vertical pipe that connects the cave. Now, this is a cave, and these are pipes that are connecting the cave. These are known as ponodes. These are known as ponodes. Clear? Okay, let's move ahead. Depositional features. Briefly, you should know and understand them also. See, slowly as limestone is dissolving with water, this small droplets will be going down, and this will solidify. These are known as stalactites. And after the water droplets are dropping down, they will be collecting here and they might form a structure over here also. These are known as stalagmites. Stalactites and stalagmites. How you will remember? Stalag G for ground, that means from the ground level it is rising. These are other stalactites. Sometimes both these features combine to form, supposing this is moving down, this is moving down, they combine. This is known as a pillar. There can be a group of stalagmites over here, which are known as compound stalagmites, and this is a cave floor. Obviously, there can be a cave pool also because the water has assembled over here. So this is known as a cave pool that is present inside. Okay, see here. Stalactites formed by the deposition of calcareous solutes which are carried by water dripping through the cave ceiling, formed by the deposition of calcareous solute formed on the clay fold. Pillar when the stalagmites and stalactites basically join, as I've explained you. Okay. Okay, now running water. Now please understand this. Running water, when I'm talking about, is a very, very important perspective over here. We all know what running water is, but there are certain concepts which I would like to explain to you, because this is a very, very important part and integral part of your conceptual clarity of running water. You know that very well. Now see here, let's see. You know that there are various stages present, right? Young, mature, and old stage. When the river is basically moving down from the mountainous regions, you will see a lot of different landforms are created, right? As you just at the start of the mountain, you see, you will be seeing V-shaped valleys. When you go to the mature phase, you should be seeing U-shaped valleys, and so on and so forth. We already know that also. We study that also in our schools and colleges. But the important thing is, we know one fact is that when the river is moving down, this river is eroding, right? Right? Agreed? But the question that arises is, till what level will this erode? Supposingly, a river is moving down on certain surface, let us say any region also. You say the river will be moving and will be eroding the sides also, particularly the grounds also, the bed also, the river bed, which is known as a river bed. To what extent it is going to erode? This is a question that has always come across many candidates and they're not able to answer it. Please understand this. That is why the concept of base level comes. This is something that you should understand. You know that this river over here will like to erode. Do you realize everything that I mentioned here, all these three things? The river in these stages, relatively, yes, obviously the erosion will be more, greater tendency, greater force, here will be very less, minimal. But river in these stages relatively would be eroding the ground, or let us say the river bed. Till what level it will erode? So that why the level till which the maximum level, or the level till which the river will erode is the base level. What is the ultimate base level? The ultimate base level is a sea level. Can a river erode beyond the sea level? No, because that is the maximum extent that it can erode. Now, locally also you realize the groundwater at the local region. Now, if I am standing in some region of NCR, The sea is very far off, but do you realize there is a concept known as groundwater? Now, groundwater is present. Groundwater also acts as a local level, base level for us. Beyond that, the river will not erode. If the groundwater level falls or the local base level falls, the river will further start eroding because it wants to again meet the region of the base level so that lesser energy consumption takes place. So, in order to achieve that, it is continuously going to erode. Now, water surface, please understand, local base levels play a very, very important role. That is why in the regions of Kashmir, you will be realizing that though it is in the mountainous region, various rivers are meandering. Why are they meandering? Because of the base level, local base level aspects that are present here. Now, please understand, the local base level is again associated with the ground level, but the ultimate base level is the sea level, beyond which the river will not erode. So, the ultimate base level sea level. Groundwater influences the local base level. This is something that you should understand. If supposingly due to some reason groundwater level rises, the erosional capacity of the river around that region will decrease. It will not erode further. But if that base level falls down, it will again start eroding till the level it reaches the base level. So this is the concept of base level that you should understand. The ultimate level, base level is the sea level. Local level is obviously influenced by the local factors and obviously the groundwater present at that particular region. And that marks the erosional ability of a particular river also. Now, if the base level over here is, let us say, further moves down, more erosion will take place. That is why you realize finally when the river merges with the sea, that is the ultimate base level that ends. So till any river reaches the base level, whether it is a local base level or the ultimate base level, which is the sea level, it will try to erode. It depends upon the erosional ability, depends upon what is the speed, what is the velocity, what is the nature of rock, type of rock, how it is jointed, what is material it is made up of. All those factors influence. But tendency is this, which I've explained you. This is something that you should be a little bit aware of and something that is important. Clear? Now comes the aspects of erosional features as well as the depositional features by the rivers. If you see the river valleys, if you are in the young phase of the river, you will see there will be V-shaped valleys that are formed. When you go to the mature phase, you will be seeing the U-shaped valleys are formed. So, river valleys again are a long, narrow depressions on the earth's surface which have been carved out by the erosional activities of a river over the time. Yes, so this is basically known as the river valleys. So, this is basically present in the young phase. This is present in the mostly in the mature phase of the river. When you move further, waterfall. Now, waterfalls are created because of the erosional activities. Now, please understand. A lot of erosion is taking place. Now, what is waterfall? Waterfall is a steep descent of the river or stream over the vertical and nearly vertical drop in the course. So, this is again over here, please understand, a drop in the course is taking place. There are a lot of other features through which a water fall can be created. It depends. Now, let us assume hypothetically, if supposingly this was the original topography. And supposingly erosion has continued and slowly, let us say certain parts have been eroded which are a softer rock. Now, because of that erosion, now water is falling from certain level. Slowly, this will further erode backward and which is softer rock will further be eroded. So, there are waterfalls can be of 50 categories, but some of the other way you can say they are related to the erosional activities. Now, slowly when this erosion will take place, supposing this will end, this will further fall. So, this waterfall is again it basically refers to a steep descent on the river or river stream over the vertical, where nearly vertical drop in the course takes place. With this aspect, please understand, at the base of the waterfall, there is a pool that is created that is also by the river because of the force which it is falling. This is known as a plunge pool. Over here again, movement of particles take place. So it is a deep circular broad bowl shaped depression that is formed at the base of the waterfall. This is also a erosional feature that is present. River terraces. Now please understand, river terrace is a very important aspect. These are terrace-like, step-like structures that are formed. If you go to Grand Canyon and all, you will be seeing such step-like structures will be formed where a Colorado River is moving, right? How does this happen? Please remember, initially this was the surface. The top was the surface. When there is further fall in the base level, erosional activities will increase. Further base level will fall, so further deep cutting will increase, and this is the level where it will reach. So please remember this. This is basically referring to the erosional activities and how the base levels have changed, and that is why this was the initial surface, right? This was the initial surface on which the river might be moving. Let us see here. Let's see here. This is the original surface. Let us make a simple diagrams for you to understand. Supposingly, a river is moving on this flat surface, right? Now, when the river is moving, it is eroding the surface. When it is eroding the surface, automatically, what will be the next step? If supposing the base level further falls, this is the path where it was eroding. Now, this is a staircase because of the erosional activities, that are taking place. This is the meandering action because of which it will further move down. And because of this, this part will appear elevated. What? This part will appear elevated. Now, further, if you see further the base level falls and further erosional activities continue, what will happen? Further it has gone. So such piers are created. This is because of the erosional activities and the meandering action or zigzag movement of the river. That is why. And along with it, yes, as the base level moves down, further that will provide more energy or better as a potential for a river to more erode more the ground surface, and that is why it will move down and such terraces will be created. So in either side such terraces are created. These are known as river terraces because of the erosional activities. Next, incised meanders. Now you have very well known what is meandering of river. You see, the meandering of rivers generally takes place in the old stage because at that time you realize that the steep slope is no more present and the speed at which it is flowing also is very less. So that means load is more. So that is why there is meandering of river that is taking place. Now, when the meandering of rivers take place, the problem that arises is that in certain cases, such type of structures will be created, particularly when the region has a rocky terrain. So what can happen is, see, if it is in a rocky terrain where river is meandering, but you will see that it will lead to it basically cutting the rocky surface also. So this will be known as an incised meander, right? A meander or riverbed that is deeply cut or entrenched in the bedrock or valley floor due to the downward erosion of river. Now, please understand, such types of structures, if you see in certain regions in Europe and even in the Kashmir region also, there are certain parts where this is visible because the rocky terrain is present. Obviously, that is influenced by the local base level. If you see in the deltatic region, obviously it is not very easy to be found unless and until there are coasts which are associated with a rocky type of coast are present. Only then it can be visible. But otherwise, if you see, these are basically representation of the fact that there is an imprint of the movement of the river on the rocky surface because of the meandering action influenced by the local base level. So this is known as incised meandering. Clear? Depositional work, natural levees. What happens is normally when the river, this is like the river flowing through its channel. When the river is flowing through its channel, you will realize that it carries a lot of sediments also. sometimes when it floods, the level rises, so the sediments are deposited on the sides. Now, these deposition on the sides are known as natural levees, right? See here. Raised embankment made up of coarse sediments, mainly sand and silt, that form along the both sides of the river channel due to repeated flooding and deposition is known as natural levees. Please write it down. All of you write it down. Write it down quickly. Done? Okay. Now, next, delta. Delta. Delta, you know that very well, associated to the coastal regions where you see that deposition of a lot of sediments take place in the final stages. Now, this is supposedly a river and deposition is taking place in the form of delta. Now, the depositional features almost in a triangular shape at the mouth of the river that is entering the lake or a surface or ocean or a sea. So, this is known as a delta. Now, because delta word is derived from a triangle, it is not necessarily triangle, it might be of various shapes, various types. Deltas themselves are of various types. So, this is just a representation over here. Next is the concept that is present in your NCERTs is an alluvial fans and cones. Now, what happens? Due to the accumulation of material at the base of the foothill, there is drop in the channel gradient. Now, sometimes due to the steep drop in the channel gradient, the rivers that are carrying the sediments are deposited just at the base of the foothills. Now, they can be seen in the form of a fan, that is why they are known as alluvial fans, or sometimes a cone-like structure is formed, alluvial cone. The difference between them is alluvial fans are associated with gentle slope than cones. So, the fans, alluvial fans will have a gentle slope, cones will have a sharper slope. Alluvial cones will require more debris, but fans will require relatively lesser debris. So, these are again two which are mentioned in your NCERT, so we have covered them. Clear? Okay. These were the important factors or the features that we have done over here, and hopefully you enjoyed them. Hopefully you learned a lot of features. Obviously, there are certain other aspects also which are associated with the oceanography and all. We're going to cover them in the chapter of oceanography and deal with the ocean's currents in that particular chapter. So, whatever you have learned them, I will request you to please revise them properly, understand them well. These are very, very important from the perspective of your civil services examination. All the diagrams have been made by hand. So, please continuously revise them and make the best use of it. Take care, and as we say at the end of the lecture, Jai Hind, all the best, and do well in your examinations also, and make the best use of this particular lecture. Bye. Take care.